Hi and welcome back. Let's talk about what is REST. And it can be a little bit confusing because REST is not a way to code your application or a way to create files and folders. It is a set of architectural constraints. When your API follows these constraints, then you can say it is a REST API. If you don't follow these constraints, your API may still be a useful API. It may be exactly the thing you need, but it isn't a REST API. Now, there's quite a lot of gatekeeping about what REST is and what a REST API is or isn't. And at the end of the day, it doesn't really matter whether your API is a REST API or not. As long as you understand the constraints and why they're there, you can choose to follow some of them or not. You can choose to follow most of them, and your API is still not a REST API if you don't follow all of them, but it can be more useful that way, maybe. So, what are the REST constraints? Well, the first thing is that in your system, you should use the concepts of client and server. Most web APIs do this, but what this means is you can't have a REST API between two Python files, for example, like we talked in the last video. That wouldn't make sense. It wouldn't be a REST API. The REST API should use the concept of a resource. We'll talk about resources in a moment. REST APIs should be stateless. They should be cacheable. They should have a uniform hypermedia-driven interface. Well, this is a bit of a confusing one. We'll talk about that more in a second. And if the backend system uses multiple servers, then the client shouldn't care whether there are multiple servers in the background or just one. Let's talk about these one at a time. What is a resource? Resources are just things that the API deals with, just like classes in object-oriented programming or rows in a database. Resources are what the API deals in. So posts, comments, likes, users, that kind of thing. When a client makes a request, they should make a request about a particular resource. For example, if they want to get information about a post, they should say which post. Or if they want to get information about all posts, they should say that. This is obvious. When you want information about a certain thing, you should say what it is. Part of this constraint is that when the server responds to a request, it does so with a resource representation. So if the client asks for post with ID 3, then the server will respond with something like this. This contains all the information that describes the post. And I apologize that I used ID 3 here, and this is responding with ID 123. That's just a typo. Okay, so what does stateless mean? It just means the server doesn't keep any information about the individual clients. Remember that when you code a REST API, you may have many clients. Let's say you're making an API for a game, and you've got all the mobile phones that are connected to your API, sending you requests, and you're responding to them. Each phone, in that case, would be a client. The server doesn't keep any information about the clients. That's something that helps define that it's a REST API. For example, let's say that the client wants to get information about post with ID 3, and then it wants to change the post's title. This should be, first of all, two separate requests, one GET and one PATCH. And in both requests, the client should say what post it's talking about. So we should change this slightly to say, get information about post with ID 3, change the post with ID 3's title to be something. So for the second request, the server can't remember that the first request was about post 3. That is what stateless means. In every request, the client has to send all the relevant information for the server to understand what's going on. The server doesn't remember anything about the clients. And the reason why this constraint is here is because if the server has to remember stuff about the clients, you are in a world of hurt in terms of the resources that you need in your server to remember all this stuff. And think about the disk storage that you'll need to remember everything that the clients have requested in the past, especially if you have a lot of clients. So being stateless makes the server much simpler, much more straightforward to code, and also performs much faster because you don't have to remember stuff from the past. What does cacheable mean? If one client makes a request for information, then it should be possible for the backend to save that response so that when another client makes a request for the same information, it doesn't have to be recalculated. Example, a client gets information for post with ID 3. The API will go into the database and will fetch that information from the database and then will respond with it. If another client makes that request, maybe the server doesn't have to go to the database again because it's got that saved in a cache. This is not at odds with being stateless because the server isn't remembering which client asked for the information. It's simply streamlining the process of retrieving information that was recently used. So a cache is normally another layer in front of your API that remembers requests and the response that was sent back to that request. And then if an identical request comes through, it can send that response without having to do any calculation. REST APIs should be cacheable, but that doesn't mean that you must use caching for your API to be called a REST API. It just means that it should be possible for you to add caching to your API if you wanted to. So that's a distinction there. What does hypermedia driven mean? This is the confusing one that most APIs don't implement. We will look at this towards the end of the course, how to add this to our API, but it's one of those that I think are more optional in most cases. If a resource is related to another resource, then in the response, in the representation of that resource, there should be an actual link that allows the client to find the related resource. So here you've got, for example, a post, and you can see there's a user ID. So presumably there is something in the API which is the user. This user ID is the identifier for a specific user. So we should tell the client how to get information about that user. So instead of this, we will do something like this. We'll include a user link, and then the client can make a GET request to this link and get information about the user with ID 3. This is what this hypermedia-driven constraint means. And I tend to not implement this in my REST APIs, which makes them not REST APIs. But I think that with good documentation, this isn't strictly necessary and it doesn't add anything to the clients, because in my experience, clients are not looking for links in the response to explore the API. Most normally, the developer reads the documentation and then makes the requests that they need. But nonetheless, this is a constraint. If you don't do this, then it's not a REST API. What does the thing about multiple servers mean? Well, in a REST API, you may use a layered approach to your backend. Sometimes our backends are made up of multiple servers. For example, you could have one server for posts and comments, and this is the server that receives requests and creates posts and comments and responds with data. And you may have another separate server for user authentication and registration. This is a way to implement microservices in your backend. The client shouldn't care that there are two different servers, one for one thing and another for another thing. The API should distribute these requests properly, and the client shouldn't be worried about how many servers there are or how the backend is organized. This is the final constraint in REST APIs. Remember that the API is the interface between the client and server. It isn't the actual processing and the work that goes in behind the scenes. So the API is just the requests, the responses, and the way the information is passed from one place to another. You may have many different servers and many different implementations for the work that actually happens when you receive a request, but that's not part of the interface aspect. And REST API defines how the interface should behave, not how the implementation or the architecture of your backend system should be done. So hopefully this helps understand what REST is and isn't, but I find that it doesn't really matter in most cases. As long as you're building an API that does what you need it to do, that solves a problem for you and your application, that's the main thing. You should understand these constraints and why they exist, because they help you make good decisions in your own APIs, but implementing REST to the letter shouldn't be a goal of your backend system in itself. Thank you for joining me in this video, and I'll see you in the next one. Hello and welcome back. In this video, let's talk about what is an API. An API is an application programming interface. So these are three words which on their own may be pretty understandable, but together doesn't seem to make sense. Let's talk about them one by one. An application, in terms of coding and software development, is just code that runs and does something. Programming, we know what it is, providing instructions to perform a task. So an API is going to be an interface for programming an application. But what is an interface? Well, this is where things get a little bit trickier. An interface defines how things are allowed to interact with each other. So an application programming interface defines how two programs are allowed to interact with each other. Let's delve into interfaces in a bit more depth. What is an interface? Well, let's look at a few examples. A car's interface, for example, are the steering wheel, the pedals, and the knobs in the dashboard. And this is the interface between car and driver. An interface is always an interface between two things. In a restaurant, the interface between the customer and the chef could be the server or the waiter. But what about a code interface? We're mostly concerned about code and software in this course. So what does a code interface look like? Well, here's an example of an interface. And in code, everything is made up of interfaces, as you'll see in a second. In this file, which I'm going to call the server, you've got _db. This is a database. And you've got two functions, add post and find post. Let's assume that because the _db variable has the underscore in front of it, you're not supposed to access that variable if you import this file. That's what the convention in Python means. So that leaves you with two ways to interact with the database by calling the two functions. So that is the interface to the database. In this file, you've defined an interface, which is the public-facing stuff that other files can import and use. And that's your interface. And in this file, which we can call the client, is using the database. And the way it uses the database, the way it interacts with the database, the way it gets the database to do what it wants to do is through the interface. And that's the two functions that are defined in the database file. Now, you could, in Python, import _db and do things that are not, quote-unquote, allowed by the interface, such as modifying an existing post or deleting a post. But the exposed interface, the thing that you are expected to use, does not allow that functionality. So what about a web API? Because that was an API in code, and now you know that everything in code has an interface. But what is a web API? Well, it's just like the code file, but instead of one file asking another to do something, you've got one program asking another program to do something over the internet. So instead of this message passing happening within a process between two Python files, you've got this message passing happening between two different programs in maybe two different parts of the world. And how these two programs communicate is by sending data over the internet, and that means sending requests and getting responses back. Here's an example of a request that a client could send to a server. Here you've got get and then /post/hello. This is a request made up of two parts, the method and the endpoint. And these are just pieces of data included in the request. Then the server receives this data, get and /post/hello, and it can do something with it, and then it can respond. Just like when one file calls a function and then the function does something, when the client sends a request, the server does something and then presumably returns a value or responds with a value. So what else is included in a request? There are a few pieces of data which are interpreted by the server however it wants. So the pieces of data are there in the request, and it's up to the server to get them and do something with it, and it can do whatever it wants. But there are some standard ways of interpreting certain pieces of data, and if you don't follow the standards, then that's going to be quite confusing. So the four pieces of data are the method, the endpoint, the body, and the headers. Here's a diagram I made that shows a bit more detail. You've got the HTTP request, and it's comprised of four different things. The method on the left can be one of many different values, but these values are essentially preset. These methods have meaning to most servers and clients, so usually servers will respond in a predictable way to each method. For example, the get method tends to be used to retrieve information, and the post method tends to be used to create information. Patch, for example, at the bottom tends to be used to modify an existing bit of information. If the server you write using FastAPI uses post to retrieve information, that's going to be weird and it's going to be unintuitive. And when you publish your API and you have clients interact with it, they're going to be confused, or the developers of those clients are going to be confused because your API is non-standard or follows non-standard practices. So getting your API to use the methods as they are normally used can be important. In addition to that, some methods have certain restrictions. For example, most requests can have a body, some data included in the request. But some methods don't support a body being sent. So you couldn't use a get method to send information to the server because it can't have a body in most cases. More on that in a second. The second part of information on a request is the endpoint, and that is where the request is sent. Let's say you've got a server running on api.com/post is the endpoint. So you would have api.com/post. That would be where the client sends the information, and /post can be the endpoint in that case. When the server sees that you've sent a request to /post, it can use that information to do something. For example, if you send get/post, maybe the server will be coded to respond with all of the posts that are available. That can be what that means, but obviously it's up to the server to be coded in that way and to respond with that data to that information. We'll talk about this in a second. The next bit is the body. This is usually JSON data. So when the client wants to send the server some extra information, for example, let's say you want to create a post with post/post, you would normally include some information like the post's title or the post's body, and that would be in the body of the request. So what is JSON? JSON is JavaScript Object Notation. It's a language agnostic where to share data. It's comprised of keys and values, and the values can be strings, they can be numbers, they can be lists, and they can also be other objects. So these things can be nested inside each other. We're going to learn more about this later on, but there's not much to it. Because it's easy to convert this whole thing into a string, that means it's easy to send it over the internet, and that's why we tend to use it to share data between client and server. Finally, you've got the headers, which is also information in key value pairs, but the keys tend to have specific meaning. For example, you've got the content type header, and you can say content type JSON, and that tells the server that the body is in JSON format. Or you could say content type HTML, and that would tell the server that the body contains HTML. So the headers are specific key value pairs that mean something. And these normally you can't just make up on the go, although there are ways to create custom headers as well, but we're not going to look at that in this course. The last bit of the endpoint that you see here is another way to send extra data, and that is as part of the URL. So you can say api.com/post and then sorting equal new, and that includes this query string argument, the sorting query string argument with a value of new. This just sends some more information to the server so it can do something with it. For example, if you were doing get/post sorting equal new, presumably that would return posts sorted by the newest posts first. But again, it would be up to the server to be coded in such a way that it understands what this means and uses it for sorting. We're going to look at how to add sorting in the course later on. So we've talked about APIs, we've talked about requests and clients and servers, but what is REST? Well, let's learn about that in the next video. I'll see you there. Hello and welcome to this FastAPI course for beginners. In this lecture, let me show you how to write a FastAPI app, and in the next lecture, I'll show you how to run it. I've created a project folder with Visual Studio Code, and you can see I've got a .vs Code folder inside it. This just contains some settings that I use for recording. Your project will initially be empty. To create a FastAPI application, we're going to first create a folder. I'm going to call it store API, because that is what our project is going to be about. It's going to be a stores and items REST API. Then inside this, we're going to create init.py, and we're also going to create main.py. Having the dunder init.py file inside store API will let us do things like from store API dot whatever import something. So basically it treats the store API folder as a Python package from which we can import. Inside main.py, we're going to put our FastAPI app. We put everything inside a folder so that we can have non-code files outside of this folder, but still within our project. For example, README files or configuration files for linters and formatters, etc. Let's open up main.py, and we're going to write a little bit of FastAPI code. From FastAPI, import FastAPI. This is always going to be the first line of a FastAPI app, because it imports the FastAPI object, which we use to create the app. And then we do app equal FastAPI, just like that. So that's it. This is your first FastAPI app. So it doesn't do anything. But if we wanted to do something, we just do @app.get, for example, and then we define a function that can return, let's say, a message. So there are a few advanced Python concepts already at play in this code, which is why I didn't want to go through app setup and writing the code in one video. We've got a decorator at app.get, and then we've got an async function. A decorator is a way to extend the functionality of a function. In this case, when we apply this decorator, it tells the FastAPI app that when the app receives a request, and that request is made at this endpoint, then this function should run, and whatever this function returns should be sent back to the client. A client, in this case, may be a website or a mobile app that wants to request some data from our API, so they're going to send us a request. For example, it might be going to api.com/, and in that case, this here is the endpoint that is receiving the request. When a client makes a request to this endpoint with our host, of course, and not api.com, then this function will run and we will respond with this dictionary. For a more in-depth look at decorators in Python, we've got a series of blog posts and videos that I'm going to leave linked. Async in front of a function just means that this function can run more or less at the same time as other functions. If any of the functions that we are trying to run at the same time do heavy computation, then they can't run at the same time. But if they are all just waiting for the client to send us some data, or they're waiting for the database to respond to our requests or things like that, then those functions can run in parallel, more or less. So that is where we get a speed benefit when we're using FastAPI and async functions. So that's it. This is your first FastAPI app. Now, in the next video, we're going to actually install the dependencies and run this app. I'll see you there. Hi and welcome back. In this lesson, we will learn how to set up our project for running the FastAPI app. One of the first things you need to do for almost any Python project is create a virtual environment. And in order to create a virtual environment, you need to have Python installed, of course. And you can install Python in a wide range of different ways, from the official installer to using things like Homebrew. And in my case, I recommend and like using something called PyEnv. You can get it on Mac, Linux, and Windows, and I'm going to leave a blog post linked that shows you how to get PyEnv in case you're interested. And what PyEnv does is it simplifies managing multiple Python versions in your computer. Once you have PyEnv, you can use it to select your local Python version. So in the console, making sure that I am in the folder that contains store API, we're going to do PyEnv local 3.11, and you can see that creates another file outside of our store API folder that is Python version. And here it just contains 3.11. What does this do? Well, now we can do PyEnv exec, and what that's going to do is it's going to allow us to run commands. And when we want to use the Python executable, it's going to use Python 3.11. So for example, I'm going to do PyEnv exec Python-V, and that gives us Python 3.11. That's because earlier I installed Python 3.11 So I've got that available in my system, and I can use it with PyEnv local 3.11. So how do we create a virtual environment? Well, we do pyenv exec and then python-m venv.venv. This is going to use the venv module that comes with Python, and is going to create a new virtual environment locally called .venv. The reason I call it .venv is because the folders and files that start with a dot are often hidden, and the venv is just not something that we need to see, really. It's all automatically generated. We don't have to go into it. We don't have to change anything inside it. So that's why I call it .venv. So it's hidden away. Now that the venv is created, you can do source venv bin activate. And on Windows, the command may be slightly different. For example, in cmd.exe, if you're using that, is venv /scripts /activate. And if you're using PowerShell, then it's venv scripts activate.ps1. These commands may change, so if you have access to the text for this lecture, which is available only on teclado.com, then you'll be able to see the text for each of the Windows consoles down below the video. After creating the virtual environment, we will install our dependencies. And you can do pip install FastAPI and all the other dependencies, but it's easier and more common to create a requirements.txt file. Again, this is outside the store API folder, and in this file we're going to put FastAPI and the Unicorn standard. These are the two libraries that we need for now. More will come later in order to run our application. And then back in the console, we do pip install -r requirements.txt. Now, once that's all installed, we can now run our application. But the first thing you want to do is when you open a Python file and then go to the bottom right, that your virtual environment is selected. So you'll see here Python 3.11 and the path is .venv bin Python. So that is exactly what you want. Now you can see that I'm getting some sort of error here from Pylance. Don't worry about that. We're going to change the way that the linter operates in a coming video, and you'll get rid of that error. Now the final thing that we want to create is a .gitignore file. And in here, we're going to add one per line the different paths and files that we don't want to include in Git. If you're not sure what Git is, don't worry. I'm going to leave a whole ebook that we've written on Git linked in the lecture text or in the resources section for this lecture. Basically, what Git allows us to do is track changes to our code over time, and we can link our Git repository with GitHub in the cloud to share those code changes over time with other people. That's super handy, for example, if you want to collaborate or you want to review somebody else's code. But there are often times where we want to skip some files that we may have locally and we don't want to put them in Git. And so for any file or folder that you want to ignore, you put it in .gitignore. There are a few things that we want to put here. I'm just going to paste them in. For example, .dsstore is a file that Mac creates automatically whenever you visit a folder with the Finder. So I don't want to include that because it doesn't do anything. Star.pyc will ignore Python compiled files. You don't want them because when you run the app, these get generated. So you don't need to share them with other people because they'll be able to generate their own very easily. Same thing with PyCache. It's a folder that gets created by Python automatically. Data files, the venv itself, we don't want to put that in. Our VS Code settings, any images that we may end up having. And finally, the most important file in here is actually this .env. .env files are usually used by web applications like this one to store secrets like passwords to services that we depend on or API keys, etc. We don't want to include that in GitHub because we don't want to give other people access to our secrets. We will cover this in more depth later on in the course, but it's important to have it in there. If you want to add any other things that you don't want to include in GitHub, then feel free to do so, just one per line. Okay, so now that all application setup is done, we get to run the FastAPI app. So we do unicorn storeapi.main, and this is targeting the package and then the file, and then :app. This is going to run the FastAPI app. Now, to simplify development, we can add the --reload flag so that whenever we make code changes, the app is automatically restarted. So we do that, and now the app is running. To test our API, we use a REST client like Insomnia, Postman, or even curl in the terminal. These allow us to make requests to our application and receive responses, so we can check that the application is doing what we expect. I'm going to leave a short blog post linked in this lecture to tell you how to set up and use Insomnia. It's really straightforward. You basically just install it, and then you create a project, and then you create a collection. And then in that collection, you can create HTTP requests. There's really not much more to it. An HTTP request is going to send that request to wherever we tell it to. And you can see here it's going to send a GET request because our FastAPI app uses GET. And we're going to give it the URL, which you can see here. It says Ubicorn running on http://127.0.1:8000. So we're going to copy that and we're going to put it in there. And then we're going to put our endpoint, which is just the /. And then we hit send. You should be able to see your message. In the next lesson, we're going to look at improving the developer experience by using a linter, a formatter, and an import sorter so that we can develop our FastAPI apps without having to worry about a lot of manual work when writing our code. Thank you for listening, and I'll see you in the next lesson. Hi and welcome back. In this video, let's make our life a little bit easier by adding a few tools to our project. But first, let me show you that when we made a request to our API in the last video, we got a line here in the logs telling us what we did. We did a GET request to the / endpoint. This is the HTTP version that we used, and this was the response, 200, which means OK. So all was good, and we returned the data that we expected. Now we're going to stop this application, and then we're going to create a new file called requirements-dev.txt. And in this file, we're going to add 3 lines: rough, black, and isort. Rough is a linter that is very fast, written in Rust, and it's a new linter and it works very well. Then we're going to add black, which is a code formatter. So whenever we save our code, black is going to process the code and change it so that it matches with a specific style. And finally, isort, which is going to sort our imports for us. Import sorting just means that when we have a lot of different imports, they're going to be sorted alphabetically and depending on whether they are imports from our own code base or from external libraries or indeed from built-in libraries. Now we're going to install the rough and isort extensions in Visual Studio Code. If you don't use Visual Studio Code, I strongly recommend you do so. Sorry, but the extensions are just really great and Visual Studio Code is a fantastic editor. So yeah, you can run rough and isort in the console if you don't use Visual Studio Code, but it's obviously much less convenient. Let's go over to the extensions section here in Visual Studio Code, and we're going to look for rough, and that's this extension here. So just install that, and then we're going to go with isort, and this one, you can see it's there. So just install them both and then restart your editor to make sure they are enabled. And that's it. Now let's go to our workspace settings. So you can open your workspace settings by going to Command-Shift-P or Control-Shift-P on Windows, and then go to Open Workspace Settings. Then under Extensions, navigate to Python, then scroll down a little and find the Formatting Provider, and you're going to select Black. Then we're going to go to the workspace settings, but in JSON mode. So this is the same settings, but in JSON. And you can open them with the little file with a wee arrow there on the top right. And you should be able to see just this one line in your settings. Python formatting provider is black. I've got a few others because they help me record, but you should just have this one. Then we're going to go to another line, making sure to put a comma at the end of it, and we're going to add a few other settings. These are available below the video on teclado.com in the transcript, and also I will have a JSON file that you can download that contains these settings. What these settings do is the following. This one makes sure that whenever you save a file in your editor, the file will be formatted. So imports will be sorted and black will process it and reformat it. Rough not organize imports false tells rough to not organize the imports, because it does so automatically. We're going to instead use isort. Then these square brackets with Python inside them say that these settings only apply to Python files. And here, when we save the file, we're going to organize imports and fix all the issues that we can. And that's because rough will help us detect some issues in our code, but it can also fix some issues if they are minor issues. And so we'll see that come into play later on. Now there's one more thing that we have to do for setup, and that is to create another file called pyproject.toml, and in here we're just going to put this. In square brackets, tool.isort, and then underneath it, profile equal black. And what this does is it tells the isort tool to format imports in a way that is compatible with the black tool. That way, there are no conflicts. Now, finally, what you want to do is pip install -r requirements-dev.txt. Make sure to install the 3 libraries, and then we can go ahead and test this out. So let's go to main. You can save this file and nothing should happen. But if we add another string to this JSON, and we're going to make it, for example, a long string, then almost instantly you should see it is reformatted to a style that black likes. The reason why it does this is so the line is a little bit less long, but it's not going to do things like split a string into 2. So although this line is still quote unquote too long, it is formatted in a slightly more readable way. If we delete that string and this comma, you can see that black reformats it so that it's all in one line. Here's another quality of life improvement you'll get. If we do import OS, just importing a library from Python, you can see we're not using it anywhere. So ideally, this should get deleted when you save the file. So let me save the file. And you can see it's not deleted. It has been sorted, which is good because that's isort working, but it hasn't been deleted, which is not good. That means rough is not working. In order to restart the rough server, you can go again with Command-Shift-P or Control-Shift-P on Windows, type rough and restart the server. Here it seems I'm getting an error, so let me just restart VS Code real quick and see if we can't get rid of it. So I've restarted VS Code, and now you can see that rough is working, even though we haven't saved this file yet and the import OS hasn't been deleted. You can see we've got the yellow squiggly line underneath, which tells us that rough is not happy because we've imported this, but we aren't using it. So let's save the file, and you can see that rough now deletes the import OS. So that's something that you can do, which should normally work. Rough restart server, you can see it works now. I don't know what happened there. And also isort formatter restart server, and you can restart them too if you get any issues with either one of them, because it means that something might have gone wrong, but restarting it usually works. Okay, so now that we've got these quality of life improvements, we are ready to continue in the next video and actually start building our REST API. So I'll see you there. Hi and welcome back. In this video, we're going to work on adding posts to a database using our REST API. We're going to start in Insomnia because I want to show you what requests will be made, and then we'll write the code to fulfill those requests. This is similar to doing test-driven development, which we are going to do from the next few sections. But for now, we'll just use Insomnia, and I'll focus on writing tests in the next section. So we are in Insomnia. We've created a new request. Now we're going to be sending post requests. Post requests are often used to send data to a server to create a resource in the server. In this case, the resource is a post. We're using a post request to create posts. That's not confusing at all. 127.1.1:8000, and then we're going to do /post. Then when we send this data to the API will expect us to send it also some information about the post that we want to create. So we're going to go to body, we're going to select JSON, and in here we're going to say body is, this is my first post, for example. What this means in API terms is we're going to ask the API to create a new post. For example, think of a Facebook post or a Twitter post. And the body of the post or the content of the post is going to be, this is my first post. Notice that you can call /post something else if you want. You can call the body field something else entirely. It doesn't matter. These two things here are customizable by us, the developers of the API. The post method, though, is not. So we're going to be using post for this because that is what's usually used for creating a resource. We will go into some other methods later on, but you should use the HTTP method that most often is used for the type of operation that you're performing. So for creating resources, we tend to use post. Okay, so when we send this at the moment, obviously it doesn't work because the app isn't even running, but it will later. We're going to call it create post, and then we're going to create another one, which is going to be a get, and it's going to go to the same place, and it's going to retrieve a list of all the posts that we have created. Get list of posts. And obviously this one doesn't work either. Okay, so these are the two things that we're going to have to create a post and to get a list of posts. Let's go to our application in main.py, and at the start of this video, we're going to do everything in main.py, and then at the end of the video, we will split it out into multiple files. I'll show you how to do that. We're going to do from Pydantic, import base model, and you don't have to worry about making sure this import is in the right place or whatever, because isort is going to sort it for us. Similarly, you don't have to worry about leaving new lines between the import and app equal FastAPI, because Black is going to sort that for us. Notice that if we save right now, the import goes away because we aren't using it. So just don't save until you actually are using the import. Or you can just write the code that uses the import first and then add the import later. Both are good options. Base model in Pydantic is a class that allows us to define a model, and a model is used to validate data. So what data are we going to be validating in our API? The data that the client sends us. So when the client sends us the body field of a post that they want to create, we need to make sure that the body field is there, it exists, that the body field is a string, for example. Those are two things that we have to validate with our model. So we'll do class user post in. This is a convention for data that we're receiving. What data is coming into our API? And this is going to inherit from base model. And then we define the fields that are in this model using Python type hinting. So we'll say body is a string. Now, when we create a new post in our API, we're going to give it a unique identifier. That is so that we can identify each post uniquely. So when we return data to the user, we want to include the body as well as the unique identifier we generate. So we'll say user post inherits from user post in, which means it has the body field and also an ID field, which is an integer. If you're not familiar with Python type hinting or Python object-oriented programming, I recommend checking out a more beginner course first, because this course is going to be a bit fast for you if you're not familiar with these concepts. Sorry about that, but there is just a lot to cover, and we can't cover the more foundational aspects of Python development in this course. Now that we've got our models, which are going to be used to validate incoming and outgoing data, we are going to create our database, which is going to be a dictionary. Later in this course, we're going to introduce SQL databases with SQLite and later Postgres, but for now, we're going to be using a dictionary, just for the next couple of sections. Then we're going to do add app.post, and we're going to create our create post endpoint. So this endpoint needs to receive the body field and needs to respond with the body and ID. We define the response model here. We say app.post / and then response model equal user post. And then inside the function definition, we will say what it's receiving in the body. So we'll say post is a user post in. FastAPI will automatically detect that post is a Pydantic model, and therefore it will come in the JSON body of the request. So even though our post request only contains body, it doesn't contain, post equal something, FastAPI knows that because user post in is a Pydantic model, this data here is the JSON body of the request. So FastAPI will automatically do a few things for us. When we receive a post request at /, it's going to check that the body field is in the JSON payload and it is a string. If it is, it's going to construct a user post in object, and it's going to give us that as the post variable. So now we'll be able to do post.body, for example, and that should be the body field in the JSON payload of the request. So if we want to turn it into a dictionary, which we do want to do, we'll say data is post.dict. Now we're going to see how many records we've got in our database, and we're going to do that with len of post table. And now we've got the body and the ID. So we'll say that new post is the existing data, which we're going to destructure with star data, and ID is last record ID. If you're not familiar with this syntax, I'll leave a link in the text of the lecture or in the resources section of this lecture. Essentially, this builds a new dictionary which contains all of the fields and values of the first dictionary, which is data, and also contains the ID field. Then we'll say post table last record ID equal new post. And we're simply using the ID as the way to find posts within this dictionary, so later on it's easier to retrieve individual posts. Finally, we will return the new post, which again is the body and the ID. All right, let's try this out. Well, it helps if you run the app first. So we'll go back and we'll say unicorn storeapi.main app reload. Make sure that it reloads when we make future code changes. Then let's go back in here and run it. And you can see we get not found. Notice that when I saved that, the application restarted, so that's pretty handy. We're going to try this again, and we get the body and the ID. You can create multiple posts, and the ID increases. Now, if we want to get a list of all the available posts, it's pretty easy. You can almost do it now with the knowledge you've got. The only thing that we don't know is yet how to populate this response model. And the response model, again, uses Python type hinting, so we say list user post. And here the square brackets tell Python that we are going to be responding with a list, and the list is going to contain user posts. So again, Pydantic and FastAPI are going to make sure that everything that we return from here gets converted to JSON correctly. And we'll say async def get all posts, and we'll simply return a list of post table.values. This is how you can get all the values of a dictionary using Python, and we're going to turn that into a list, and then Pydantic is going to turn that list of user posts back into JSON. So it's going to contain a dictionary of ID and body for each object. Okay, now if we go to get list of posts and we run it, you can see it's empty. That's because whenever we restart our application, which happens whenever we save a file, everything is deleted in terms of our data. Because our data is stored in a Python dictionary, well, it simply doesn't persist across reruns of our application. So whenever we save the app, it is lost. If we want to keep the data around, we'll have to use a database, which again comes later on. Let's create a post though, and then get a list of posts, and you can see that it is in there. If we create a few of them, and then we get them, you can see they're all there. Okay, finally, let's take a look at splitting this out into files, because that's going to be pretty important. We're going to create a models/post.py. So that is a models folder and post.py inside it. And in here, we're going to put our two models and the Pydantic import. Now in main.py, we're going to say from storeapi.models post import user post and user post in. In the next video, we're going to learn how to get this code out of main.py and into its own file as well, so that as we grow our API and have more endpoints, it's not very messy all in one file. So thank you for joining me in this video. I hope you've learned something new, and I'll see you in the next one. Hi, and welcome back. In this video, let me introduce you to API routers. First, let's go into storeapi. I'm going to create a new file called routers/post.py. Make sure that is a slash. And in here, we're going to just grab the entire main.py and we're going to paste it in. And then we're going to make a couple changes. First, we're going to get rid of from FastAPI import FastAPI. We're going to do from FastAPI import API router. And then instead of app equal FastAPI, we're going to do app equal API router. But instead of calling it app, we're going to call it router. And then we're going to go to our decorators and change that. An API router is basically a FastAPI app, but instead of running on its own, it can be included into an existing app. then it basically lets you use these endpoints in the original app. We're going to keep our database definition in here. We're going to keep our import, but now we can go back to main.py and delete our endpoints, delete the post table, delete these imports, and instead we're going to do from storeapi.routers.post import router. But because we're going to have a few different routers in our application, we don't just want to have this router name floating around in main.py. So we're going to do import router as, and we're going to call it post router. Now we do app include router post router. Now you can see that when I saved that, the app restarted and it is relatively happy with it. So let's go back to Insomnia, create a post, and it works. So that is how you use an API router. And now there's a lot of options for routers. You can do things like give them individually defined prefixes such as /posts/ create, for example. You can give them a prefix here like posts, for example. Now, if you do this, when we go back to Insomnia and we try to create a post, it doesn't work. But if you do /posts/post, then it will work because we've added this prefix to the endpoint, which is /post. Using these prefixes does sometimes allow you to simplify your routers a little bit, but we're actually not going to be using them in this course, but it's there if you want them. Okay, thank you for joining me in this video. I'll see you in the next one. Hi and welcome back. We're going to be adding comments to posts. So when adding a new feature to an API, the thought process is almost always the same. First, you think about what data your user is going to send you and what data you're going to send back. Then you think about what data you're going to store in your database. And finally, you create the interface with the user, the endpoints themselves. So for data, we're going to say that the user is going to send us the post ID and the comment body. And that's how we're going to relate comments to posts. And then when we respond, we're going to send them the comment body, the post ID that it is related to, and also a unique identifier for the comment. So let's create those classes. We're going to say comment in, it's a base model, and it has a body, which is a string, and also a post ID, which is an integer. Make sure that these two data types match. Then to get a comment out, it's going to inherit from comment in and is going to add an ID, a unique identifier just for each individual comment. And that's it. We've dealt with data coming in and out of our API. And this is one place where FastAPI really shines, which is the speed of development for adding new features is really high. Now, there's one more thing that we could add, and that is a user post together with its comments. We can add a user post with comments class that is a base model, and this has a post, which is a user post, and a comments, which is a list of comments. This is how you can nest models within other models. Now, when we respond with a user post with comments model in our API, we're basically going to be saying post is ID 0, body my post, and comments is a list of ID 2, post ID 0, body my comment. So this is the data structure that we've defined in here. Let me just reformat it in here using black. So the post contains user post, which has an ID and a body. And then the comments list contains comments, each of which has an ID, a post ID, and a body. So we're going to use this to respond to the user in some circumstances or with some endpoints. Let's go to our router and we're going to add a few things in here. First, we're going to add a table for our comments. Then we're going to add a function to find a post in the database. This is something that takes in a post ID and is just going to return post table.get post ID. That's it. Later on, we may change this to do a few more things. Now let's create an endpoint to create new comments. And it's actually going to be extremely similar to this endpoint here. So much so that in order to save you some time, I'm going to copy that, paste it in here. And now let's think about what we have to change. Well, we've got /post, so we're going to change that to /comment. The response model is going to be a comment. We need to import that. Instead of create post, it's going to be create comment. And instead of post user post in, it's going to be comment in. Now instead of post.dict, it's going to be comment.dict. And now we are going to get the last record ID, which is in the comment table, and that is going to create a new comment. And then we're going to go to the comment table and insert it. Finally, we're going to respond with a new comment. We do have to have these two imports. So we'll do comment in. Notice how they got resorted there by isort, very handy. Now, something that we may want to do is make sure the post for which this comment is being created exists. So we'll do post equal find post with comment.postID. And then we'll say if not post, we're going to raise HTTP exception. The status code is going to be 404, and detail, which is a message to be included in the error, is going to say post not found. We have to import HTTP exception, and we do that from FastAPI. Now we've got our error handling at the start, which is the common thing to do. You want to raise your errors as soon as possible. So you don't want to do any work if the post doesn't exist. Just find the post first and then do the work. Now the status code here, 404, means not found. And this is how we can return something that isn't the actual response defined in the endpoint definition. Normally, the response model is comment, and that tries to convert whatever we return using the comment model into JSON. But by raising an HTTP exception, we circumvent that use of Pydantic, and instead we simply respond with a message saying post not found and a status code of 404. This does remind me that whenever you create resources, the default status code is 200, and that's just not what you normally use for creating stuff. It's what you use for retrieving stuff. So the get endpoint remains the same, and the endpoints for creating get changed to status code 201. Let's add another endpoint to get the comments on a given post. So this endpoint will receive the post ID and will respond with a list of comments. But before we get into that, let me just show you how creating a comment works in Insomnia. You just send it to /comment and you include the body and the post ID in there. If we send this, we get detail 404 not found. We have to create the post first and then make sure to create a comment using that post ID. And now that works and you get 201 created. Excellent. Now to get the comments on a post, we're going to duplicate that there, get comments on post, and we're going to say /post /0/comments. This is going to be where we're going to make our request. And this should give us the comments of post 0. So how do we do that in FastAPI? How do we include that dynamic segment in the URL? Well, it's very straightforward. We say at router.get /post/ and then inside curly braces post ID, or you can call it whatever you want, /comment. Response model is going to be a list of comment. And then async def get comments on post, and it takes in a post ID, which is an integer. Up till now, when we've added a parameter to the functions, it has been a Pydantic model. And FastAPI knows that when we have a variable and it is typed as a Pydantic model, that's coming in the JSON payload of the request. But here, it is not a Pydantic model, and the name matches that of the dynamic URL segment. So FastAPI knows that the user will enter some value here that should be an integer, and its value will be passed to the post ID variable. What's this going to return? Well, it's going to go to the comments table and return everything that matches this post ID. So we'll say return comment for comment in comments table values if the post ID is equal to post ID. Here we've got a list comprehension, and I'm going to leave a resource for this if you're not familiar with list comprehensions. What it does is it basically grabs each of the values in this iterable. You can add an if statement at the end to do some filtering, and the filtering here is going to make sure that each of the comments post IDs matches the post ID that we've received. All right, let's try this out. We'll first create a post, then we'll create a comment, then we'll get the comments of that post. Oh, and I've added comments there. It should be just comments. There you have it, your list of comments. Finally, let's add our last endpoint, which is going to be get post with comments. So that is going to return the post and the comments. To save yourself a little bit of time, I've started the code here. We've got router get /post/ and then the post ID with a dynamic segment. The response model is user post with comments. We're going to import that at the top. Notice how now this is split out into lines. That's because it's getting a bit long, and this makes the lines a bit shorter. Then it's async def get post with comments. And again, we have the parameter just as we did up here for the dynamic URL segment. Then we're going to see if the post exists. And if it doesn't, we're going to return an error. Now, what do we return from this endpoint? Well, we know that user post with comments has two keys: post, which is something, and comments, which is something else. Now, the post, that seems straightforward. That's just the post variable that we've got here. And remember that inside the post field goes a post or a user post model. So we just include it there, just as we did for returning a post in here. This one is just the post itself because that's the user post model. Here, we've got the user post model related to the post field. So that's why we do it like that. And then in the comments, we are going to do await get comments on post. And that is this function or this endpoint that we defined up here, and we're going to pass in the post ID. So await simply makes sure that this function gets called and finishes running before continuing the execution of this line of code here. Remember that these async functions can sometimes be run in parallel, but in this specific case, you want to actually wait for it to finish. And that's it. This is how you can call one of these endpoints. You don't have to do any special thing with making a request to your API or anything like that. Just call the function and you can use it. Now, if you want Black to format this as 2 lines, which I would like, then what you can do is, instead of having to split it out into lines yourself, you can just put a comma at the end and Black will know, you want this to be split into 2 lines. So that's just a wee shorthand there to simplify your work. Let's try this out. We will create a post, then we will create a comment. And now we're going to get post with comments like that. And we will delete that bit there. And we get the post and then the comments. All right, so that's it for this video. I hope you've learned something and I hope you've enjoyed it. We'll soon be adding tests, user authentication, and relational databases. But for now, you've got a very good start on developing FastAPI apps. So thank you for joining me, and I'll see you in the next video. Hi, and welcome back. In this video, let's talk about Pytest. We've also written a totally beginner-friendly, comprehensive Pytest guide, which I'm going to leave linked. Now, testing is really, really important, especially when your application reaches the stage where you want to share it with users. That's because you don't want things to break. If you find a bug in your code, you don't want that bug to come back 6 months later when you forget about it and forget what code change caused it. Tests are mainly used so that whenever you find a bug or a potential issue, you write a test for it, and then every time you make code changes, you run those tests and you make sure that there is no regression in functionality and no regression bugs appear. Testing is normally not used to find bugs. It's just easier to do that by testing the API manually. And then when you find something that could be a problem, you write a test for it. Whenever we write code, let's say just one function, as you're seeing in your screen, it's easy to focus on just the one situation where you're going to use the function at this specific point in time. And when that happens, we tend to forget about what will happen when we use the function in other circumstances, and also on how the function operates with the data available in our program. What I mean to say is we may forget the function could be called with y = 0, and then that's going to raise an error. And problems like this happen all the time with all sorts of functions. You're writing your code, then you decide to take some code out and make a function out of it, but you maybe don't consider all potential scenarios for how that code could be used or how that function could be called. So writing tests as you go along helps you put yourself in this mindset of, what do I want this function to do given certain inputs? And that moves you from an implementation mindset to a mathematical mindset, inputs, outputs, and what could potentially go wrong. Okay, so let me show you a bit about testing. We're going to create a new folder called tests. And then in that folder, we're going to create init.py. This is necessary so that Pytest can see and discover the tests inside the tests folder. And then we're going to create test simple.py. Now, this test file is just going to be for me to show you a little bit about Pytest and how it works. In the following videos, we're actually going to be testing our API. So the first thing to do is go to requirements-dev.txt and install Pytest, and then do pip install-r requirements-dev.txt. When that's done, we're going to write our first test in test-simple.py. We'll say test add to, and Pytest works with functions. So there are a couple of things you may not have noticed but are important. First is every test file doesn't have to be inside a tests folder, but it does have to be called test underscore and then something, or something underscore test. But I like to put the test at the beginning. And then inside that test file, you're going to write test functions, and each function should test one thing. And that also should be called test underscore and then something. And that's how Pytest is going to discover what to run when you ask it to run your tests. Okay, then we're going to do x equal 1, y equal 2, and now we're going to use an assert statement. This is a part of the Python language, so it's not unique to Pytest. We're going to do assert x plus y equal 3. Okay, so that's our test. Now if you want to run the tests, you run Pytest, and you should see the output here, which tells you that in this file, storeapi/tests/testsimple.py, there is one test that passed. And that's what the dot means, and it says 1 passed. And really, with just this knowledge, which I know is not a lot, you can already start writing Pytest tests, as long as you're comfortable with Python. And the tests normally follow this sort of structure. You first define the data the test is going to work with. Then if you want to call a function like result equal call my function, whatever it is that you want to do. And finally, you would say check that the result is what you expect. This is a very common structure for tests. When we start testing our FastAPI endpoints, we're going to be doing that. We're going to be defining the data. We're going to be sending our API. Then we're going to make an API call. And then we're going to check that the response from the API matches what we expect. It's very simple. Let me write another test to show you how to work with dictionaries in tests. So I'm going to create test dict contains. And what this is going to test is that one dictionary contains certain values. And this is going to be useful because our API is working with JSON, and Python always treats JSON as dictionaries. So we're going to be doing a lot of dictionary comparison in our tests, and I just want to show you how that's done. So let's say that we've got a dictionary like this, A and B, and now we are going to make a call to our API, and we're going to get a response, and we want to make sure that A is 1 is present in the response. So we would say expected is A is 1, and we don't care about B is 2. So how do we check that this is inside this? If you're using Python 3, then you're going to do assert expected.items, and then we're going to do less than equal to x.items. This is going to check that this is inside this. Let me save that and run it, and you can see that both tests pass. I know the syntax is a little bit weird, but we're going to be using it a few times. What this does is it gives you a view into the dictionary, which is what items does, and then it just checks that that view is inside that one. Okay, in the next video, we're going to look at Pytest fixtures, which are ways to share data between tests without having to duplicate it in all your tests. That's how we're going to gain access to the FastAPI app. So let's continue in the next video, and I'll see you there. Hi and welcome back. In this video, let's talk about Pytest fixtures and how to start working with the FastAPI app in your tests. Whenever we want to use fixtures and we want to share those fixtures with multiple test files, in Pytest we create a file called conftest.py for, I guess, configure test .py, and in here we're going to write our fixtures. Now, in the last video I mentioned that fixtures are ways to share data between multiple tests. So we're going to import a couple of things and then we'll get going. We're going to import two things from the typing module so we can use type hinting with our fixtures, async generator and generator. We're going to import Pytest so that we can tell it which functions we're going to define are our fixtures. And then we're going to import test client from FastAPI.testClient. This is what will allow us to interact with our API without having to start the FastAPI server. And finally, we're going to import async client from HTTPX, which is what we're going to use to actually make the requests to our API. Then we're also going to import from our own code. So we'll say from storeapi.main import app, we're going to need this. And from storeapi.routers.post, we're going to import comment table and post table. Okay, so this is a lot of imports. I just wanted to show you them, but they are in the text of this lecture if you want to copy them. And then we're going to do a couple of things. First, let's create our test client. And this is what we're going to interact with instead of starting our FastAPI server. And we'll say def client, and this is a generator. And it's going to yield test client of app. So as you can see, this is just a function that yields the test client. Why do we yield instead of returning? Well, because in some cases you may want to do some work before yielding or after yielding. That's called setup and teardown. And using yield within a Pytest fixture allows you to do whatever it is getting test client, or whatever it is that you want to do before getting a test client. In our case, we don't have to do it, but it's there just in case. And I just wanted to show you that syntax. But this is just a function and it's not a fixture. I'll show you what is the difference and why a fixture is useful very soon. But in order to mark it as a fixture, we need to do Pytest fixture just like that. And the next thing we want to do is clear the tables. We want to clear the tables before we run any test. That way, all tests have empty tables to begin with, and we know that they're not going to be using data that maybe a different test created. And this is going to be called DB, and it's also going to be a generator. And what it's going to do is post table.clear, comment table.clear. Make sure you don't do post table equals something, because you actually do want to modify what you've imported. These tables are present inside the post file, and you don't want to be creating new variables or anything like that. Finally, we're going to yield. We're also going to mark this as a fixture so that it can be shared between many tests, but we want to make sure that this fixture runs on every test. And to do that, we do auto use equal true. This would be good to go while we use dictionaries for our database, but later on when we introduce a relational database, we're going to need this to be an async function. So let's turn it async just now because it doesn't change anything for us, but it will be more useful later on. And that's just how you do that. We'll make it an async function and we'll use an async generator. Now, as soon as we start using async functions in our tests, we actually need to do a little bit of setup. So let's create another fixture, but this time we're going to say scope equal session inside the fixture. And what this does is it makes sure that this fixture we're about to define only runs once for the entire test session. So for all our tests, this is only going to run once, and it has to be called any IO backend, and it's going to return async IO. This is just because when we use an async function in FastAPI, we need to have some sort of async platform that it runs on, and we're going to tell the FastAPI test system to use the built-in async IO framework for running our async tests. Finally, and I know this is a lot of setup, what we need is to use the async client. So we need to figure a way to actually make requests to our API when a test client is running. So here we've got the client, which is our API. Now we need to use HTTPX to make requests to the API. So we'll do pytest.fixture, and we're going to do async def async client. Remember, this has to be an async client so that the tests can all be async. And for FastAPI, that's going to be useful. It's not necessary at this point in the course, but later on it will become necessary. So that's where we're going to do it now. This is also an async generator, and then we're going to do async with async client app equal app and base URL equal client.base URL as AC yield AC. And what you've noticed here maybe is something a bit weird. Not the async with, although that's a bit weird too, and I recommend that you learn more about async development with Python if you're not familiar with what this is. But what's weird is this client parameter in this fixture. The client parameter will actually have a value that we don't have to give it ourselves. And that's bizarre in Python, because normally whenever you call a function like async client, you would give it a value for client. But in Pytest, this is how fixtures work. You've got your Pytest function, which is in this case a fixture, but it could be a test. Tests behave in the same way. And then as a parameter to the function, you put the name of a fixture, which is client. Remember, it's our fixture up here. And when Pytest runs the async client function, it will run the client function and give it its value. So that's a bit weird, but it is how the fixtures work. This is known as dependency injection. You name the dependencies and they get injected for you when you run the code. It's actually a really handy, although a bit confusing, way to work. When we start writing our tests, if we want to make requests to the API, for example, all we have to do is put async client in the test parameters, and this will be called and the value of async client will be given to our test. And this is why the DB fixture is auto use equal true, so that we don't have to put DB in every one of our tests as a parameter. This will become clearer when we start writing tests in the very next video. So thank you for joining me for now. I know this is a bit confusing. I promise it's all going to make more sense as we go on. So I'll see you in the next video. Hi and welcome back. In this video, let's get started writing tests. So we're going to go into our tests folder, then create a new folder, which I'm going to call routers. And in here, we're going to create init.py and also test post.py. Now, before we start writing tests, which we could do just now, but before we do that, let's write a function that calls our API and creates a post in our API, because we're going to be creating posts multiple times throughout our tests. It's helpful to do this, and also it'll be a nice introduction to how this all works. We're going to do async def create post. This is just a Python function. It's not a fixture. It's not a test because it doesn't start with test underscore. But it's going to take two arguments. Body is one of the parameters, and the async client is going to be another, and it's going to return a dictionary. Now let's import async client, just like that. And I've actually forgotten that we have to install HTTPX. So let's go to requirements-dev and add HTTPX in here. Then we're going to do pip install -r requirements-dev.txt, and that should be us good to go. Now in this function, we have the body of the post that we want to create. We don't care where that comes from. And we've also got the async client, which is connected to our test client. Remember that connection is done through here. We can do response equal await async client dot post, and we're going to do /post, and the JSON is going to be body is body, and then we're going to do return response dot JSON. Async client dot post submits a post request. This is the endpoint that it's going at. Remember, you don't need the rest of the URL because that's all already done for us. And the JSON is going to include this JSON in the body. And by using JSON equal, we already set the headers that are required for sending JSON, such as the content type. Now that we've got this function, we're going to create a fixture that uses the function. So we'll do pytest.fixture, async def, and we're going to call it created post. And this one also takes in the async client. But now notice that this is going to be a fixture. By the way, we need to import Pytest. This is going to be a fixture, so it's going to use dependency injection. Therefore, the value of async client is going to be injected dynamically. The first thing that Pytest is going to do is it's going to look within the current file to see if there is a fixture called async client. But there isn't one. So then what it's going to do is it's going to go into routers and see if there is a conftest.py file there. If there was, it would look in that file to see if a fixture called async client is defined. But we don't have conftest.py inside routers. So then it goes to the parent tests and looks at conftest.py there. It's going to find the async client fixture. So it's going to call it and it's going to give us the async client. And that's the value that we're going to get there. We can do return, await, create post, test post, for example, and async client. That's it. We've got our post. But now this fixture is not marked as auto use equal true, because what we want to do, and the reason why we call this fixture created post, is because now when we write test post something, we're going to do this in the next video, we can put in here created post. And now this test has already created a post and we have access to the API response in here. The reason why we call it created post is because by the time this test runs, the post is already created. It should already exist. This naming convention allows us to really read these tests very easily. Okay, so we've created our fixture and we've written our first interaction with our API. Now in the next video, let's write our tests for the post section of our API. I'll see you there. Hi and welcome back. In this video, let's write some tests for our post endpoints. First, let's begin with testing that we can create a post. When we create a post, we're going to be sending this request, essentially. We don't want to use our fixture when we're testing creating a post. We only want to use our fixture when we're testing things that require a post to already exist. Let's start with testing the creation of a post, and then when we are retrieving posts, we will use our fixture. To write a test, we'll do async def test create post, for example. This is going to get the async client. Then we're going to define our data. For example, the name is going to be test post. Now we're going to say that response is await async client dot post. We're going to trigger post and the JSON is body. Then we'll say assert response dot status code is 201. I called this name, but this should have been body. Sorry about that. Then we'll say assert ID is 0, body is body. Dot items, remember we did this at the beginning of this section, response.json.items. So we're going to write that this is expected to be in the response JSON. The reason why we don't use equal is because later on, if we want to add something to this JSON that is irrelevant for us, because we don't really care, for example, if we want to add a list of comments or something, the test should still pass because it has been created, the response is 201, and you've got an ID that's been given to you. If more things are added to the response in the future, we don't necessarily want to change our test. This makes the test a little bit more resilient rather than using equal. Okay, so if we save this and then we try to run, you'll see that we get an error. Well, not an error, but a warning, and the test was skipped. It says you need to install a suitable plugin. We already have any IO. If you remember in conftest.py, we got any IO backend defined there. But for every async test, we need to tell Pytest that this should use the async backend or async platform that we've told it to. So in this case, we're going to use any IO. We're using any IO, by the way, because FastAPI uses any IO, so it already comes installed. We still have to tell it that the async tests need to use any IO. The way we do that is at pytest.mark.anyIO. Now we can run the tests again, and you should see it pass. As you can see, this is doing what we were doing with Insomnia, but now we don't have to do it with Insomnia. We can just run our tests, which is much faster. Okay, let's write one for creating a post, but we forget to pass the body. I would recommend that you pause the video and try it yourself. See what happens see what the response is, write the test that makes it pass. So I would start with Pytest mark any IO, then async def test create post missing data. Long test names are okay because they are descriptive and they're going to help you understand what went wrong when tests fail. Then we're going to have our async client. And now we're not going to have any body variable. We're just going to do response equal await async client dot post. Into post, the JSON is going to be empty. We can assert response status code equal 201. Okay, so 201 means created. Therefore, this test should fail because when you try to create a post but you don't give it a body, the post shouldn't be created. Let's run our tests, and you can see that it does fail. And with Pytest, you get a pretty nice error message here. You can see that we went into this assert, we said response status code is 201, but really after the variable's resolved, this is what we're asserting. Assert 422 equal 201. And actually, 422 is not equal to 201, so that's why this test failed. So the status code that came back from trying to create a post with no body is 422, unprocessable entity. Wait, did we raise this failure somewhere? Well, no, we didn't. We tried to create a post, but we have post is user post in, and Pydantic is automatically validating our data and returning the error if the data is invalid. So we can just change the number there because this is the number that we want in this test. When we send an empty JSON, we want to get a 422 back because it means that the API is working as we expect. Running the tests again now makes them pass. All right, let's write a test for getting all posts. Again, Pytest mark any IO, async def test get all posts. Async client is async client, and now we're going to use our created post, which is a dictionary. The reason for that is because now we're retrieving posts. We don't want to create a post first and then run our test. We want to use a post that's already been created. Now remember how Pytest works with fixtures. We put the fixture name, and then Pytest is going to look in the current file for a fixture called created post, which exists. So it's going to call it, and that's going to make a request to our API, and it's going to wait for the API to respond, and then it's going to return the JSON response that came back from the API, and that's what we're getting here. If we have some sort of error in our API that prevents us from creating posts, then you'll get an error here. If the API works as expected, which we know it does because we've tested it, then you should get the JSON response from the post. We can do now response is await async client get /post, and this is going to give us all the posts in our database, which we know is only one post, the created post. How do we know there's only one post in our database at this point? Because we have an auto-used fixture here that is clearing our tables before every test function. So the databases have been cleared, and then our function runs. So we know the databases were empty before the function ran. We created the post, and we only have one post in the database. We'll say assert response status code equal to 100. Now we're going to do assert response.json is equal to, inside the list, we're going to put our created post. All right, let's run these tests, and all tests pass. Let's say you don't put the list because you forget to. If you run the tests, now you can see the diff in the data. You asserted that this here should be equal to this there. Obviously it isn't, and you can use -v to get more diff. So let's do that. Run pytest -v. And now you can see that the difference is that this list here was on the left side, but not on the right. So we have to put our list there. I don't recommend using -v all the time. You just don't need it most of the time, but it's there if you want more information. Pytest is really good at showing you what's going on. When you run the Pytest command, you can also pass it other flags such as --fixtures. And this is going to show you all the fixtures that are available in your tests. So you can see there's quite a lot of them. A bunch of them are built in. Essentially, they come with Pytest. You've got cache and various other things that you can use. Then you've got your fixtures defined from the Pytest plugin, and that is any IO that comes with FastAPI, and you've got those. Then you've got the fixtures defined in your conf-test.py, and finally you've got the test post in there. You can also do pytest -- fixtures per test, and that tells you for each test which fixtures it used. So you can see it used async client, any IO backend, client, created post, and DB, even indirectly. DB is used by all tests because it is auto-use equal true. But again, normally you'll just be doing pytest. You can use those other flags if you want to see more information, or maybe if you try to use a fixture and it gives you an error that it doesn't exist, maybe you can use that to figure out what fixtures are available. Okay, thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi and welcome back. In this video, let's take a look at writing the rest of our tests for our endpoints. We're going to start by creating another function to create a comment. So we will just copy that one, call it create comment. It will take in the body, the post ID, and the async client, and then it's going to send a post request to /comment with a body and a post ID, which is the post ID. Now we'll create another fixture similar to created post for created comment, and it just calls create comment. But in order to create a comment, we need a post to already exist. So we will add this fixture as a parameter in this fixture. So we'll say created post, and now we can give it test comment string for the body, the created post ID, and the async client. Okay, now let's write some more tests. We're going to start with testing that we can create a comment. So again, we're not going to use our new fixture for this test, but we will use it in a moment. So we'll say pytest mark any IO, async def test create comment, and it's going to take in the async client as well as the created post. Then the body is going to be test comment. Then we'll make our call to /comment and pass our JSON just as we did. The body is body. The post ID is the created post ID. Then we'll assert that the response status code is 201. Finally, we'll assert that the following is inside the response. The ID should be 0. The body should be the body, and post ID should be the created post ID. Then we do items less than equal to response.json.items. All right, let's run our tests. You can see that we've got an error, which is fine. That's because here post ID is create post, but it should be created post. There you go. Let's run them again, and now they all pass. Okay, now let's see if we can get the comments on a post. If we go to our router, we're gonna grab this endpoint. Again, pytest mark any IO, async def test get comments on post, for example. And now we've got the async client, we've got the created post, and we've also got the created comment. I'm splitting this like this. This is the way to do it with Python when you have a set of parameters that is very long. We want to check that the created comment comes back when we check on the comments for this post. Response is await async client dot get. We'll say /post /created post ID /comment. We'll assert that the response status code is 200. And the response.json is equal to created comment, like that. Let's run our tests, and it passes. So that's brilliant. You could also write another test for getting the comments on a post, but there are none. And in that case, you would just copy, paste this, but delete created comment, leave the JSON empty, and call it like that. And you have another test there. Okay, that's also an option there. This is something that is a bit of an art when it comes to testing, which is how many tests do you write? Do you write a test with one created comment? Do you write a test with no created comments? Do you write a test with 2, with 100 created comments? And this art is called boundary value analysis. which is part of your job as a tester or as somebody who's writing tests, is to find what the boundaries are for the values that you want to test. For example, if you try to get the comments on a post but there are none, should the API return a 200, or may it return an error because you tried to get the comments but there aren't any? Maybe it returns 404, no comments found. All of these subtleties are things that you have to keep in mind to decide if you want to write a test for getting comments but there are none. That would be the boundary. The boundary is between 0 and 1. Then you can assume that if you've written a test for 0 comments and 1 comment, that 2 comments is going to behave in the same way as 1 comment. You can assume that, because if not, you'll end up writing a million tests, one for each number of comments that is possible. And Pytest does have a way of parameterizing your tests to make it easier to test with multiple different inputs, but we're not going to get to that in this course. I do encourage you to learn about it though, it's pretty interesting. Okay, so now that we've got that, let's see if we can get the post and its comments with our last endpoint. So we'll do pytest mark neio, and again, async def test get post with comments. We've got the async client, we've got the created post, and we've got the created comment. Now we'll make our request to the post ID, post/post ID. Let's check the status code is 200. And then we'll check the response is what we expect. We'll say assert response.json is equal to post is created post, and comments is a list with created comment. Ooh, make sure to not do what I've done just here and call them created. But yeah, this is what the function should return, so we can check that. And you can see that it passes. There is one more test we could write, which is to try to get the post with comments when the post doesn't exist. So I'm just going to paste it in here because it's pretty straightforward. We define our decorator, then our test, and that's get missing post with comments. And here I'm going to add these 2 fixtures so that a post and a comment do exist. And in my opinion, this makes it clearer that we are getting a post that hasn't been created. Even though other posts exist, this gets one that doesn't exist. And then the response should be 404 in this case. So save that and run our tests again. And now we get 8 passed. This is basically what we were doing with Insomnia, but we were doing it manually. We were clicking on create a post, see what comes back. Then we were going to click on create a comment, see if that works. Then we're going to get the comments and see if that works. But we're doing it in a way that once we've got our setup done with our fixtures and our functions, it's super easy to write a path for our tests, which with Insomnia wasn't that easy, and it could get a bit convoluted to run all these tests manually, because you'd have to create a post, then create a comment for that post, then check the comments are back, then delete it and see if it comes back when it's empty. It's much easier to do with code once you've got it set up. So in this section, I just wanted to show you how to get started, how to set it up. Now, as we go along with the rest of the course, we're going to be writing tests together with the code, because that's what you should do normally. In doing so, you're going to understand a bit better how each thing works, because we're going to write tests for those things while we write the code. So hopefully you'll find that interesting and enjoyable. Thank you very much for joining me in this section. I hope you've really enjoyed it, and I hope you've learned something. Thanks again, and I'll see you in the next video. Hi and welcome back. In this video, let's talk databases. There are 2 main ways to talk to a database: by executing queries against it manually, or by using an ORM. Neither is necessarily a better option, it just depends on what you're used to and what you find easier to write. In this course, we won't be using an ORM, because I find that directly executing the queries is much simpler. With that said, we won't be writing any SQL code ourselves. Instead, we'll use the encode/databases library to help us do so. There are a few different libraries for talking to databases, but because FastAPI is an async framework, we want to use an async database library. I found that encode databases is a great easy to use option. Also, it uses SQL Alchemy in the background, so we know it's building on a very popular and well-tested library. Let's go to our requirements.txt file and add our two new requirements, SQL Alchemy and databases AO-SQLite. These are what we'll need to talk to a SQLite database asynchronously. Instead of AO-SQLite, you can use async PG to talk to a PostgreSQL database. Install the requirements, making sure you've activated your virtual environment first. Now we're ready to start integrating databases into our application. We've got a few things to do. One of them is we need to provide our application with a database connection string. This is a secret string that includes the database location, username and password if needed, and some other information. In the next video, we'll look at how to give that to our application while allowing the connection string to remain a secret. That's important as we don't want the connection string to be stored in our code, just in case we want to share the code with other developers in the future. Thanks for watching, and I'll see you in the next video. Hi and welcome back. In this video, let's talk about config files and environment variables. Environment variables are variables whose value is set before you run your Python program, but outside of the code itself. We can set the values using the console, and then in the Python code, you can get their value with the OS module. The key benefit of using environment variables is that the value is not stored in the code, but we can write code that requires the variable. For things like secrets, we don't want to store them in our code just in case we want to share the code with other developers later. While developing, we often create a file called .env and put our environment variables and values inside it. And we will never share this file, so make sure it's in the gitignore file. Then create another file called .env.example and put just the environment variable names inside it. We will share this, and it tells other developers who want to run our code that they have to create a .env file with these variables and give them values. To read environment variables from the .env file, we'll need to install the python-env library. Go to your requirements file, add it there, and then install the requirements before continuing. Let's create a config file using Pydantic that reads from the .env file. Let's create config.py inside our store API folder. Then from Pydantic, we'll import base settings. Now we'll write a class which inherits from base settings, and inside it, we'll define another class which is used to configure it. Inside the config class, we'll add an env_file field, which is the name of our .env file. This is how we tell Pydantic to load a .env file to populate configuration variables. But we haven't told it what configuration variables it should look for in the .env file or what configuration variables will exist in our application. To do that, let's create another class which inherits from base config this time. In it, we'll just define the config variables. These will be read from the .env file if they are there, and otherwise the default value will be used. We want to allow Pydantic to not read the database connection string, so we'll mark it as optional in order to give it a default value of none. To do this, we also have to import optional from the typing module. If we didn't do this, then its default value should be a string. For each variable, we define the name, then its type, and finally the default value. The dbForce rollback variable is used so that at the end of every database transaction, the changes aren't written to the database and instead they are deleted. This will be handy for when we write our tests so that after every test, the database is cleared. For now, we'll set it to false, and I'll show you how to set it to true for your tests later. When we come to deploy our application, we'll be giving the Cloud Deployments service a copy of our code, but we won't be giving it the .env file. Instead, we'll tell the Cloud Deployment Service what environment variables we want to create. It's straightforward. I'll show you how to do that when we reach the deployment section of this course. That's it for now though. Thank you for watching, and I'll see you in the next video. Hi and welcome back. Now that we've got our config file, we need to be able to have different configuration values when we're developing locally, from when we deploy our application, or even from when we run our tests. To do this, we're going to introduce another environment variable that tells our application what environment it's in. So we'll say env state, and that's going to be an optional string, and it's going to default to none. And what this is going to do is we're going to be able to put in our .env file a value called env_state, and we're going to be able to assign it a value of either development, production, or testing. And then we're going to be able to select different configuration variables depending on which environment we're in. So to do that, we'll now create 3 subclasses of global config. We're going to say dev config, and that's going to be a subclass. Then we're going to have test config, and also I'm going to put it in here, prod config. And there's no reason for the order of these classes. It's just what I've got in my notes and what you're going to see in the code if you check out the code for this lecture. So I just want to keep things the same, but obviously the order of these classes doesn't matter at all. You can put them in whatever order you want. Each of these is going to get its own config class. So let's do it with fconfig. We're going to put a config inner class, and in here we're going to say env_prefix, which is a string. It's going to be dev underscore. Okay, what this is going to mean is in our .env file, we're going to prefix all the variables, which are these two for now, with dev underscore. And then that's going to populate those environment variables if we use dev config. It'll all become clearer in a moment when we actually start using these. So I'm just going to copy paste that config class into these and call it prod and test underscore. If we go to our .env file, you can see we've got database URL. The first thing we're going to do is add env state and make it dev, because whenever we're working on our application, such as we want to run it and we want to interact with it locally, we want to develop with it, we're going to be running it in development mode, not in production mode or in test mode. And then what we have to do is we have to say dev underscore database URL and give it the value. Now, what this is going to do in a moment when we finish wiring everything up, which it isn't wired up yet, Pydantic is going to look at dev underscore and is going to strip it out and use the rest of the variable name to populate these configuration properties there. So as well as dev underscore, we can do test database URL, and we could do SQLite test.db, and we could also do prod database URL, but you almost never want to do that because very seldom you're going to be connecting to your production assets from your local environment. It's just a bit of a dangerous thing to do. If you make a configuration mistake, for example, and you leave DB force rollback enabled, when you connect to prod, you could end up deleting stuff, or if your code has a bug because you're still developing it and you connect to prod, then you could end up deleting prod assets. Really, connecting to prod, it's not something that you're going to do. Let's get rid of it. We don't want to accidentally connect to any production database. Now, our test-specific variables are never going to change. We are not going to have a username and password, for example, in our test database. So it's not something that we want to hide from our code, because we can add this database URL to our code. We don't have to add it to the git ignore, for example. However, our dev database URL, which will probably connect to a PostgreSQL database somewhere in the cloud in the future, is something that we will want to hide. And we may want each contributor to our code base to generate their own database and use that. So that's the difference between development and test. The test variables are probably never going to change, and they are not secret. Whereas the development variables will be unique to each user that's using the code. So what does that tell us? Well, it tells us that we don't actually need to put these in the .env file. Instead, they can just be hard-coded in our code. What we're going to do is we're going to go to test config down here, and we're just going to copy these two values from global config, and we're going to overwrite them. So database URL, we're going to delete the type hint because it's already inherited from the base class. It's going to be SQLite test.db, and db force rollback is going to be true. That means we don't have to pollute our .env file with values that are never going to change. And when a new contributor downloads our code and wants to run the test, they don't have to remember to set the values in the .env file. They can just run the test straight away. However, If you want to overwrite the values, you can do so by putting new values in the .env file, like test db force rollback. You can set this to false. Not that you would want to do that, but this is how you can overwrite the values. So the ones in config.py are like the defaults, but they can be overwritten. So this is why we've done all of this. Just a reminder that this is okay to go in the code because it doesn't have a username or a password and is automatically generated by our code. If you wanted to use a cloud PostgreSQL database for your testing, then this would have to go in the .env file and you wouldn't put it in your code because your code may end up being public or other people may see your code. You don't want to share your secrets with other people. Okay, so now that we've got our multi-environment configuration set up, we're ready to move on to the next thing. So I'll see you in the next video. Hi and welcome back. In order to calculate the correct configuration that we want to use based on our environment, we're going to write a function that takes in the value of the env state variable and then returns the appropriate config class. There's no magic going on here, but there is something a little bit weird, which I'll show you in a second. So this is a function that simply takes in the env state, which is a string, and it's going to do configs, and it's going to create a simple dictionary of configurations so that it's a bit easier to retrieve. This is a very common technique. Then we have our configs, and then it's going to return configs, env state, and it's going to create the object. Configs env state means that if env state has the value of dev, then this access will give us a dev config class. And then we're going to create an object of that class. How do we get the current value of env state? Well, the current value can be gotten with base config, which needs to be an object, .env state. And what this does is it actually loads the .env file. It's going to load the .env file, and because this class only has the env state variable in it, then it's only going to allow us to get that value from the .env file, and it's not going to look at any other variables that may be prefixed with dev, prod, or test. This is how we get that value. How do we get the config? Well, we'll say config is getConfig, and we pass in the value of env state. Doing it this way, putting the env state outside of everything else, means that we don't have to prefix it with dev, prod, or test, which would defeat the point of it. This definition there cannot go into dev config, prod config, or test config because these define the env prefix, which means that all of these values are only populated from the .env file if they have that prefix. So that's why env state has to go up here. For any given environment, such as when we run our code, we are never going to want the configuration to change. So getConfig can be called once and then it's never going to change. So it's always going to return the same object. We don't want to reread the .env file at any point or anything like that. What that means is once we call getConfig with a given env state, that's it. The next time we call it, we don't want to rerun the function. We just want to get the same value that we got last time. So this function is a prime candidate for caching. And caching allows you to improve the performance of your code. You're not going to improve the performance of the code much by caching this function, but I want to show you how to do it. And it also tells us as readers of the code that this function always returns the same thing, basically. So how do you cache a function in Python? Well, we go up to the top and we're going to say from functools import LRU cache. And if you save, it goes away because we've got the rough automatic fixes going on. So let's not save that yet. The least recently used cache. What this does is if you set a max size for the cache, which we're not going to do, but if you did, then that cache would store up to the maximum size of calls, and then it would start to recycle space. In our case, because this function will only ever get called with one env state in our application, we don't really need to give it a maximum size. All that we have to do is LRU cache, and that's it. So now we can save this. That gets resorted, which is good. And now when we call this function with, let's say, dev, then the LRU cache will add the dev argument to its cache and the return value of the function. And the next time we call the function with the dev env state, it will reuse the value that it returned the first time. Again, it's not going to improve performance in this application because this isn't a very computationally heavy thing to do, but nonetheless, I wanted to show you how it works. It's something that I do use quite a bit, especially when writing functions that do take a little bit longer. Okay, thank you for joining me in this video, and I'll see you in the next one. Hi, and welcome back. We've got our application config set up, so now we are ready to connect to a database. For now, we're going to connect to a SQLite database, but later on in the course, we'll use PostgreSQL. And no code changes should be required when we do that. That's because to define our database, we're going to use SQL Alchemy. So let's go to Store API and create database.py. And here we're going to use SQL Alchemy to define the database schema, or the structure of tables and columns that our database is going to use. To actually connect to the database and interact with it, we will use the databases module, which we've already installed. And that uses SQL Alchemy behind the scenes, but it makes it a bit easier to interact with the database in an async way. Also, I really like the API that the databases module exposes for us to talk to the database. I find it's very clear to see what we're doing with the database. You'll see it in a moment. So to begin, we're going to import the databases module. Make sure to import databases and not database. That would try to import yourself or the current file, and that would be very weird and you'd get an error. Import SQL Alchemy as well, and we're going to do from config import config. And it's interesting and important to remember that this is the first place in our application that we're importing the config variable from our config module. And as you know, Python runs the module when you import it. So this is going into config.py and running the config module, which calculates the current config. So that's going to read your .env file and get you the appropriate config for the current environment. Just something to remember, because it is at this point that the value of env_state matters. It's going to give you one database or another. Now, we're going to define the metadata variable, and this is what stores the information about our database, what tables and what columns we want to create. We do SQL Alchemy.metadata, just like that, and we don't give it anything. This gets assigned a value, or this gets given information about our tables and columns in a moment. And then we do engine is SQL Alchemy create engine, and now we're going to connect. So we do config.database URL. Remember that config is an object of our config class, and these all have a database URL provided by global config overwritten in test config, but otherwise it will be coming from the .env file. Something else that we need is connect args check same thread false. This is only needed for SQLite, because SQLite traditionally runs single-threaded, and this is going to allow us to connect to it from multiple different threads, which FastAPI can use for things like background tasks and stuff like that. This is not necessary just yet, but it's going to future-proof, because at the end of the course, we're going to talk about background tasks, and that's going to use multiple threads. Okay, now in between these two, we're going to create our tables. But before we do that, let me just show you how to tell the database to actually create the tables and columns in the database server. You just do create all and you give it the engine. And then we will do database is databases.database config.database URL, and force rollback is config db force rollback. Okay, this is the setup that we need for our database. Again, the metadata object is going to store information about our tables and columns. The engine is just what's going to allow SQL Alchemy to connect to a specific type of database like SQLite or Postgres. Metadata.createAll with the engine tells the engine to use the metadata object to create all the tables and columns that the metadata object stores. And finally, the database variable uses the databases module to actually give us a database object with which we can interact. So the SQL Alchemy side of things is used for creating the database. The databases module is used for connecting to the database, and our code will use it to interact with the database. Okay, so let's create our tables, or let's define our table structure. We're going to have post table, and this is going to be SQL Alchemy table. And this takes just 3 different kinds of thing. First is the table name. You can give it whatever you want. I'm going to say posts. Second is the metadata object, because this is what SQL Alchemy is going to use to, again, store information about this table. We need to give it to the post table, not only so that the create all call creates the correct table, but also so that if we have any relationships between our tables, they can be validated. Finally, it takes a bunch of columns, however many columns we want, and we're going to give it an ID, which is an integer, and primary key is true, and this is how we define an integer primary key column. This is going to be auto-incrementing in most cases, and we're going to define the body, column, body, SQL Alchemy string. In any of these, you can pass a value to the constructor, and then that lets you define a maximum size for that column, but we're not going to do that. There you go. This is our post table. Now let's create our comments table. Again, comments is going to be the name of the table when it gets created in our database server. We pass the metadata object, and these two are going to be created together, and we're going to be able to validate the link between the two. And then we're going to have 3 columns. The first 2 are actually the same as this. So let's just copy them. We've got an ID, which is a primary key, which is an integer, and we've got the body, which is a string. But then we need to relate these comments to posts. So we'll do SQL Alchemy.column, post ID, SQL Alchemy.foreign key, and then we tell it what table and column to target. We say like that. The foreign key receives a string, which has the table, then a dot, and then the column name. So that's that one over there. Now, we don't need to give it a type of SQL Alchemy integer, because SQL Alchemy is automatically going to use the metadata object to detect the target column's type and use the same type for this. Finally, we're going to say nullable equal false, so that the post ID column must have a value. If it doesn't, then the comment wouldn't be related to any post. It would just be what we say is orphaned. It doesn't have anything that it is related to. And therefore, our application would never be able to retrieve a value for the comment in question, because we don't have any code in our application that retrieves comments by ID. We always retrieve them by post ID. We want to make sure that these always have a value. Okay, so with this metadata.createAll line in here, as soon as we import database.py in any of our files, we're actually going to create the tables and the database file. We are not doing that just yet. As you can see, we haven't imported this anywhere. We're going to do that in the next video. So thank you for joining me, and I'll see you in the next one. Hi, and welcome back. In this video, we're going to connect to our database. We want to ensure the connection to our database starts before we respond to any requests that may want to use that connection. To connect to a database is not just to send some code to the database asking it to retrieve some data or to insert some data into any table. We actually have to establish a connection. Doing that is very straightforward. You just do database.connect, but we have to do it before responding to any requests, so that when we are in a request, we don't have to think about whether we have connected to the database or not. We're going to do it in main.py, and we're going to use the FastAPI lifespan attribute to do that. The first thing to do is we're going to say from context.lib import async context manager. And then before we define our app variable, we're going to say at async context manager, and then async def lifespan. And this takes in the FastAPI. And then all this is going to do is await database.connect, then yield, and then await database.disconnect. And we are going to do from storeAPI.database import database. Okay, save that, and that gets reformatted. Again, when we run from storeAPI database import database, that is going into database.py and actually creating our database and everything that goes with it. When that happens also, that goes into config and actually reads the .env file and populates the environment variables in our selected config class. There's a few things going on. Database goes to config, config goes to .env, and then we get the values back. Eventually, we end up with our database. Okay, now what does this do? what is a context manager and what is an async context manager? A context manager is basically a function that does some setup and some teardown, and in the middle it pauses execution until something happens. If you're not familiar with async, await, and the yield and yield from keywords in Python, we're not going to get into that in this course because it is a fairly complicated subject, but that is what it means. This function can run this, and then it stops running until FastAPI tells it to continue, and then it runs that. Now, when does FastAPI tell it to continue? Well, we're going to run this function before the app is ready to respond to requests. And then this function is going to stop, and FastAPI is just going to leave it there until the app is shutting down because we terminate the app, for example, and then FastAPI is going to run the rest of the function and is going to execute our teardown. It used to be in previous FastAPI versions that you had app events, startup and a shutdown app event, and those still exist, but this is the new recommended way of doing it. Now, to actually get FastAPI to use this, we say lifespan equal lifespan. If you're using an old FastAPI version, this may not work, in which case I recommend you update your FastAPI version. But if you can't, then look at the FastAPI documentation for the startup and shutdown events. And then what you'll do is you'll add those. The startup will run database.connect and the shutdown will run database.disconnect. So that's it. This is how we do it. Let me bring up my console here, and we're going to do uvicorn storypi.main app. And now I see I've made a mistake a few videos ago, so we're not going to go back and fix it. But here in database, this obviously needs to be storypi.config. This will be fixed in the text version of this lecture. So if you have access to that, the code that you've seen there will be correct. But obviously I made a mistake there. Okay, so running that gives us data.db. And why is it called data.db? Because the .env file defines the env state as dev, and dev database URL is SQLite data.db. Now we can go to Insomnia and we can create a post, for example. But remember that if we go to our routers, post.py, we're not using the database here. We're still using our in-memory dictionaries. So even if you go to Insomnia or you run your tests, they are still going to be using this in-memory database. So in the next couple of videos, we're going to be running our tests in test mode and connecting our router to our database module and getting rid of these dictionaries. I'll see you in the next video. Hi and welcome back. One of the key features of our test-specific configuration is this dbForce rollback. We need to make sure that when we run our tests, they are independent of each other, so that if one test adds something to the database, the other tests don't use the data that's already there. They have their own data. And so when we run each test, we're going to say delete all the data that's in the database. Now, in order to do that, we need to make sure that test config is used when we run our tests, and therefore not the values that are in the .env file. Or, to put it differently, we need to override the value of env_state. Fortunately, it's very easy. It feels a bit hacky, but it's so straightforward that it is the best way to do it, in my opinion, because it's so simple. All we have to do is import OS, and then before we do our imports from our code, we say os.environ env state is test. Now, the rough linter is going to complain about these two things. So we'll say no QA E402. And there we have it. We actually don't need to put that one under here. We just need to put the app import in here. Why is that? Because when we import app, we import database, and when we import database, we import config, and when we import config, we're actually reading the values. This is how that's going to work. It's going to overwrite the value that is read from the .env file, and we're going to use the test mode for our tests. The no QA E402 just tells the rough linter to not quality assure this line with the E402 rule, which tells us that imports should be at the top of the file. Because we've got some non-import code before it, the rough linter considers this to not be at the top of the file, doesn't like that, So adding this here tells it to ignore this rule for this line. All right, now we're ready to actually use the database in our router. So let's do that in the next video. I'll see you there. Hi and welcome back. This video is going to be a bit of a longer one where we're going to use our database in our router. I'm here in conftest.py, and the first thing we're going to do is get rid of this comment table and post table import. We don't need it because we are actually going to not be using that. Instead, we are going to add from storeapi.database import database, and again, no QA E402, making sure that this is under this OS environ line, and then this DB fixture is going to say await database.connect, and under the yield, await database.disconnect. Remember that when we disconnect from the database, that's automatically going to roll back everything because we've got our DB rollback set to true. This fixture is going to run every function, every test function. So at the beginning of the test function, we're going to connect to the database. Then we're going to run the test function. That's what the yield does. It pauses execution of this fixture until after the test function. Then after the test function runs, we're going to disconnect from the database and undo all the changes that we've made. Now let's take a look at our router. We're going to start by getting rid of what we actually want to get rid of. And when we do that, we're going to get a whole bunch of errors, and that's going to tell us what we have to go in and change. So let's get rid of our in-memory tables, and then we're going to go through one by one and make the changes that we need to make. Now let's start with find post. We're using the post table here, so let's make our changes. Now we could go to the top of the file and say from storeapi.database, import comment table, post table, and database. We're going to need these. But you can see that as soon as we do that, all our errors go away, but we will get errors when we run the code because we're using post table, which is a SQL Alchemy table, as a dictionary, and it's not going to like that. So what I'm going to do is assume these imports are here. We're going to comment them out so we get our errors back. We're going to write our code as if the imports were there, and then we'll uncomment the import after. That's just so that we don't miss any bits. If you were writing this code from scratch without going through a dictionary first, then you would add the import first so that you get your method auto-completion and stuff like that. But for the purposes of the video, we're going to leave it at this. So find post is now going to be an async function because our database connection is async. That's why we use the databases module. And then for every database interaction, it's always the same thing. First, you decide what you want to do with the database. Then you write a query for the database. That part's not so obvious, and you need to know a little bit about how the databases work. And finally, you run the query. That's how it normally goes. So what do we want to do in find post? Well, we want to retrieve data from the database, but we want to retrieve data only for the post that has this post ID. In SQL terms, we're going to do a select for data, and we're going to select data where the post ID matches this value. We'll say query is post table dot select dot where, and here we pass in a boolean. So we'll say post table dot c for column dot id equal post ID. What's happening here is this where clause doesn't evaluate to true or false at this point. What it evaluates to is a query clause. And that query clause is going to run on the database server, and it's going to make sure that the post table ID column matches this value. But again, it's going to run in the database server. So this is just a really nice Pythonic way of writing a SQL query without actually having to write the SQL code yourself. This is why I like the databases module. I find it's very SQL-y, but you don't write SQL. There are alternatives to the databases module, such as the SQL Alchemy ORM, or even the databases library has also a companion ORM. And what an ORM allows you to do is to go a step further in detachment from SQL. So instead of doing select, where, blah, 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 you use Python objects as though they are already connected to a database. It's much more confusing, and also it's, I think, a lot more magical. So that's why we're not going to use it in this course. Okay, so this is our query. Now we have to run it. So we'll say return await database.fetch1 query. You can do fetch one or you can do fetch all. If you do fetch one, then you get the first value returned by the query. If you do fetch all, then you get everything that's returned by the query in something like a list, a way that allows you to go through all of the values returned by the query. So now that we've got this, let's go down to get all posts, and we're going to actually do something very similar. We want to select from our table, but we don't want to do any filtering because we want to get everything. So we'll do query equal posttable.select, and then we'll return await database.fetch all. There you go. I'm going to delete these few lines, and then we're going to write our query, which is posttable.insert. But when we insert data into a table, we need to give it what values we want to insert into each column. And with this library, it's very easy. You just do .values, and then very conveniently, you can give it a dictionary. What you have to make sure when you give it a dictionary is that the keys of the dictionary match the column names. So our user post in has a body, and our post table has a body. So those are going to match, and that's all fine. You don't have to give a value for ID because the database is going to generate one for us, which is pretty convenient as well. Now, when we execute this query, which we do with await database.execute query, and again, we're not doing fetch one or fetch all because this is not a retrieval query. This is an insertion query. But when we do database.execute of an insert, we actually do get a value back. And that is the ID that was generated for this row. So we're inserting a body, the database is generating an ID, and it gives that to us back when we execute. So we actually can say last record ID is database.execute, and now we can return the data and the ID from last record ID. And this matches what we were doing before, where we were returning the generated ID, which we generated manually. Now we are getting the database to generate it, but we still want to return it in our API so that the user of our API can then use the ID to maybe add a comment. Okay, the next thing we have to do when we are creating a comment is actually we need to await find post. That's because find post is now an async function. Previously it wasn't, but now that it is, we actually have to add the await keyword there so that it finishes running before we continue. Now, to create a comment, I'm sure you can do this on your own. It's very, very similar to creating a post. So pause the video and give it a go. I would recommend trying it out. Okay, now that you've tried that, we first create our query. That's comment table dot insert dot values, and we pass in the data dictionary. Then we get the last record ID with await database.execute, and we pass in the query. And finally, we return data and the ID, which is last record ID. I can't recall if earlier in the course I mentioned the double asterisk for the structuring a dictionary into another dictionary, but if I didn't, I'm going to leave a link down below in the lecture or in the resources section of this lecture where you can read more about how this works. Basically, it just passes each of the values of data as key and value pairs for this new dictionary we're constructing. So it allows us to add all the data from there and then add more data. So this is just a way to construct a dictionary quite succinctly. Let's move on to getting the comments on a post. What we have to do here is go into the comments table and now do some filtering like we did here when we were finding a post. But in the comments table, we're going to filter by the post ID column. If you remember, going back to database, the comment table has post ID, so we can filter by this. Let's go down here. We'll do our query. It's going to be comment table.select.where comment table.c.post ID is equal to post ID. And then we return await database.fetch all of our query. As you can see, there's really no magic going on with the databases library. We simply define our SQL queries and then we execute them, and that's it. It's a small library that simplifies writing SQL queries, but there's little magic involved. Finally, for getting a post with comments, we again have to await find post and make sure that this has an await there as well, which it should do already. Okay, so I think we are ready to uncomment this and try it out. Let's go through the code one more time to make sure that we're not trying to do anything with our previous tables. So post table, we're selecting, then we're filtering, and then we're doing fetch one. When we create a post, we're doing insert.values, and we're passing a dictionary where the keys match the column names. Then when we do database.execute, which is how we run a query that isn't a select, that returns only one thing, which is the ID that was generated for the inserted value. So then we create a new dictionary that contains the inserted data and the generated ID, and we return that. When we want to select everything from a table, it's just table.select and then fetch all for getting everything. And because Pydantic is going to process the returned values, it's going to already be able to turn that into a list of user posts and return that. Then we've got our await find post, and again, insert values of data, database execute gives us a record and we create that. And finally, to get the comments on a post, we do select, and now we can do filtering on the foreign key column in the comment table. You can filter by anything you want, but filtering by primary keys or foreign keys tends to be much faster because of how SQL Alchemy works with its indices. Now, there's one more thing that we have to do, and that is some of these are returning a dictionary, and that is fine. Pydantic knows how to deal with dictionaries, and up until now, we've been returning dictionaries from all our functions, and Pydantic has been able to deal with that no problem. But in some other cases, we are returning something that isn't a dictionary. It is a SQL Alchemy row. So those SQL Alchemy rows don't allow Pydantic to interact with them in the same way that a dictionary does. Basically, what Pydantic is doing is whatever our return value is, and then it's doing square brackets, body, to validate that the body exists. You know, this is a simplified thing, but essentially Pydantic is accessing the values that we return as if they were dictionaries because that's what it expects them to be. But our values are no longer dictionaries in all cases. Some are objects, SQL Alchemy row objects. For example, when we do fetch all, this is giving us a generator of SQL Alchemy row objects. When we do post is post, that goes to find post. Find post also returns a SQL Alchemy row. It doesn't return a dictionary. So we need to tell Pydantic how to deal with these objects that aren't dictionaries. But it's very easy. We go to our post models, and now for every model that we want Pydantic to be able to treat as an object as well as a dictionary, we have to give it a little bit of configuration. So for user post, we'll do class config, and then ORM mode is true. And then for class comment, we'll also do the same. And these are the two things that we may retrieve from our database. The rest are not going to be retrieved from the database, or rather they are just using those two. So these are the only ones that need ORM mode. Basically what ORM mode does is Pydantic will now try to do return value body, and if it fails, then it will try to do return value body. And that is something that does work with the databases library and SQL Alchemy. It just tells Pydantic to try to do that. And that's it. Let's run our tests and see what happens. Well, you can see we've got a couple of issues. We've got an assertion error. We asserted that dict items with ID 0 and body test post should be inside here, but it isn't because the ID is different. It's 1. And that just goes down to how SQL Alchemy is generating the IDs. Previously, we were generating IDs by calculating the length of our database and then using that number. So obviously, when the database was empty, the length was 0, and that's the ID value we used. So in our test, if we go to test routers, test post, we've got a few things in here where we say the ID should be 0. But with SQL Alchemy, the counting starts from 1. So we just have to go in here, change the ID to 1, and change this ID to 1 in the 2 tests that are failing. Then we can run our tests again, and they all pass. So as you can see, we've swapped out everything in our application, but our tests haven't changed. And that is what you want. Because the tests test functionality of the API, they don't test the internals of the API. So these are system tests. You could call them integration tests. The line is a bit blurry between those two terms, but these are good tests for an API because they make sure that we have confidence that when we deploy this API and users are going to interact with it, it works in the way we expect. If you're still with me, congratulations. This was a pretty long lecture, but we've done a lot of work, and hopefully you've got a really good idea now of how straightforward, not easy, but straightforward it is to interact with a database using FastAPI with the databases library. I hope you've enjoyed this video and this entire section, and indeed I hope you're enjoying the course thus far. Remember, if you have any feedback or any comments, feel free to let me know. I'm always looking out for that. So thanks again, and I'll see you in the next video. Hi and welcome back. In this video, let's talk about the logging module in Python. 3 key concepts in the logging module are loggers, handlers, and formatters. Here's a quick poem that I wrote with ChatGPT that's actually pretty relevant. In the realm of code, logging's a fickle dance. Too many logs may leave budgets askance. Find the balance and debug you can, but log too much, you'll end up in a jam. And this is really the problem with logging, I find. It's difficult to do well. How much should you log? How often should you log? Where should you put your logs once you've logged them in order so you can read them later on? And that's where the budgets line comes into play. If you have a production application and you are logging a lot of data so that you can tell what the application is doing when you read the logs, all of that adds up and you have to store them somewhere, and that costs money. So you can actually end up spending quite a lot of money in storage and in subscription plans for logging services. The other problem with logging is it takes up lines of code in your programs. If you log too much, most of your code ends up being logging calls, and it can end up quite difficult to read. So you have to find the balance, and then logging is going to help you debug your application if something goes wrong when you deploy it. And also it's really going to help you identify what's going on in case your application grows so complex that you're maybe not 100% sure the path that the code is taking in all cases. I thought this was an interesting thing. ChatGPT is a cool technology. Anyway, let's move on. The pros and cons of logging. So this is a bit of a guide as to what to expect. Logging, mainly you use it to see what happened during a request to your web application, because once your application is deployed, you obviously can't step through it with the debugger, at least not very easily. So if a problem happens, you want to be able to see what the user did in that request that led to the problem. The problem with that is that it makes your code less readable, as I mentioned earlier. And you'll see what I mean when we start writing logs in our routers for our application. The code ends up being a little bit less readable, but if you find the balance, it's not that bad. Also, logs let you gain a historical context into your application. Because you can store your logs somewhere, then you can search through the logs, and you can use the logs to build big data applications or just to see what users tend to do with your applications. That kind of information is something you can glean from your logs. If you log well, there is enough information in there to actually glean something from it. But the counterpoint to that is the more you log, not only is your code less readable, but you also have to spend more money. Once the logging system is set up with Python, the Python logging module, logging is very straightforward. You get a logger and you say logger, send a message, and then that's it. The message goes to wherever you've told it to go when you set it up. The initial setup is quite confusing. There's obviously loggers, handlers, and formatters that we're talking about in this video. There's also something called filters. You've got to link these up to each other. There's a few extensions as well that you can install to help with your logging. Then you've got logging services and analysis services and all that kind of thing. So it is a bit confusing. Once you've set it up, it's fairly simple. Another benefit of logging is you can set up alerts and dashboards. For example, if you log an error message in your application, you can set up an alert so that it will send you an email to your work email when that happens, and you don't have to wait for users to complain that something's going wrong. You can use the logs not just for seeing what happens during a request and gaining historical information, but also for real-time information as well. So logs are really useful, and really you have to use logs if you are deploying an application and it's a serious application. It's basically essential. So let's continue. A quick primer on the logging module in Python. You've got loggers. These schedule log information for output. And each logger has one or more handlers. And a handler is responsible for getting that log information that you've scheduled and sending it to a particular destination. I'll give you an example in a moment. And each handler has one formatter attached to it that defines how that log information will be displayed. So what parts of the log information will be printed out to the console, for example, or put into a file, and what parts will not be displayed. Let me give you an example. You've got your logger, and then you may have two handlers, let's say, a console handler and a file handler. There's a few different handlers you can use, and we'll go through them throughout the course of this section. And then you've got a formatter that is set up to display the current time and the log message. Let's say that you use the logger to send or schedule a message that says, "This is my log message." Well, first, this goes out to the handlers. The handlers each send it to the formatter, or rather the handlers use the formatter. And then the handlers, in combination with the formatter, will either print out the message to the console in case of the console handler, or put it into a file, let's say storeapi.log in case of the file handler, and obviously you can customize the file name and various other parameters when you use a file handler. But this is the quick primer on how the logging module works. You've got your logger that you use to schedule messages. You've got handlers attached to the logger. Each handler has a formatter, and the handler uses the formatter to display the log message in some way, sending it to wherever you've told it to send it to, such as the console or a file, or indeed a third-party online service if you want to do that. Logging levels. You can log messages in different levels, and they have different meanings. For example, the critical level is a type of level that you should use only when there's an error that causes application failure. For example, you may try to connect to a database and you have a try except block in Python. In the except block, if you can't connect to the database, maybe you will have a critical log message being scheduled. Then you've got error. For example, if a user tries to access an endpoint, but they don't have permission to do so, maybe you will log an error message. Then you've got warning, info, and debug. In different environments, such as when developing locally or when your application is in production, you may only show or hide certain levels of message. For example, in production, you may not want to show debug messages because you can often print out a lot of debug messages, and that can take up a lot of space and therefore a lot of money in production, and you're not going to be looking at them. But when you're developing locally, you may want to enable debug level messages so that you can see all that information when you are actively coding. Here's an application that uses the logging module to print out 5 different logging messages at 5 different criticality levels. First, you can see we have to import the logging module. Then we set up the default handlers and formatters using logging.basicconfig, and we pass the level at which we want to be able to log. If we say logging.debug, then that means that all messages will be shown. If you pass logging.error, for example, then only the error and critical messages would be shown. So this is like a low pass filter that allows you to filter out certain types of message. Now, once you've set up the logging module, you need to get a logger that you're going to use to actually schedule these messages. So you do that with logging.getLogger, and you give the logger a name. This initially sounds a bit weird. That seems irrelevant. It's going to become relevant later on in the next few videos. And the logger name actually has some meaning that simplifies the logging setup. So we'll get to that. Once you've got your logger, you can simply do logger.debug info warning error or critical, and that schedules a message with the given text at that level of criticality. So logger.debug would send a message at the debug level. And again, if you had configured the level here as logging.info, then this message would still be executed, but it would be immediately filtered out and it would not get sent to the handlers. And the default handler, by the way, is a console handler. So if you do this, you'll see your logs in the console. And by the way, this is what it looks like. You would see the level. So that's debug, info, warning, error, critical. Then you have a colon and the logger name. You can see that's my logger. Then another colon and then your message. This is the default look of logs, or this is what the default formatter displays logs as. If you want to define your own handler so that you're not using the default handler, then you can do it like this. Just define a variable, make it equal to logging.streamHandler, and then this is going to send logs to the console. Now, in basic config, you can pass in a handlers keyword argument with a list of handlers, and you put your handler in there. And now this does exactly the same thing, but it sends it using this logging.streamHandler. This is what you can do if you wanted to define multiple handlers. So again, define your handler and then pass it as a keyword argument. If you wanted to define two handlers, for example, you can do it like this. You can add another handler in here. In this case, it's logging.fileHandler, which defines a file to which logs will be printed. And then you can just add it to your handlers list. And now, whenever you log these messages, they would go to the console and to a file called file.log. So this is what the logs look like, as I mentioned earlier. And when you want to display log messages using a formatter, the formatter has access to certain variables that are defined within each log record. A log record is the object that gets created when you actually schedule a log for output by the logger. So the logger creates a log record, then the handler uses the formatter to display it, and at that point the formatter has access to certain variables stored within the log record. These are these variables here. You've got level name, which is the criticality level. You've got the name, which is the logger name, and you've got the message. You can also notice that there's a percentage, a pair of brackets, and an S at the end. This is the percent-based string interpolation in Python, and all this means is level name is a string. You do percent brackets, you put the variable name inside it, and the S at the end means it's a string, and this is how you tell the logging module to display the level name variable. Just like with F strings, we use curly braces. With the logging module, you use this percent brackets and the S at the end. If you wanted to display a number instead of a string, you would replace the S by a D. You can see that each one of these maps to one of these variables, and the colons there are just for display purposes. They don't mean anything. It's just you want to actually show a colon there. You could change it by a dash or a pipe or whatever you want. Now, here's the same application that we had earlier, but now we are defining the format string ourselves. As well as level name, name, and message, we also have ASC time for the current time. And you've also got line number, which is a number, and that is the line number of the file where the log message was shown. For example, for this debug message, we're in line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So line 13 would be shown in place of this line number variable. This is what these messages would look like. You can see the current time there. That's the year, month, day, hour, minute, second, and millisecond. Then you've got the level, the logger name, a colon, the line number, and then our message. If you compare this to the default look, you can see there's a lot more information. You've got the current date, which is essential to be able to know when something happened. And also you've got the line number, which lets you find where the message was created. If you have an error log message, you can go into the file and figure out how that was called, what caused this log message to be created, and from there figure out the problem, hopefully. But logging.basicconfig can make things easy, but it's maybe not perfect. It gives us some nice defaults, but we don't have as much control. And when you want to start doing things like send messages to a third-party logging service, or maybe do some more advanced configuration, it's just not something you can do with basic config. Plus, basic config does a few things that are not ideal in terms of which loggers it configures. You don't have to worry about that too much, but it's better to set up our loggers, handlers, and formatters manually. Unfortunately, it's pretty straightforward. So let's do it. We're going to create the logger, handlers, and formatters. To the logger, we're going to attach the handlers, and to each handler, we're going to attach a formatter. The first thing to do would be to import the logging module, and then get a logger and set its level. Basic config was doing this for us, but now you have to do it here at the logger level. Then create the handlers, just as we did before when we were passing them to basic config. You simply create as many handlers as you want your logger to use. Then you can create a formatter, and you have a formatter per handler, but 2 handlers can use the same formatter if you want. So here we're just creating one, and then we're going to set formatter on each handler. So we'll do console, which is the console handler, or the stream handler. We're going to set the formatter to be this formatter. And for the file handler, we're going to set the formatter to be this formatter as well. So that way, when we use the logger to send the log records to these handlers, they will use this formatter to display the logs. Then we basically do the same thing as we did with formatters and handlers, but to handlers and logger. So to our logger, we will add the 2 handlers. And then you can actually use the logger. So that's basically it. Obviously, it's not sustainable to do this in every file. So whenever you want to log something, you're not going to be doing this whole thing. That's where logger inheritance is going to come into play. We're going to configure a logger, and then every other logger in our application is going to inherit from that logger, and it's just going to use the logging configuration that it set up. I'll show you more about how to do that in the next video. So thank you for joining me, and I'll see you there. Hi and welcome back. In this video, let's talk about the Python dunder name variable and how we can use it for logger inheritance. The dunder name variable in Python is a special variable, and its value is either a string containing the text dunder main, or its value is the import path to the file that you're using the name variable in. I know that's a bit confusing, but I will give you a few examples as we go through this video. If you run the file as a script, then dunder name is the string dunder main. Otherwise, it's the import path. Let's look at some examples, because all of that I've just said is incredibly difficult to understand on its own. So you've got this file, app.py, and inside app.py, you've just got one line of code, print dunder name. Then you're going to run python app.py. This is the command that you run in the console. The $sign in front of any of these just means run this command on the console. This is the convention. That's what the $sign means. So you run python app.py in the console. That runs the code above, prints the dunder name variable, and you get dunder main out. Therefore, dunder main is what was contained in dunder name. That's what happens when you run a file as a script. Running a file as a script just means doing Python and then the file name. That's what the term run as script means. In a more complicated application, such as this one that has 2 files, you've got app.py, and then inside a store API folder, you've got test.py. In app.py, you've got import store API.test, and then you print dunder name. Then inside test.py, you've got print dunder name. The first thing that you would do when you run Python app.py is app.py would be running as a script. But storeapi/test.py is not running as a script. That's an imported file. That's the key differentiator between the two. So what would happen when you run app.py? Well, first, you import storeapi.test. Whenever you import a file in Python, Python runs the file so that it can figure out what names are inside the file, what variables and classes and functions are in there that you can use. So first, you would import the file. Second, the file would run and print dunder name would be executed. And that's when you see in the console the dunder name value of storeapi/test.py, which is the import path to the file, storeapi.test. This is how import paths are defined in Python. They're formatted, I guess. You've got each folder or package up until the file name. So this file is inside a folder called storeapi. So you've got storeapi, then a dot, and then the file name. If there were multiple folders or subfolders, you would get them separated by full stops as well. Now, after you print storeapi.test out to the console, and that file finishes running, you'd go back and continue in app.py where you left off, and you would print dunder name in app.py. And remember, app.py is the file that we ran as a script, so you get dunder main printed out, because the dunder name variable of any file you run as a script is always dunder main. This is actually where that if dunder name equal dunder main if statement that you can see sometimes in Python files comes from. That if statement allows you to check whether the file is a file that you were running as a script or it's imported by something else. Now let's say that we've got this project structure. You've got your project folder, then inside it, you've got storeapi, a folder. Inside that folder, you've got dunder init.py, you've got main.py, you've got another routers folder, and inside it, you've got dunder init.py and post.py. This matches the application structure that we've got in this course. When you run the FastAPI application and you are inside the project folder, you do like uvicorn storeapi.main:\app, just as we've been doing throughout this entire course, then all of the files inside this project are storeapi.something. In main.py, the name is storeapi.main. In post, it's storeapi.routers.post. This is what I meant earlier when I said if you've got multiple subfolders, they're always separated by full stops or dots. So you can see that within our project, everything starts with storeapi.something. And that is the key, because now we get into logger inheritance. If we define a logger called storeapi and we attach handlers and formatters to it, then other loggers with specific names are going to use the same handlers and formatters. And which names? I think you can probably guess. storeapi.routers.post is going to use the handlers and formatters associated with storeapi.routers.post. Once it has used those handlers, it will then pass the message to storeapi.routers, and it will use storeapi.routers handlers and formatters. And then it will pass the message to storeapi, and it will use storeapi's handlers and formatters. If we don't configure storeapi.routers.post, and if we don't configure storeapi.routers, all that's left is storeapi. In our application, all our files, as long as we just don't configure the logger specific to that file, all our files are going to use the handlers and formatters of the storeapi logger. With this application structure that we've very conveniently been using throughout the entire course, we only have to configure one logger, and all our files will use the same configuration. That's pretty handy. So again, just as it does in the import path for Python, where you've got the dot separating folders and files, the dot in logger names separates inheritance levels. Anything storeapi.star is going to end up using the storeapi logger configuration. If you want to custom configure a specific logger for something, you can also do that, but it's generally not done. You just normally put all your code in one folder, you define the logger for that folder, and then you use that across your entire project. Okay, so that's the key takeaway for this lecture. You only have to define and configure one logger, which is the StoreAPI logger. And that's because all our source code is in that folder, and all our files will use the same configuration. So again, a short diagram to hammer the point home. In any of these files that we've got in our application, well, this one we're gonna create in the next couple of sections. Basically, in any file that's within our StoreAPI folder, as long as we run the application from outside the StoreAPI folder, such as by doing unicorn storeapi.main:app, as we've been doing, then the dunder name of any of those files will be storeapi dot and then the file name, or storeapi dot and then the folder name and the file name, and so forth. So these all inherit from the StoreAPI logger, and that's the one that we're going to configure in this course. Hopefully this all makes sense and you've enjoyed this video. Thank you very much for joining me, and I'll see you in the next one. Hi and welcome back. Now that you've learned about loggers, handlers, and formatters, we're going to set up the logger for our FastAPI project. But we're going to do it not manually as we did in the last video, but using a configuration file. Now, it's basically the same thing, it's just a little bit easier to work with. Inside StoreAPI, let's create a new file called loggingconf.py. And now in here, we're going to say from loggingconfig import dict_config. And from storeapi.config import config. We're going to need our config variable in here in a second. Then we're going to write a function called configure logging that doesn't take any parameters and doesn't return anything. All it does is it calls dict_config from the logging module, and now we pass it a dictionary where the loggers, handlers, and formatters are defined. This is just slightly nicer to work with than doing logger, get logger, and then add handler, and then set formatter, etc. The first thing we need to do here is version, and this needs to be 1. The version 1 just tells the Python team that we want to use the first version of the dict configuration style, and this is the only version, but in the future, if new versions are released, it means that it won't break everything that we're doing here. Then we're going to say disable existing loggers, and this is going to be false. Something you can do is you can define a bunch of loggers in this dictionary, and all other loggers will be disabled if this is set to true. But we don't want to do that, at least not for now. And then we'll have 3 keys: formatters, which is again another dictionary. We've got handlers, which is another dictionary, and we've got loggers, which is our 3rd dictionary. And there's also a thing called filters. We haven't looked at filters yet, but we will talk about them later on. And these are dictionaries because within each dictionary as the first key, we're going to have the name of the formatter. So let's define a console formatter that is going to format log records to be displayed to the console. We're going to use another dictionary in here where the first key is the class. This is akin to doing logger equal logging.formatter. So we do logging.formatter in here. And then we define the date format. If we want to use the date within the formatter, we can define the date formatter in here. So we'll do %y, %m, %d, t, %h, %m, %s. And this uses the same syntax as the datetime module for formatting dates. Finally, we've got a format key that uses the %style language to say what this is going to be displayed as. So we'll do, for example, line no d and then message s. Notice the dash there. I'm just putting that in myself to actually display a dash in the message. So it's a bit easier to tell where the name of the formatter and the line number ends and where the message starts. But you can change this and you can put something else in there. Or you can use the same format as we used in the last video to format this differently. But I'll show you that you don't need to do that because we are going to add a little bit of magic into this logging in a moment. So you don't actually need the time, the date time, or anything like that in here. I'll show you why in a second. Okay, so now that we've got our formatter, let's go into our handler. And now the handler that we're going to define is going to be called the default. And the class is going to be logging.streamHandler. And then we can set the level because handlers can also filter out certain log levels if you want, but by setting it to debug, it means it's not going to filter out anything. It's going to simply do whatever the logger tells it to do. And finally, the formatter is going to be console, because that's the formatter that we defined up here. So you can see how these dictionary keys map to the actual name of the formatter. Now that we have our handler defined, let's define our logger, and this is going to be Store API, because we have the Store API top level folder for our source code, and therefore all our loggers within all of these files are going to inherit from Store API, as we've already discussed. So we need to set up the Store API logger. And in here, we're going to do handlers, and this is going to be default. And this is a list of handlers, because remember, we can have multiple handlers for a logger to do things like file output, etc. So here we put a list with the default handler in there. And then the level, which is going to be debug, but only if the config that we've got, which has disappeared from storeapi.config, import config. We only want the level to be debug if this config object is in dev mode. So we want this to be info if we are in test mode or in prod mode. So how we're going to do that is we're going to import dev config and config at the top. I know that earlier we imported just config. That was a small mistake. You want to import both of these things and then say debug if is instance config of dev config, otherwise info. What that's going to do is it's going to check that the config object, when it was created, was an instance of dev config, which is what we're using in development. In any other case, it's going to be info level. That's because when you're in test mode, you're probably not going to be looking at the logs, but you can always change this later if you need to in any specific situation. And in prod mode, you definitely don't want debug mode to be enabled, because that's probably going to generate a lot of logs, and that can actually get quite expensive to store. And I'll show you how to store your logs when you're in prod in a few videos time. Finally, what we're going to do is set propagate to false. And what that does is it doesn't send any logs that are generated by a Store API logger to its parent. And you may think, well, I thought Store API was the parent of every other logger in our Store API folder, and you'd be right. For example, in post.py, the parent is Store API, then you've got routers, and then you've got post. So this logger, as I've discussed previously, inherits from Store API.routers, which inherits from Store API. So in post.py, for example, the Store API logger is one of the top level parents, but there's actually one more, which is root. And the root logger is the parent of all loggers. And so propagate false, what it will do is it will not send any logs generated from any of these loggers up to the root logger. And you want to do that. You want to set propagate to false when you're developing an application and you don't want your logs to be sent to the root logger. And you want to do that in your applications when you have configured a top level logger that you're using for your application and you don't need anything to be sent to root. But there are some situations where instead of configuring a Store API logger or a logger for your application, you want to configure the root logger, and then everything goes through that. So that's an alternative option that I don't normally recommend, but it exists. But you want to set propagate to false, and that means that Store API is the top level in this logger hierarchy. Now that we've got this set up, we can simply go to main.py and we are going to configure our logging. So we'll say from storeapi.loggingconf import configure logging. And then in the lifespan function, we're going to say configure logging right there. Something important to note here is the configure logging function is going to run before your FastAPI application deals with any requests. That's because this lifespan function will yield when it has finished setting up, and only at that point will your FastAPI application respond to requests. So that means that in your routers, whenever you want to log in any of these functions, you know that the logging has already been configured by then. You're never going to get any situation where you're logging before your Store API logger is configured. Let me show you how to log in here, and I'll also show you a small nifty trick. So we'll say logger is logging, get logger, we'll call it dunder name. Now, after configure logging, we're going to do logger.info, for example, hello world. Then let's open that console and we're going to say unicorn storypi.main app. You can see that our log gets printed out there. But things are missing, obviously. We don't have the time at which the log record was created. You could go into logging conf and modify your format, as we've already discussed earlier on, to include the ASC time variable. Or you can use the rich library for your handler, and that makes your logs look much better and also includes that information by default. So let's go over to requirements.txt and make sure the rich library is there, and then do pip install-r requirements.txt and make sure that's installed. Then go into logging conf, and here you can do rich logging rich handler. And now if we run our application again, you'll see that things look a little bit different, and you've got a little bit of color going on in here as well, which is nice. You can see the date is displayed as well as the logging level. And here on the right, you've also got the file and column name in which this was created. So if you wanted, you can just display the message in the format there, and that's totally up to you. I just find the file names sometimes are a little bit confusing because multiple places in your application may have the same file, like models and routers. So I do tend to like having the logger name in there, but it's totally up to you. An added benefit of using the rich handler is that if you duplicate this a few times and you restart the app, I'll show you what that looks like. When logs are generated at the same second, they all get displayed like this, and you don't get the date in each line. So this just makes it a little bit easier to read. All right, so we've implemented logging, we've made it available to our entire application. Now, whenever a log is triggered within any code files inside StoreAPI, they're going to use this logging functionality. So we are ready to actually start using logging in our routers. In the next few videos, we're going to finish configuring logging by adding files and that kind of thing. And then we'll start with using logs so that we can tell what our application is doing when we run it. Thanks for joining me, and I'll see you in the next video. Hi and welcome back. In the last video, we configured our logging, but you may notice that some logs look really nice with our rich handler, and some look the default way that they do for FastAPI apps. So in this video, let me show you how to configure multiple loggers so that as many logs as possible look the same way that we have configured for our app. To do that, all we have to do is go to logging.conf.py, and down here in loggers, create more loggers or configure more loggers so that they use our default handler. Just as we have been following best practice in our application with a folder under which all our code lives, and we have configured one logger with that folder's name, most other libraries, or maybe even all other libraries, can have their loggers configured just by configuring a logger with the name of the library. So you first have to find out which library is generating which logs, and that can be a little bit tricky sometimes. So let me show you which ones are being used in FastAPI. First, we're going to start with unicorn, and this, as you'll know, is the command that we run to start our application. Unicorn is what takes our FastAPI app and runs it in a way, so it produces some of these logs that you see here. So let's configure the unicorn logger. To do that, we just provide the unicorn name, and then all the loggers under the unicorn library that inherit from the unicorn main logger, if you will use this configuration. So all we have to do is give it a list of handlers, which is our default handler, and you can also configure the level. You will be changing this every now and then depending on whether the level that you select gives you enough information if something bad happens. But for now, we're going to stick with info. Like I said, in the future, if you feel like you need more information from unicorn to see what's going on in your application, you can always change this to debug. And you may not do that very often, but it may happen. And there's two other loggers that we're going to configure as well. There's databases. And by the way, the order of these loggers doesn't matter. I've just got them in this order in my notes, so I want to stick with this order so that when I share my code with you, it is the same. So it doesn't matter which order it goes in. Here for the databases module, which we're using to connect to a database, we are going to do the same thing, but we're going to use the warning level. And finally, for IO SQLite, we're going to do the same thing and make sure to not forget your commas at the end. Now, when you run your app, you'll see that the first couple of logs don't look any different. That's because those are generated by FastAPI and they are not using the same logging configuration structure that we use here, and that is a bit non-standard. So those I haven't figured out how to change, so I do apologize about that, but everything else should match. For example, if we now go to Insomnia and run a request, you can see that now we get the Uvicorn access logs being printed out like this, and you get your get post and so forth. And also these logs here look the same as they did for our application. All right, so I just wanted to show you how to make all of these logs look the same, because it's going to make your experience reading them that much nicer and easier. So thank you for joining me in this video, and I'll see you in the next one. Hi and welcome back. In this video, let's talk about logging to a file. We earlier showed you how to log to a file, but we're going to do things slightly better in this application by logging to a file and keeping backups of previous logs. So to do that, we're going to start by defining a formatter that we're going to use for the file logs. You can have a different formatter for console logs and a different one for file logs so that you can add more information to your file logs than to your console. That's usually a good idea, so that if you really need to trawl back through all your logs, you're not missing anything. Whereas for the console, because you're normally not going to be looking back on a lot of console logs when you're in production, you don't have to worry so much about it. So to create our file formatter, we're again going to define its name, which is going to be file, and then we're going to have a class of logging formatter, and the rest is going to be the same, the date format and the format, but here we're going to use a slightly different format string. This is the format string that I've been using for my file logs, and it looks a bit intimidating, but what you've got is the time, which uses this date format. Then you've got a dot. Then you've got the milliseconds of this time. That's formatted to 3 digits. That's what the O3D means at the end. So you're always going to get 3 digits of milliseconds. Then you've got the Z, because that's the ISO format standard. When you've got this, then a dot, and then milliseconds, and then Z, that's the ISO format. So it's a good practice to use that format for your logs. So if you ever have any tools that are going to analyze your log files, they're going to understand the date at which the log was emitted by using a standard format. Then you've got a pipe character. This is just a pipe character. It doesn't have any meaning, and you can generate it on Mac at the bottom left of your keyboard by pressing Shift and the key that's just beside Shift at the bottom left. I'm not 100% sure how to do it on Windows. It might be one of the number keys, but in any case, you don't have to use a pipe character. I just like the pipe character. Then we've got the level name, which is like debug or info, etc. And this -8s is going to pad the level name string with spaces so that it is always 8 characters long. So what that means is if you put info, for example, then it's going to add 4 spaces. And the reason for that is so if you have a critical message that is 8 characters long, you can see the pipes line up. Just makes it a little bit easier to read. That's why we pad it to 8 characters. If it already has 8 characters, then no spaces are added. If it has less than 8 characters, spaces are added to make up the rest. So that's what the -8s does. Then there's another pipe character, and then you've got the logger name, colon, the line number. Again, that's a number, so it ends with D. Then you've got a dash, and you've got the message. You could put a pipe here if you prefer. Totally up to you. I've just been liking the dash in there, but again, it is your choice. Now let's create our rotating file handler. So we put a comma in there and then rotating file. And what a rotating file is just a log file, but when the log file becomes full, when it reaches a certain size, then a new log file is created and the old one sticks around for as long as you tell it to, so that if you have to go back quite a long time, you can find previous logs in other log files. You can customize for how long files stick around and what size they should be before new files are created. I'll show you how to do that. First, we're going to define the class, which is logging handlers rotating file handler. Make sure to spell this right, by the way. I've been making a lot of typos while recording on this class name. Then the level is going to be debug. Again, we don't want to use this handler to limit any kind of logs. We want to use the logger to limit that. Then the formatter, which is going to be our file formatter. Again, this just links the formatter defined above and uses that for this handler. Now we've got the file name. I'm going to call it storeapi.log. And now we've got a few other things that we need to configure, such as max bytes. This is how big a file can get before a new file is created. When you get multiple files created, they are storeapi.log, storeapi.log.1, storeapi.log.2, etc. So you can say, for example, 1024 times 1024, and this is 1 megabyte because this is in bytes. I find it easier to do this because this is how megabytes are calculated. You can, of course, just put the number in there, but I just think this is quite easy. And then if you want to change it to, let's say, 5 megabytes, then you can just multiply by 5, and that means 5 megabytes. The larger the file can be, the longer it will be, obviously. So just pick a number here that makes sense for how much your application is logging and how large a file your editor can view. Because sometimes when files get very long, the text editors struggle to open them and to read them. So yeah, just pick a number that makes sense. 5 megabytes, I think is fine. So is 1 megabyte. I'm going to leave it as 1. So in the future, I can show you how multiple files are created. Okay, then you've got comma and backup count. This is how many files will be kept. So you create storeapi.log, then when that reaches 1 megabyte, you'll create storeapi.log.1, and when that reaches 1 megabyte, the first one will be deleted because you only keep 2. If you want to keep more files, then keep 5, for example. And then you'll have 5 megabytes worth of files in 5 different files when they are all at its maximum size. If you multiply this and you keep 5 megabytes, then you'll end up with 25 megabytes worth of log files. How many files and how many bytes you want to keep is up to you, but make sure that you've got enough disk space in your server to keep your log files around. 5 megabytes worth of log files is not very much, neither is 25 megabytes. You play around with these numbers, make sure that it's something that you're happy with. Finally, something that you'll want to do is the encoding of the log file. That's going to be UTF-8. If you're logging in English, UTF-8 is a good encoding to use. Other encodings can be used, but sometimes different encodings use more bytes per character, so you end up with fewer logs for the same file size. So just pick an encoding that makes sense to you. Now let's add the rotating file handler to our loggers, and I'm only going to add it to the unicorn and storeapi loggers. You can of course add it to everything if you want. I'm just going to show you how to do it on 2 loggers, and your loggers can have different handlers. That is the second benefit of configuring the loggers that your application uses and not just relying on the default configuration, for example, the unicorn library. Now, because you are configuring it yourself, you can save those logs to a file pretty easily. Whereas if you didn't configure it yourself and you just relied on the default configuration for unicorn, those logs would be in the console by default, but they wouldn't appear in your log file. This is another benefit of doing this. Okay, thank you for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi, and welcome back. In this video, let's start logging from our router. We're going to start by importing the logging module and then creating our logger down here. We'll say logger is logging.getLogger and under name. And again, this is going to give us a logger with the name of storeapi.routers.post, which, as you know, inherits from storeapi. So it's going to use the same configuration that we have defined in our logging conf. Now let's go over to get all posts. This is a good one to start with. And we're going to do logger.debug query. And this is something that you'll probably want to do. Whenever you have a database query that you're going to run, you probably want to debug it to make sure that you can tell if something goes wrong or if maybe it's not returning what you wanted. Let's start our app and then go over to Insomnia, and we're going to hit send. You can see that we get nothing back. But maybe we're at a stage in our application where we think this is wrong. There should be something coming back. So why is there nothing coming back? Well, it's pretty easy to tell that it's not a database problem because you can see the query and you can see that it makes sense. You're just selecting everything from the database. So clearly, there is nothing in the database. It's not that you've got a bug in your application. So this is why I normally suggest debugging the queries. Later on, when you're in production and you don't have debug mode enabled or debug level enabled for your logger, you're not going to see this. And that's probably better because these SQL queries can take up a lot of characters when they're complex queries, and it can take a lot of money to store all those logs. So in production, you're not going to want to use debug, but these debug level logs can stay in your application and they just will be filtered out by your configuration. Something interesting about this whole logging situation we've got here is that you see this log first, and then you see what endpoint this is related to. So you can see get/post comes after the debug log. And I find that just a little bit confusing, right? Because you start seeing a query and you're like, where is this coming from? Then you have to go and find it. If you've got multiple logging calls, this can get even more confusing. I'm actually going to add another info level log at the top of the file saying getting all posts. Of course, you can change this to be whatever you want. You can add more information about what endpoint is getting called, etc. There's also some decorators you can add that will log this information for you, so you don't have to add this to every endpoint. But I'll leave it to you to explore more scalable solutions later on if that's what you want to do. And now what happens is if we make another call to this, you see that you're getting all posts and then the database query. If this happens fast enough, they are appearing side by side and you know exactly what's going on, the order of the logs, where each one happened. You can see the file and line numbers on the right. So I think this is a little bit nicer than relying solely on the stuff at the end, which is the unicorn log. All right, let's add this kind of logs for all our functions, and then we'll be able to start seeing what's going on in our application a bit more easily. And you can add logs to things that aren't FastAPI functions as well. So here we've got just a plain function. You can add logs to this as well. You can do logger info, and then something like finding post with ID of post ID, and then logger debug of query. Now, if you try to find a specific post, for example, let's say get post with comments, and we're going to find post 0, which doesn't exist. So we get a 404, post not found. But you can see down here that we got the query printed out. And interestingly, and this is a good thing, the query doesn't have the values that you were searching for at that time. This is just something that will be replaced by the value passed. This can be helpful for when you're searching for users and things like that, and you don't want their emails to be displayed in the logs, but there are ways to change this so that you do get all the values displayed, but I think it's probably not necessary from a debugging standpoint. You are displaying the post number there because this is not sensitive information. You want to make sure that you're not in a position where you may log sensitive information, especially if you're storing these logs somewhere in the cloud, which I'll show you how to do later on. Okay, let's go through and add this kind of logs to everything. When you encounter an error in your application, you'll want to use logger.error to print out something so that you can see in the logs that this is what happened. Because the user will get an HTTP exception, the unicorn access log will say it was a 404, but maybe you want to log something specific or some more information about what went wrong. You can do that with logger.error in here. All right, let's continue. There you have it. We've added our logs to everything, and logs take up space. You know, this is a problem with logs. You've got as many lines of logging calls as you do of actual code. I don't like that, but it is simply how it is. So you've got all our logs now, and whenever you make calls to your API, let's create a post, for example, and then we're going to get the list of posts. We're going to get the comments. You can see nothing gets printed out. Now you start seeing that you can tell what's been going on throughout the user journey. They've inserted something into the posts, then you've run this query, then you've run that one, and you can see everything that's been going on. So this is really helpful. There is a small issue with this, which we're going to tackle in a few videos' time, which is what happens if you've got many users making requests to your API at the same time. And 10 users are creating posts, and then 10 users are getting posts. You're not going to be able to tell who's who from the logs because there is no user information in here. We're going to tackle that later on, as I mentioned. But for now, we've added logging to our router. And I know this is a little bit inconvenient to do, to have all these logging calls, but hopefully you've learned something, you've enjoyed this video, and I'll see you in the next one. Hi and welcome back. In this short lecture, let me tell you about filters in the logging module. We've seen this diagram before. You've got loggers. Each logger can have 0 or more handlers. If it has 0, it doesn't do anything. And each handler has one formatter. But what we haven't seen is that there is one more bit to this diagram, and that is the filters. Each logger can have 0 or more filters attached to it, and each handler can also have 0 or more filters attached to it. A filter is simply used to reject log records and say, actually, don't log this one, don't pass it to the handler. Or it can also be used to modify the log records, such as to add more variables that you can then use in the formatter. We're going to use a filter to add a variable to our log records later on when we do the request IDs. And we're also going to use filters to modify log records and hide some personal information. There's a very good diagram in the official documentation for how this works. Let me bring it up for you. Here in the official documentation, you've got this diagram. I recommend you bookmark this page because you may need it over the next few videos. Whenever a user calls logger.info or logger.debug or whatever, first we'll check if the logger level is enabled for this type of call. So if you set the level of your logger to critical, for example, and you try to do logger.debug, that message will be immediately rejected because it's too low in the criticality level. However, if you set the logger level to debug, then the message will continue. Then the logger creates the log record, which is just an object that holds the message and various other variables. Then we go through the filters attached to that logger, and we can modify the log record with those filters, or we can reject the log record. Basically, a filter is a class that has a method, and if the method returns false, then the log record is rejected. If it returns true, the log record is approved, and we continue. If it rejects the record, then we just stop. Otherwise, if it passes and it approves the record, we continue, and we pass the log record to the handlers. So we go into this small diagram here to the right. The handler can also have a criticality level filter. So assuming that the handler is not set to only critical, for example, then we will continue. We go through the filters of the handler. They can reject the record or they can modify it. And if it is approved, we continue. So this uses the formatter at this point to emit the log record and write it to the file or send it to the console, whatever it is that the handler is supposed to do. Now, after this, we continue down here with this arrow, and each logger has a propagate property. If propagate is false, then we stop at that point. So we've emitted using the handlers, we've sent it to our file, we've sent it to our console, and then we stop. If propagate is true, then it gets sent to the parent. So for example, if you are in storeapi.main and propagate is true for storeapi.main, then it gets sent to storeapi. This is exactly what we're doing with our loggers. We have propagate set to true, which is the default value on all our sub-loggers, and propagate set to false in the main storeapi logger so that the log messages, once they reach storeapi, don't get passed to any parent handler. So yeah, if propagate is set to true and there is a parent logger, we send it to the parent logger. Otherwise, in either case, we stop. So hopefully this matches the mental model that you've been building throughout this section on how the logging module works. Looks very complicated, but again, It's relatively straightforward once you build the mental model. You first schedule the log record you created. You maybe reject it with filters, pass it to the handlers, pass it to the parent, and then you repeat that until there is no parent. Remember that every logger has a parent, which is the root logger. So that is why this question mark is here. Even the Store API logger that we've been defining has a parent, which is root. Once this reaches the root logger, there is no longer a parent logger. So at that point, we would terminate. Hopefully this makes sense. The mental model matches what this describes. And hopefully you've learned something in this video and you've enjoyed it. So thank you very much for joining me, and I'll see you in the next video. Hi and welcome back. Last time we added logging in every error. So you've got an HTTP exception being raised here, and just before it, you've got the error. And then down here, we did the same thing where we raised an HTTP exception, and right before it, we logged. We can actually do this kind of logging with an exception handler in FastAPI. So let's go over to main.py. And in here, we're going to import the logging library. Then we're going to get our logger, making sure to pass it under name. And now in here, we're going to add an exception handler. So we'll say at app.exception handler, HTTP exception, which we'll have to import from FastAPI. And then we will define a function that logs something when an HTTP exception is encountered before returning the value to the user. We can say async def HTTP exception handle logging, takes in a request and an exception, and we can say logger.error and just pass in HTTP exception exec status code and exec detail. And these two, status code and detail, come from the HTTP exception itself. You can see in here you've got status code and detail, and that just includes a message saying what happened and why the exception was raised. Then you'll do return await HTTP exception handler request and exe. This is just the default exception handler that we also have to import from FastAPI exception handlers. That returns the JSON to the user the same way as we do by default when we raise an HTTP exception. This returns some JSON to the user. By adding our exception handler, we override that and then we call the default exception handler so it does the same thing. Now, when we find an exception, we no longer have to log because that is going to be included. You're going to see post not found in the detail and 404 status code. That's all going to be logged. If you want to include more detail in the exception, then you can do that. You can say post with ID, whatever, not found. So let's remove these error logging calls to simplify our code slightly. And now whenever we raise an HTTP exception, we're going to get something in our logs, which is quite nice. All right, thank you for joining me in this video, and I'll see you in the next one. Hi and welcome back. In this video, we're going to look at how we can tell that multiple logs have been generated from the same user request. Earlier on in the course, I mentioned that when multiple users are making requests, you may not be able to tell which logs belong to which execution path. So for example, if you have two users making requests at the exact same time, you may see creating post twice in a row. So two info levels of creating post immediately, followed by two debug logs of inserting into the posts table. And you're not going to be able to tell whether the first info or the second info go with the first debug or the second debug. So we're going to fix that in this video so that whenever you have multiple logs being printed out, you can tell they're all from the same user request. To do that, we need a new requirement. Let me hide this console for now. And that is asgi-correlation-id. And then we bring back the terminal and we're going to do pip install-r requirements.txt. Make sure that's installed, hide the terminal again, and then let's go into main.py and we're going to add this as a middleware for FastAPI. We'll say from asgi correlation ID import correlation ID middleware. And then after we define the app, we'll say app.add middleware, and we'll pass in the correlation ID middleware we've imported. Okay, so this is the setup that we need to do in this bit of code. Now we can go to logging conf.py and we're going to add a couple of things here. First, we need a filter. Just before formatters, although the order doesn't matter, we're going to add filters, and this is another dictionary, and this is going to be correlation ID. It adds a new variable to the formatter that can be displayed there, and the variable that it adds is a generated string that is unique for each request. So when multiple logs are printed out from the same request, they will all have the same ID generated for them. Okay, so this is a dictionary, and now to configure the filter is a bit weird. The first thing that we need is a pair of brackets as the key, and then the class name, correlation ID dot correlation ID filter. Now what happens when we use this pair of brackets is any configuration parameters that we put in this dictionary after this one will be passed as keyword arguments to this constructor. So if you were creating this in Python code like this, like filter is this, any key and value pairs that we put after this would be passed as keyword arguments to that. So I'll just add them here. First one is UUID length, and we're going to do 8 if is instance config of dev config, else 32, and default value is just a dash. And don't forget your comma at the end there. So before I explain what these do, this is what this would look like. UID length is 8 and default value is dash. This is what this is doing, and this is why we use the pair of brackets here when configuring our filter, so that these can be passed as keyword arguments to this constructor, and this is simply how it needs to be done. When you use class, it works in a different way. It doesn't pass these as keyword arguments to logging.formatter. So I know this is a bit confusing, but that's simply how we have to do it. Let me delete that and I'll explain what these two do. Every string that is generated for a request so that it can be displayed in the logs is a UUID, a universally unique identifier. UUIDs are just strings that are pretty much guaranteed to be unique. And by setting UUID length, we ask this library to generate a UUID of 8 characters if we are in dev. Otherwise, if we're in prod, it's going to generate 32 characters. The longer the UUID, the less likely that 2 UUIDs that are identical will be generated. And finally, default value, so that if we are not in a request, then no UUID is generated and the dash will be used instead of using a UUID. I'll show you all of this in a second. Now, in our console formatter, we're going to add this new variable that this filter allows us to use. We're going to put a pair of brackets and a space, and inside the brackets we're going to do percent bracket correlation ID s. The brackets are purely for looks. They're not necessary, the ones at the start and at the end, so you could delete them if you wanted to, but I like the look of them. And the correlation ID is the new variable that gets added by this filter, and it is the UUID that is generated. Now, in the file, we're also going to add the correlation ID. So I'll just do exactly the same thing, but I'm going to put it inside square brackets, correlation ID. I think that just looks a little bit nicer. And again, the square brackets, they're just for looks. They're not needed. Now, there's one more thing that we have to do. We have to tell our handlers to use this filter so that the variables are added correctly. So here under formatter, we're going to say filters, and then pass in a list of filters, of which we've only got one, which is correlation ID. And then in the rotating file, we'll do the same thing. This has been a lot of changes for something that maybe isn't very clear what it does to you right now, but I'll show you what it does and it will all be much clearer. Let me run the app. And now you can see the first thing that when we use our logs, we get this brackets and dash in between. What this means is we are not currently in a request. So no UUID has been generated because this is just like application startup logic. It's not a request that we're handling. But if we go over to Insomnia and we get a list of posts, for example, now you can see that these 3 logs that are all relevant to the same request have the same UUID at the beginning. So if you had multiple users making requests at the same time and you had the same log printed out multiple times in a row, you would be able to tell that they are from different requests. And it's not that you've got a bug in your application that's printing logs multiple times, and this will make it much easier to see in which request things went wrong, if something did go wrong. This is basically essential for a web application. If not, it's impossible to read your logs. So this is a really simple, although I know it's not simple in the traditional sense, but it's actually fairly simple to add this using this ASGI correlation ID. All we had to do is a couple of configuration settings, and that's it. We don't have to track the requests ourselves or do anything like that. It's actually fairly straightforward, all things considered, to add this really essential piece of information. So thank you for joining me in this video. I know it's been quite a complex thing, but hopefully you've learned something and you've enjoyed it, and I'll see you in the next one. Hi and welcome back. In this video, let's improve our file logs by using JSON instead of plain strings. Up until now, we have been creating our logs in our rotating file, and it looks nice. I mean, this is very readable for a human, which is good, but it can be better because most of the time you're not going to be reading your files yourself. You're going to be giving your files to a third-party log storage service, and then you're going to be reading your logs from there. So having these files readable to you isn't that important, and it's certainly not as important as making sure that this file is readable by a piece of software and that this file contains all of the information that you want. So let's change it to use JSON. It's very straightforward. First, we'll need a new requirement, which is python-json-logger. Then we go over to logging conf and we make a small change. But first, let me not forget to install the requirements. So pip install-r requirements.txt. Make sure that the Python-JSON logger is installed. And then here in the file formatter, instead of logging.formatter, we're going to use Python-JSON logger as one word, .json logger.json formatter, like that. Also an easy one to misspell, so just take that into consideration. Here we've got our format string, and you can tell that this format string uses certain variables. The JSON formatter only cares about whether the variables are used or not, and then it will put those variables into a JSON object. So we don't need to add any formatting in here, just need to use the variables themselves. And that doesn't look as nice, but when it turns to JSON, then it's going to look fine. Let me save that, and we're going to run our app. And now if we go to the log file, you can see that we get the log displayed as JSON in here. And this is much more readable for the tools that you'll be using to parse your log files, if you do use any. Having your log files as JSON is also pretty standard, and you can see it's relatively straightforward with FastAPI and the logging module by using this third-party library. Thank you for joining me in this video. I hope you've enjoyed it, and I'll see you in the next one. Hi and welcome back. In this video, let's talk about writing our own logging filters. A logging filter is a class that has a function, and that function takes a log record and modifies it or adds some variables to it and then returns it. So to create a custom filter, the first thing we have to do is to import the logging module. And then in here, we're going to create a class. It's called email obfuscation filter. And I'll tell you what it's about in a second. Now, inside the class, you want to define a filter method. This takes in a log record, which is a logging.log record object, and returns a Boolean. Basically, if this function returns true, then whatever log record is passed to this filter will be displayed. And if this returns false, then the log record will be filtered out. If you want to add some variables like the correlation ID filter does, then you can simply do record.yourVariable equal 123, and then this variable will be available for the formatter to use like so. And then you put an S at the end. Okay, so this is a very quick primer on how the filters work. Now let me tell you what filter we're going to be creating. Sometimes in your application, you may log some personal data accidentally. In this filter, we're going to take any emails that we see in our log records, and we're going to obfuscate them. We're going to hide them. And that way, if you ever do display an email in your log records, it's going to be hidden away. But we are not going to scan the entire log message and see if there are emails in it. We're only going to obfuscate email addresses that are included as an extra argument to the log record. So before we talk about how to deal with that, let me show you what an extra argument looks like. Whenever you have a logging call, such as logger.debug query, you can actually put extra and pass in a dictionary of things that you want to include in this log record. For example, email is bob@example.net. Now, this extra data gets included in the log record, and it can be used as a variable by the formatter, or it can be put into the file, or really whatever you want to do. So it's a good way to add extra information that maybe doesn't have a place in the message itself. We are going to make sure that whenever we include this extra email information in any of our log records, that we are going to filter it out, but we can still see some of the email address. The reason for that is we want to make sure that the full email address is not shown in our logs, but maybe a few characters of it, so that we can tell whether multiple records belong to the same email address or not. Okay, so let's get rid of that for now, and let's go back to our filter. To check whether the email variable is present in that extra data, we do if email in record and then dunder dict. That's where all that data is going to be included. And we're going to say record.email is, and now we're going to write an obfuscated, if I can spell that, obfuscated function. We're going to write this function, and we're going to give it the record email and self.obfuscated length. Now, this function here is going to take the email and a number, and it's going to return the email address, but only a few characters shown. The rest of the characters are going to be hidden. How many characters are going to be shown is given by this property. What is the value of this property? Well, that's what we do in the init. The init method takes self. It's going to take a name, which is a string, and it defaults to an empty string, but this is something that we simply need from the logging filter superclass. And then it can take the obfuscated length value, which is an integer, and it's going to default to 2, returns none, and all it does is it calls the superclass, passing name, that is the name of the filter when we configure it, and then it does self-obfuscated length is obfuscated length. So this is how we're going to set that property in. Now, for the obfuscated function, this function is a little bit trickier. So we'll say def obfuscated, it takes an email, which is a string, and the obfuscated length, which is an integer, and it returns a string. Now, what we're going to do is we are going to only keep, let's say, for example, that we've got bob@example.net, and let's say that obfuscated length is 2, then we're going to keep bob and then a*@example.net. So obviously this is not that secure, but if you've got something like my name, then you'd only keep JO, and then you'd have a bunch of asterisks. Sorry, this would also be an asterisk. Okay, so this is how the obfuscation filter is going to work. We keep the ending because the endings are normally not sensitive, and we're going to asterisk everything else. You can configure this length there yourself. How many characters do we want to keep? Well, we'll say characters, and then email, and then colon, obfuscated length. This is a Python slice, and what it does is it keeps all the characters from the index 0, that's the default value, up to the obfuscated length. So if obfuscated length is 2, then it gives us the characters between index 0 and index 2. The 0 is not necessary, that's the default value. I know that looks a bit bizarre, but this is what a Python slice is. We're going to leave a blog post linked so that you can read more about Python slices if you're not familiar with them. Then we're going to do first, comma, last, and this is email.split on the ampersand sign. So this will give us, for example, Jose Salvatierra and example.net. This is going to be I guess a tuple or maybe a list with these two values. The first one gets assigned to first, the second one gets assigned to last. And then we simply do return characters, And these are the first 2 characters in the email, let's say. So now we need to add a bunch of asterisks. But how many asterisks? Well, we'll do asterisk times the length of first minus the obfuscated length. And that will give us an equal number of asterisks as characters are remaining in the first part of the email when you take into account that some of them are not obfuscated by asterisks. Then we'll add the ampersand sign and then last. This is what produces our obfuscated email. Okay, that's our custom filter. Now let's register it here in our filters. We're going to add a comma and then say email obfuscation. This again is the name that gets given to the filter. And now we will use the brackets again. And now we pass in the email obfuscation filter class. If you pass in a string, then Python will try to import this and use that as the constructor. If you pass in simply a class, then it will just use the class. And we are calling the init method. The next thing we're passing is the obfuscated length. We don't need to pass a name because, again, that's passed automatically. So we just pass obfuscated length and any other parameters that we want, which we don't have any in this case. And this is going to be 2 if is instance of config dev config. So basically, when we are developing, we're going to see some of the email. When we're in production, we're going to see none of the email. Then using this filter is really easy. We don't have to change our formatters at all. All we have to do is in our handlers, add the email obfuscation filter in there. And now, whenever we include the email as an extra piece of data to our logs, it will be obfuscated. So we can do that. And then in development, we can debug the application. But in production, it's all going to be hidden away. The main part of this video was to show you how to write a custom filter and for you to see that it's pretty simple. You create a class, inherit from logging filter, and then define a filter method that takes in the log record and then returns true or false. This can be a conditional based on some other code in the method, or you can also add values or change values within the log record if you want. Note that you don't want to include the email in the formatter because some log records may have that extra data and some may not. It just depends on whether you put it here as extra. So if you include the email in there, then you'll get an error every time you try to log something that doesn't have the extra field included. All right, thank you for joining me in this one. Hope you've enjoyed it, and I'll see you in the next one. Hi and welcome back. In this video, let me tell you about a pretty nice cloud logging solution that I've been using, and it's called Logtail. With Logtail, you can simply send your logs from your Python application over to them, and then you can see them in this nice interface, and you can also query them using something that looks a lot like SQL. You can create custom views, you can create alerts, and all sorts of things. It's got a free plan, which is quite generous, and then after you use the free plan, you'll have to start paying for it. Now that we've got all our logging configured for our application, it's actually really easy to also send our logs to Logtail. So what you'll want to do is sign up. And once you've signed up, you'll be able to link your application to Logtail. Once you've created your application and logged into Logtail, you'll see something like this. You can connect a source, give it a name, for example, FastAPI, then connect to Python, create the source, and then you're going to have a source token that you're going to need. Save that source token to your .env file as dev logtail API key, then go to config.py and add that to the global config logtail API key as an optional str, which is none. Then let's go over to loggingconf.py, and in here we're going to add another handler, which is the Logtail handler. So we'll say Logtail, and here we need to use the class of logtail.logtailhandler. We're going to need to install this. The level is debug, formatter is console. For filters, we're going to add both our filters. And finally, the source token is going to be config.logtail API key. Under store API, let's add Logtail to our list of handlers. And then we also need to install Logtail Python. So let's go to requirements, logtail-python, then pip install -r requirements.txt. Once everything's installed, you can run your app and then try to use your application. And now you should see some logs over in Logtail. You can simply click on Livetail here at the top, and you'll be taken to the Logtail for just this source. You can look at just this source, or you can look at multiple sources at once. And also you can modify what things you see. For example, you've got here the file, the line of the file where the log was emitted, and you've got your message, and you can see that you've got some information here that is duplicated, such as the file and the name of the router and the file name. So you could potentially get rid of this in another formatter and just display the message. Later on, when we start adding more attributes to our log records, such as that user email that we talked about in the last video, they will also appear here under more potential columns, and you can use them as well. Although it's pretty handy to be able to see all your logs like this, it's actually most useful when your application is deployed in production and you don't have access to a console for your server. We're going to be looking at the Logtail logs mostly from production. We're not going to be looking at them when we are in development. So thank you for joining me in this video. In the next one, we're going to make sure that we don't connect to Logtail when we're in development. We only do that in production. Again, thanks for joining me, and I'll see you in the next video. Hi and welcome back. In this video, we're going to make sure that we only send our logs to Logtail when we are in production and not when we're in development. We don't want to fill up our Logtail free plan with development logs that we can very easily see in our console. And also we don't want to not know whether the logs that are in Logtail came from a test that we did locally or from production from actual users. So that's the main reason for doing that. Let's create a handlers variable that is going to have default and rotating file. And then we'll say if is instance config of dev config. Then we will say that the handlers list is default, rotating file, and Logtail. Then at the very end, for our store API handlers, we'll simply say handlers is handlers. And that's it. Now your logs won't be sent to Logtail until we deploy this application and set the env state to prod, which we will do when we reach the deployments section of this course. Thank you very much for joining me in this section. I hope you've enjoyed it, and I hope you've learned a lot about logging with Python and with FastAPI, and I'll see you in the next video. Hi and welcome back. In this video, let's talk about JWTs. A JWT is just a string that is encoded to contain some information so that it can be stored by the user, and when it's sent back to us in the backend, we can decode it and access that information. Let me show you this diagram of how a JWT is used, and then I will give you some concrete examples. If we take some metadata, such as an expiry date, the identifying information for the user, such as the user ID, and a secret signature, we can combine those things together to form a JWT. And this is a very long string. Then as the backend, we send that JWT to the user's client, which could be their mobile phone or their browser that's accessing our web application or something like that. And then the browser or the mobile phone is going to store that JWT. Remember that this JWT is generated from these pieces of data. Now, whenever the user wants to make a request, an authenticated request, they send us the JWT. Then we can decode it. And by decoding it, we essentially use these pieces of data. The secret key is not something that we can access when we decode the JWT, but because our code generates the JWT and also decodes the JWT, we can use the secret key that we already have to check that the secret key matches. And I'll show you how that works in a moment. But what we can get from the JWT by decoding it is the metadata that we can use to check that it hasn't expired. And we can also get the user ID. Now, what's the benefit of this? Well, let me just zoom out of this diagram so you can see the whole thing. The benefit of this is the user can ask us for a JWT by providing their username and password. Then we will get their user ID from our database, if it matches the username and password, generate the JWT with it and give it to the user. And then in any other request, such as if they want to create a post, we can ask for the JWT, and just with that, we can say that the post is to be created by the user that originally created the JWT. Here I am at jwt.io, and on this website you can see what a JWT looks like and what data is included in it. When we generate a JWT in our FastAPI app, we're going to give it this data on the right, and we're going to end up with this string on the left. We will then give this string to the user for them to store. Then, whenever the user wants to, say, create a post for which we need their user ID, they will send us this JWT, and we will decode it to grab this data again. And in here, you can see there's a sub field in the payload, and this is going to be the user ID, let's say user 1. We're going to be able to access the user ID there. The other fields that are present in the JWT are, for example, the issued at time. This is a timestamp. And the expiry time. This is another timestamp. Basically, what this means is whenever our application receives a JWT, we will be able to know which user generated it. And in order to generate a JWT, the user needs to give us their username and password. So by giving us a JWT, we know the user logged in the past. So we can use the JWT as a proxy for the user having logged in. Since the JWT includes the user ID, we don't need to ask the user to send us the user ID in the JSON payload of the request. Simply by giving us the JWT, we can already get their user ID. So this acts as both authentication and also gives us the data we need to then create our posts or our comments or whatever it is that we want to create that is linked to a specific user. Now, a common question you may get is, what if the user decodes a JWT and changes the subject and then sends us that? Well, this is where the secret key comes into play. Let's change it back to 1. And here we have the secret key. Now, the secret key is not included in the JWT, but the secret key is used to generate a signature. You can see that the signature is generated by encoding the header, then putting a dot, then encoding the payload, which is this here, and then using the secret key to generate this piece of text. If the user that doesn't know our secret key, because we keep it secret in our application, gets this JWT, decodes it, and changes it, for example, let's say they change some text here, then you can see that we get invalid signature. Because the user doesn't know the secret key, they cannot re-encode the contents with the secret key to create another signature that is valid. So this is how the JWTs are secured in a way. So users can see the contents of the JWT, such as by putting it on this website, but they can't modify the contents of the JWT and send it back to us unless they have our secret key. So that's why it has to be a powerful secret that you actually keep secret and you don't share with anybody. All right, going back to our application, let's open up our requirements.txt, and we're going to need a couple of things. We'll need Python-Jose, which is a library used to generate JWTs. Then we'll need Python-multipart, which is used for receiving form data using FastAPI. And then we've got passlib bcrypt. This is going to be used to hash the user passwords so we can store them in our database. Then in our requirements-dev.txt, we will also need Pytest-mock. We're going to use this to do a little bit of light mocking in our tests so that we don't have third-party dependencies. Then let's open up the terminal and do pip install -r requirements.txt to install those new things, and also pip install -r requirements-dev.txt. And that's it for this video. So we've had a brief look at what a JWT is, which is just a string that is encoded and contains some data and is signed. And we've also installed our requirements. Now, in the next few videos, we're going to add user registration and user authentication to our FastAPI app. I'll see you in the next video. Hi and welcome back. In this video, let's start by adding a database table for our users. Let's go into database.py and just here somewhere, I'm just going to add it here. We're going to create our user table. And this is just a table where we're going to store the user data. So just as before, we will have SQLAlchemy.table, then the table name, which is users, and the metadata object so that we can have everything in there. And now we will add our columns. We need an ID column. So that's SQLAlchemy.column. This is an ID and it's an integer. We're going to say primary key is true. Then we will also store email and password. The email and password combination is what the user is going to use to authenticate, i.e. they will give us that and we will give them back a JWT. By marking the email column as unique equal true, two users won't be able to use the same email to register. And then the password is just a simple string. Now let's write our new file that we're going to call security.py. And in here, we're going to put a few functions related to users and authentication, JWTs, and that kind of thing. We'll import the logging module, and then from storeapi.database, we're going to import database and user table. Then we will create a logger, just so we can get into the habit of logging from the very beginning. And then we'll define a get user function that takes in an email and returns a user. Let's start by doing logger.debug, and we'll say fetching the user from the database. And here we're going to use this extra argument to put in the email address of the user we're retrieving. Remember that because we've got our email obfuscation filter in our logger, we're only going to display the first couple of characters of this email address in our logs. Then for the query that we'll need, we're just selecting something from the user table where the email matches. Because the email is unique, we know there's always going to be either one or no rows. So we'll do user table.select where user table C email is equal to email. We've already done this with posts earlier on. Then we will await database fetch 1 for that query. And finally, if there is a result, because there is one user with this email in the database, we will return it. Otherwise, it will return none. So we've got this written. Now it's a bit difficult to write tests for this function because we don't have a way to register new users. We could write some unit tests that modify the database directly, but let's wait until the next video when we add user registration, and then we'll be able to register a user and then check that this function works correctly. So thank you for joining me in this video, and I'll see you in the next one. Hi and welcome back. In this video, let's take a look at adding user registration to our FastAPI app. Remember that whenever you work on a backend API, you're going to be looking at three main things. The data that you need to store, the data that your API is going to receive and return, and then you're actually going to implement the API interface to the user, the endpoints. The first two, the data that the API will receive and return, and what data you're going to store, can be done in either order. Earlier on, we did our models first and then our database after. For this section, we've done the database first, and now we're going to do the models. We'll start with user.py, and here we are going to create our Pydantic models. We'll say from Pydantic, import base model, and then we'll define a user, which is a base model. And this has an ID, which is either an integer or none. And the reason for that is because when a user gets created, they're not going to be giving us an ID. But when a user is returned, then we will be including an ID in there. Then we have a user in, which is a user subclass, and this adds a password. Now, you may notice that when we did posts, we did it the other way around. We did user post in, and that was the base model. And then what we were returning was the subclass of that. For the user, we've defined it the other way around. The user is the base model, and the user in is the subclass. That's because we don't want to return the password when we return a user. So doing it like this makes that a little bit easier by defining user in as something that has an email and a password, and the user as something that just has ID and email. Now let's go over to our routers, and we're going to create user.py in here. Just as we had for our post router, we're going to say from FastAPI import API router, and we're going to say router is API router, and at router post, and we're going to create the register endpoint, which has a status code of 201, async def register, and this takes a user in object. We're going to say from storeapi.models.user import user in. Now, the first thing we want to do is check if the user already exists, because if it does, then we're just going to say you've already registered. So we'll say if await get user with user email. Let me just write pass there while we add our import from storeapi.security import get user. This is the case, then we're going to raise an HTTP exception, and we're going to say status code is 400. And detail is going to be a user with that email already exists. We need to import HTTP exception. Now there's something in FastAPI that you can use, which is the status variable. And this one has all the status codes, and maybe you'll find this more readable, status.http 400 bad request. It's just a number. So if you click into that, you can see that's just the number 400, but it's up to you whether you want to write it like this, or you want to write the number directly. We're going to leave it like this here so you can see how it works. It's identical, but again, it's up to you. Now, the next thing we want to do, if we did not raise an HTTP exception, is we want to insert this user data into the database. So how do we do that? Well, we'll write our query, which is user table, and we need to import that. So we'll say from storeapi.database import database and user table. We'll need both of these. User table.insert, and we'll pass in the values to the insert, remembering that because the ID is a primary key, we don't need to pass a value for it. We just need to pass email and password. So we'll say email is user email, and now we're going to do something very bad, and that's password equal user password. We're going to do logger debug of query, and then we're going to say await database.execute query, and then user created. We also forgot to create our logger, so let's do that. There you go. And also when I saved, the import got deleted, so let's add it here. Okay, so I said this was very bad, but what do I mean by that? You should never store the user's password in the database just as is. Let's say the user password gives a super secret password. You're going to end up putting super secret password in the database in plain text. And that means later on, if you want, you can go into the database and look at people's passwords. Because most people use the same password for everything, that means that you could conceivably go into other websites and check to see if that user's email and password combination works, and you could basically hack into people's accounts in other websites. So it's a very bad practice to save passwords as plain text. Also, even if you say, oh, I'm not going to be looking at these plain text passwords, yeah, that's fine. But if your database gets hacked, somebody else might look at them. So it's just much, much better. In fact, it's the only way to do it to not save plain text passwords in the database. You have to hash them. And that just means turning the password into an unreadable set of numbers and characters that cannot be turned back into the password later on. Okay, I'm going to add a comment here to tell you that this is a very bad idea. In a couple of videos' time, we're going to be using the passlib library that we've already installed to do this a bit better. So this is bad. We'll fix it very soon. Now that we've got our register endpoint, we should be able to insert the data into the database. And, there's nothing new here from anything that we've done before. It's a bit more intimidating because we're dealing with user data, but we're just getting two values and we're putting them in the database. So nothing new there from what you already know. Let's go into our main.py, and we're going to add this router to our app. So we'll say from store api.routers.user import router as user router, and then we will include it there. Just like that. Now we can start writing some tests. So let's go over to tests/conftest.py. There we go. And we're going to write our first fixture that deals with users. And that is the Pytest fixture async def registered user. This takes in an async client and returns a dictionary. So let me just add that in there. What this is going to do is, just as our created post and created comment fixtures did, it's going to register a user and then return some information about it. We've got our user details, and that's email. It's going to be test@example.net, and password is going to be 1234. For now, this password is what is going to be saved in the database as plain text, which, remember, I've said is a bad thing. Later on, we're going to be dealing with hashing the password. Then we'll do await async client.post and go to register, and the JSON is going to be the user details. Now we could just do return user details. And then what this function would do is it would give other tests that use this fixture access to the email and the password of the user that we've registered. But I want to do something a little bit better, which is to return this information, but also the user ID, because we're going to be needing the user ID in a few places. To get the user ID, we need to go into the database. So we'll do query is user table.select, where the user table C email is equal to user details email that we've already defined. We'll say user is await fetch 1 of the query, and then user details ID is user.id, and then we will return the user details there. We need to import the user table, so we'll go here and we'll do user table. This actually registers a user and then fetches the information that we've created and gives us the ID, and then we return that. So this will include the ID, the email, and the password that we can use in other tests. Also, calling this fixture or using it in any of our tests will mean that a registered user already exists in the database. Let's go and create test security inside tests. We'll do test security.py, and we are going to import Pytest and do from store API import security, then Pytest mark any IO, and we'll do async def test get user, and we can give it a registered user, which is a dictionary. Now we can see if the get user function that we wrote earlier on actually gets a user from the database. So we'll do user is await security.getUser, and we'll pass in the registered user's email. And then we'll assert that the user email is equal to the registered user's email. All right, let's run these tests. And you can see that they all pass. Now let's write one that is the inverse of it, where we try to get a user, but none exists. So we'll do Pytest mark any IO, async def test get user not found. And we'll say user is await security.getUser, test@example.com. And then we'll assert that the user is none. Remember that when comparing with none, you have to use the is keyword and not double equal. And running that also passes. So we've done quite a lot in this video. We've written our models for dealing with data in and out. Then we've written our first user-focused API endpoint, which allows us to save their information to the database, their email and password. And we've not hashed the passwords, which is a bad thing. We're going to be dealing with password hashing very, very soon, before the end of this section. Then we've also written a Pytest fixture that registers a user and then gives us the user details and the user ID. And we've written a couple of tests for the getUser function in security.py. And we've also registered the user router with our app. So there's quite a lot there, but hopefully you're still with me. I hope you've enjoyed this video and you've learned something new. Thanks for joining me, and I'll see you in the next one. Hi and welcome back. In this video, let's take a look at writing some tests for our user router. So let's go to tests routers and create test user.py. And in here, we're going to import Pytest. And from HTTPX, we're going to import async client. We'll need this for typing. And then we'll do async def register user, and we will write a helper function that we can use to actually register a user in case we need to do that in any of our tests. And this is async client, email is a string, password is a string, and simply does return await async client dot post and goes to register, and the JSON is the email and password. Once we've got the register user function, we can actually use it to test our API. So we'll do Pytest mark any IO and async def test register user, which again takes an async client and simply tries to register a user in the database. So await register user, and we will pass in test.example.net and 1234, and we need to pass in the async client as well. Feel free to extract these into variables. That's totally fine, but we're not going to be reusing them. So we'll simply say assert that the response status code is 201, and we'll also assert that user created is in the response JSON detail. Let's run these tests, and you can see it passes. Now let's do another one where the user already exists. So it's actually really similar to this one, but we're going to use the registered user fixture, and then we will try to register another user with the same email as the registered user. So here we write our function and parameters. We need the async client and the registered user fixture. And then we simply do response is await of registered user, passing the async client, but also passing registered user email as the email. And you can pass in any password you want. And then we will assert that the response status code should be 400, because remember, in our API endpoint, that's the status code that we returned if the user already exists. And we can also assert already exists in response.json detail. It's better to do this kind of thing rather than equal, because if you want to add a period or a full stop at the end of the message or something like that, that can break your tests if you use equal, whereas asserting that this is in the response won't. That's if you don't really care that it has to be exact. All right, let's run these tests, and you can see they pass as well. Saving that also reformats our code, so it's a little bit nicer to read. That's everything for the user registration. So now we're ready to move on to the next video where we're going to be dealing with password hashing. So thank you for joining me in this one, and I'll see you there. Hi and welcome back. In this video, we're going to deal with password hashing. With the passlib library that we've already installed, it's fairly simple. The first thing we want to do is we want to define what algorithm we're going to use to hash passwords. Then we're going to define a couple of functions that hash a password and verify that a password matches another password that has already been hashed. So let's do it in that order. We'll say from passlib context import crypt context. And then here somewhere under our logger, maybe we'll say pwd context is equal to crypt context. And now we pass in the algorithm that we want to use, and that goes in the schemes. That's a list of algorithms. We're going to use bcrypt. Now we'll define two functions, get password hash, which takes in a password, which is a string, and returns a string. And we'll also define verify password. And the reason why we need a separate function to verify a password is because once a password has been hashed, it cannot be unhashed. So we will store the password hash in the database, and then it's safe. Nobody can go into the database and somehow turn it back into the plain text password and then use that to log into other websites, for example. The password hash that gets stored in the database cannot be turned back into the password. So how do we check when a user logs in later that they've provided the correct password? Well, we're going to hash a password when they sign up and put it in the database. And then when they log in and give us the password, we will hash that password and compare it with what's in the database. The crypt context has a verify method that we can use to get a plain text password and compare it to a hashed password, and it does that for us. Verify password takes in the plain password, which is a string, and also the hashed password, which is another string that comes from the database, and simply returns a boolean. To get a password hash, we do return pwd-context.hash. As you can see, pretty straightforward. We pass in the password, and that gives us this long string of characters and numbers and symbols. And to verify password, well, it's actually pretty similar. pwd-context.verify, and we pass in the plain password and the hashed password. If you hash the same password twice, you will not get the same hash back twice, because each password hash also has some unique seeds and things added to it to make sure that it is unique and you don't get the same hash every time. And that information that was used to generate the hash is stored in the hash itself. So when you use pwd-context.verify, that uses the information stored in the hashed password to hash the plain password, and then it is the same when it is hashed, and that's how it compares it. So that's why you can't simply do pwd-context hash plain password equal hashed password. This will not work, because the plain password hash will not be the same as hashed password, because it happens at a different point in time to start with, so it has a different seed. That's why we use verify, so that we ensure that every piece of metadata about the hash is the same. Now that we've got this, we can go into our user router and actually use this. You should never put this code in production. Like I said, I'll repeat it again. Don't put plain text passwords in your database. We'll do from storypi.security import get password hash and get user, and then simply grab that, and we will say hashed password is equal to that of user password, and we will put this in there. And that's it. This is now safe. So we didn't do much, but it's essential that you do this. Also, something else that you don't want to do is anything with the user's password until you've hashed it. So don't put it into logs, don't print it out, don't send it anywhere. Just hash it, and then you're safe to almost do whatever you want with it. Let's go into test security.py, and we're going to write a function here. Test password hashes, and we will give it a password such as password, and we will assert security verify password for password and security get password hash of password. So this is a very simple test. I'm not even sure this is necessary, but it's basically going to check that our verify password and get password hash functions are compatible with each other. If we get the password hash of password, and then we try to verify it against the plain text password, it should return true. So this is what this assertion is doing. Let's run that. And you can see it passed. And now you can also see that we've got a couple of things going on. First, the tests were slower. And that is by design, in a sense. You don't want password hashing to be very fast, because if password hashing is very fast, then it's easier for hackers to brute force your password by essentially trying it many, many times. So it does take a few milliseconds to hash a password. And now, whenever we want to do that in our code, it's going to take a little bit of time. The other thing we got is this crypt is deprecated and slated for removal in Python 3.13. This is just a small issue with the passlib library, but I'm sure they'll come up with an alternative to crypt by the time that Python 3.13 gets released. So don't worry about it for now. If this becomes a problem later on when Python 3.13 is released, I'll make sure to put an update on the course for what to do instead. But the passlib library is very popular. It's well maintained. It's frequently updated. So it's not something for us to worry about just now. Okay, thank you for joining me in this video. I hope you've enjoyed it and you've learned something new. And I'll see you in the next one. Hi and welcome back. In this video, let's take a look at creating our JWT. JWTs are also known as access tokens or sometimes bearer tokens. So those are all names for the same thing. To create the JWT, we need a secret key. This is what we're going to use to sign the JWT. This should be a secret and you can store it in your .env file and then go through config.py, but you know how to do that. Just add secret key in here as a string, add the value in env, and then use it here. You can also just define your secret key using a string, and this one is obviously not very secret. You should pick something that is very long and complicated to guess. Then the algorithm that we're going to use to create the JWT is HS256. So these are the two values that we need. Now that we have these two values, let's write a function called createAccessToken that takes in an email, and this is what's going to be stored in the access token. Alternatively, you could store the user ID. As long as it's a unique thing that identifies the user, then it's okay. We're gonna log a message creating access token, and we're gonna put the email for which the access token is being created. And I'm saying access token, and again, it's the same as a JWT. Now, we need to also store when the access token will expire. So we're going to say expire is datetime.datetime.now, datetime.utc plus datetime.timeDelta, and minutes is going to be 30. We need to import the datetime module, and made my variable disappear because we're not using it. So there you go. So this is going to expire in 30 minutes from now. Then let's work out the payload, or what we're going to store in the JWT. That is the sub field, which is the subject. That's the user's email or who the access token is for. And then exp for the expiry time. Then we'll actually make the JWT. So encode the JWT is jwt.encode, pass in the JWT data, the secret key, and the algorithm. And I'm just going to put this as algorithm equal, algorithm as a keyword argument, just so it's a bit clearer. We of course have to import JWT, so we'll do from Jose import JWT. I just find it funny that this library is named after me. Well, it isn't named after me, but it has the same name as me. Now we'll do return encoded JWT, and again my variable disappeared, so we bring it back there. For completeness and to make these two match, we're going to say key equal secret key there as well. Now, to simplify testing, instead of saying 30 minutes here, we're actually going to extract this into a function. So we'll say access token expire minutes, and this returns an int, and it just returns 30. And this is going to just make it a bit easier to test later, because we'll be able to mock this function and define how many minutes before the token expires. For testing, it's going to make it easier because we can say the token expires -1 minute ago, so it will already be expired when we create it, and that will help us test when an access token has expired. Now that we've created our access token, let's work on login. So to log in, the users are going to send us their email and password, and we're going to authenticate them. So let's go down to the bottom and write a function for authentication. So it will be async def authenticate user, and it takes in an email and a password. And this will basically return the user if the email and password are correct. Otherwise, it will raise an error. So we'll say logger debug authenticating user, extra is email, and then we'll say user is await get user. So we get the user, and now we see if the user exists. If it doesn't, we're going to raise an exception, and I'll do that in a second. Otherwise, if the user does exist, we're going to verify the password. So we'll say if not verify password of password and user password. Remember that user.password will be the hashed password that's already in the database. Password is what the user is sending us when they want to log in. So this has to match the plain password, and the user's password, which is already hashed, has to match the hashed password. So it has to go as the second argument. Again, we will raise an exception. And finally, if the user exists and the password matches, we will return user. Now let's raise these exceptions. First, I'm going to create the exception because we're going to raise the same exception in both cases. So up at the top, we're going to create a variable called credentials exception. And this is an HTTP exception. We're going to import that from FastAPI. So we'll say from FastAPI import HTTP exception. And we're also going to import status. The status code will be 401 unauthorized. And then the detail, we're going to say could not validate credentials. So now that we've got our credentials exception, we are going to simply raise it like that. Let's go over to our user router and we're going to write our login endpoint. So we're defining another endpoint called /token, and this is going to be used to get a JWT or access token or bearer token. The user will send us their username and password and we'll respond with the token. So I'm going to call this function login, and it takes in a user in because it needs the username and password. We're not going to be expecting a user ID. So then we simply say user is await authenticate user, and we pass in the email and the password. And remember, the password here is a plain text password because it's not in our database. This is what the user is actually authenticating with. Let's go up to the top and include authenticate user. And then all we do is access token is create access token, and we pass in the user email. Remember that authenticate user returns the user record from our database if the password matches and the user exists. So this will be the user record, or an HTTP exception will be raised, in which case we will not reach this line. So if we reach this line, the user is valid, it exists, the password matches, and we've got the email in this object. Let's also import create access token from there. That gets reformatted, and we can say access token equal that and return access token is access token, and the token type is bearer. This just tells the client what kind of token we've sent them and how to use it. Let's write some tests for this login endpoint. Let's go over to our test user, and down here we'll write our test. Let's first start with what happens if the user doesn't already exist. Well, we're going to send a request to /token, and we're going to get a 401 response in return. So that is what this looks like, and because it looks so similar to some of the other tests we've already written, I've just pasted it in. You've got your test, login user not exists, takes in an async client, and then makes the post request to /token. There is no fixture here called registered user, so there's no user in the database. We can send whatever we want, and then we will get a 401 in return. Running our tests, you can see they all pass. Now to actually log in, we just need to do exactly the same thing, but get the registered user as a fixture, and then send the registered email and registered password. So that is what this looks like. Again, get the async client and the registered user, make a post request to /token, pass in that email and password. Remember, the registered user fixture gives us back the email and password in plain text. So then we can send that over and get a 200 status code. You can see that we get one failed, so let's take a look at why that is. And here in the expiry of the access token, I've used datetime.utc, but I think it is incorrect. We've used datetime.utc, but we're supposed to use datetime.timezone.utc. Now run the tests again, and they all pass. Oh, my bad there. Make sure to include that. We should also write some tests for the new stuff we've written here in security. So let's go over to test security and write that. We're going to do from Jose import JWT. We're going to need this. And then we'll first test that the access token expiry function returns 30. This is maybe unnecessary, but it's good to get into the habit of testing all your functions. So we'll simply say this is equal to 30. Now we're going to test create access token. So we'll say token is equal to security create access token, and we're going to pass just a random subject. I know it expects an email, but really any string will do. And then we'll say assert sub is 123.items, and here we're testing for dictionary inclusion. And then we're going to say jwt.decode token. Then the key is security.secretKey. And the algorithms, it's actually a list now because it will use different algorithms one at a time if you give it multiple algorithms, and it will just check which one actually manages to decode the JWT. We've only got one, so we'll do security.algorithm. Don't forget your .items at the end. And now we're checking that this dictionary is inside the decode the JWT. It also contains expiry date and various other things. So that's why we need to do that. Let's run our tests. And you can see they all pass. Now let's go down to the bottom and write our tests for the authenticate user. So again, Pytest mark NAIO. And we'll do async def test authenticate user. This takes in a registered user. So that calls the fixture. And then we'll simply try to authenticate the user that already exists and see if we get the user back. So await security.authenticate user. We pass in the registered user email and the password. And then we expect the user email, which is returned in this object, to be equal to the registered user's email. And this is how we can check that the correct thing came back from this function. Now, let's see what happens when we try to authenticate a user, but it doesn't exist. So we'll do a pytest.mark.naio, then async def test authenticate user not found. We're not getting any fixture calls in here. And now when we call security.authenticate user with a user that doesn't exist, we're going to get an HTTP exception. So with Pytest, we can do with Pytest raises. And now whatever is inside this context manager is expected to raise an exception. If it doesn't, the test will fail. If it does, the test will pass. So we'll say security HTTP exception. And now this code here should raise an HTTP exception for the test to pass. So we'll do await security authenticate user test.example.net and 1, 2, 3, 4. Now running our tests, you can see they all pass. Finally, let's see what happens when we try to authenticate and we have a registered user, but the password is wrong. So I'm going to copy the authenticate user not found, but let's change the name, authenticate user wrong password, and we got the registered user in here. And we're going to use the registered user's email, but we're going to use the wrong password. I'm just going to put wrong password in here. And again, this should raise an HTTP exception. So running our tests, you can see that is what happens. And now we've got 20 tests all passing. So our application is getting more complicated, but hopefully you're seeing how all these building blocks go together. And none of the functions we are writing are that complex. And hopefully they all make sense in your head. But please do download the code, or if you're not writing it alongside me, which I would recommend. But do check out the code, play around with it, make some changes, break it, and then fix it again, as that is the best way to get familiar with it and to learn. Thank you very much for joining me in this video. I hope you've learned something, and I'll see you in the next one. Hi and welcome back. Now that users can send us their email and password and get an access token, we need to start working on the plumbing that goes on behind the scenes so that when we receive an access token, we can use it to calculate or decode or grab the user's email. We're going to do that in security.py. I'm going to go down to the very bottom and we're going to write a function that takes a token and does some work and eventually gives us back a user from our database. I'm just going to call it get current user, and this takes in a token, which is a string. The first step whenever we get a token is going to be to decode it. So let's try to do that. We'll say payload equal jwt.decode. We pass in the token, we pass in the secret key, and as we've done in our test, the algorithms as well, which only has one. Now this may fail with an expired signature error, and that simply means that the JWT has expired. So we'll say raise HTTP exception. Status code is going to be status.http 401. The detail is going to be token has expired. And we're also going to add some headers. This is just extra data that we're going to include in our response that tell the client some information. And what we're going to tell them is that in order to gain access to whatever endpoint that they were trying to request, they need to pass a valid bearer token because the one they passed was invalid. And we do www authenticate, and the value is bearer. This is just what this header means. This is a bit of extra information we send the client that tells them, hey, whatever you were trying to do failed because the token has expired. So To gain access to it, you need to authenticate with a valid bearer token that isn't expired. Let's import expired signature error. We go up to the top and we import it from there. Now, something you can do in Python that I don't see all that often is you can raise an exception, but you can say that the expired signature error exception caused this exception. What we have to do is give the expired signature error a name, such as E, and then at the end of the raise, we say from E. And this isn't strictly necessary, it just adds a little bit of information in the traceback to say that this exception caused this one. It's a good habit to get into. Now, if there was an error other than the expired signature error, we'll say except JWT error as E, and then we'll simply say raise credentials exception from E. And let's import JWT error as well at the top. We'll just put it in here, and there you go. Now, this credentials exception didn't have the header at the time, but it would be good to add it in here. That's because whenever we're doing any user authentication, we are going to use a token, so we tell the client that they need to send a valid token in order to authenticate. Let's add the headers, and again, www-authenticate, and the value is bearer. Saving this reformats it nicely. Notice that we could just use the same exception with both errors, but I wanted to change the details slightly, tell users that the token has expired down here, otherwise it's the same stuff. Okay, so once we decode the token, we can get the payload. So we'll say email is payload.get sub for subject. And of course, we deleted the variable there because it wasn't used. And if email is none, then we're going to raise a credentials exception. Now, after this try except huge block, we've got an email. So we can say user is await get user and pass in the email. We can say email equal email or just pass the email. Now, if the user is none, it means it wasn't found in the database, and we can again raise a credentials exception. Otherwise, we can simply return the user. And so we've done a lot of error checking here to make sure that we've got a valid user. First, we decode the token. If the token is expired, we return a 401. If there was some sort of other error, like the JWT was malformed or something, we also raise a 401. Then we try to get the email from the payload. And if there was no email in the payload, then we raise a 401. Then we try to get a user with that email from the database. And if it doesn't exist, we raise a 401. Finally, if none of those happens, that means that we've got a user in a database that matches this token, and we can return it. All right, let's write some tests. Let's go over to test security, and we're just going to write a couple tests here to make sure that this is working as we expect. So the first thing is to write one for success. So we'll say async def test get current user, and we will have a registered user already existing for this. We're going to say token is security.create access token and pass in the registered user's email. And we can do this because we've already tested create access token. We know it works as intended, so we can use it in other tests, and that's totally fine. Then we're going to try to grab the user using our function. So we'll say user is await security.get current user, passing in the token. And finally, we're going to make sure that we got what we expected. So there's a very simple test there. Simply calls that, and given the token, we should get back a user object. So what happens if it's not valid? Well, let's write a test for that. We'll say async def test get current user with an invalid token. And now we don't even need a registered user to exist there. We'll say with pytest.raises HTTP exception. We'll need to import that in a second. And we can say await security get current user, and we'll pass in an invalid token. Let's grab this and import it. Make sure to put the security in there, so it's the correct exception that's being handled. All right, let's run our tests. And everything passes, so we're good to go. Thank you for joining me in this video, and I'll see you in the next one. Hi, and welcome back. In this video, let's grab the token from the user's request so we can use it to get the user information. This function here, get current user, assumes that we've got the token from somewhere. So let's actually get the token. The first thing that we're going to need to do is to define where the token gets created. We're going to say from FastAPI.security import auth to password bearer, and then somewhere here we'll say auth to scheme equal auth to password bearer, and now we pass in token URL equal token. Here we've got the endpoint that a user can send their email and password to get a token back. That is, if we go to our user router, that's the token endpoint. That's what this defines. It helps FastAPI build its automated documentation. And it says, okay, you're accepting a username and password. In our case, it's an email, but it counts as a username. You're accepting a username and password, and you're returning a token. That's what this class defines. And the endpoint at which clients can send their username and password and get a token back is the token endpoint. So this here populates the automated documentation from FastAPI. And also, if we call this auth to scheme just like that, as if it was a function, this goes into the request and grabs the token. It's pretty handy. So it does both of those jobs, populates the documentation and lets us very easily grab the token. Now that we've got that, we can go into our post router, which is where we are going to use the current user. And here we're going to say from storapi.models.user, we're going to import user. And from storapi.security, we're going to import getCurrentUser and the auth to scheme. Now, wherever we want to access the current user, i.e., in any endpoint where we want the user to send us a token so that they can do something, we are going to use these two functions. For example, let's say that in order to create a post, a user needs to authenticate. Here we can say current user, which is a user object, equal getCurrentUser, and we call the auth to scheme. This is going to go into the client's request and grab the bearer token or the JWT, and it's going to pass it to getCurrentUser, which is going to make sure that token is valid, and then it's going to give us a user object that we are assigning to the current user variable. So already this means in order to create a post, you need an access token. In order to get an access token, you need to have logged in. You need to give us your email and password. So in order to create a post, you first need to log in. This is how you essentially protect an endpoint, by making sure that a user has created an account and logged in before they can make requests to that endpoint. If you don't include that, then anyone, anonymous users, for example, can create posts. If you include this, then users need to register before they can create posts. Now, we're not using the user anywhere to create the post, but what we can do later on is associate posts with the user that created them. And we're going to do that in the next couple of videos. For now, though, because we're not using it, I'm going to put no QA at the end so that this doesn't get deleted by the rough linter. We're going to do exactly the same thing to create a comment. We'll simply say, to create posts and comments, you first need to sign up and give us your email and password. You get a token, you send us that token whenever you want to create a post or a comment, and that's how you can create posts and comments. Those posts and comments are going to be associated to your user. But now that we are requiring users to send us a token to create posts and comments, we need to go and change our tests to make sure that a token is sent to these endpoints. So let's go into conftest.py, and here we're going to add another fixture that gives us the token. We'll say at Pytest fixture, async def logged in token, and this fixture here is going to take in an async client and also a registered user, and it returns a string. All this does is it tries to grab a token using our API. So we'll say response is await async client dot post to /token, and the JSON is the registered user. Make sure to not include too many brackets there. Notice that the registered user includes the user ID, but that's okay. Any extra fields that we pass to Pydantic will simply be stripped away if Pydantic doesn't need them. It's not going to raise an error. Let's add the response there and then return response.json access token. This is how we can get an access token for the registered user in any of our tests. If we now go to test post, we can make sure to use that in anywhere that we want to create a post or a comment. For example, here in async def create post, we can require the logged in token, which is a string. And now, whenever we make a post request, we have to send a header. So we'll say headers is authorization is a bearer and then logged in token. This is how these tokens work. You don't send them in the JSON body of the payload, you send them in the headers. So that means you have to include an authorization header. And by the way, headers are just like JSON payloads, but they go in a different place in the request, and they're used to add a bit of extra information or configuration for the request. So we add the header, authorization is the name of the header, and the value has to be bearer, and then space, and then the JWT. This is what's known as a bearer token. The name authorization is the standard name for this header that's used to send JWTs. We're going to do the same for create comment. So we'll add logged in token there, which is a string. And then here we'll add the headers, authorization, and the token in there. Now in the actual fixture created post, we also need the logged in token, which is a string, and we need to pass it in here. And in created comment, we also need the logged in token. And again, it doesn't matter the order in which these fixtures go in the parameters of the function. When we're testing create post, because that doesn't use the created comment or created post fixtures, we need to get our own logged in token in here, and we have to pass it in the headers. Similarly down here, create post missing data. We're going to get our logged in token there as well and pass it in the headers. And we should also create another test for when we try to create a post, but the token is expired. So we'll do Pytest mark NEIO and then async def test create post expired token. This takes in the async client, the registered user, and now one more fixture that we haven't used, which is the mocker fixture. Mocker allows us to modify the functionality of certain functions in our code. So what we're going to use this mocker for is to modify the access token expire minutes function to return -1 instead of 30. And that way, when we create a token, it will already be expired. So here we'll say mocker.patch. This is how we modify a function. And we'll say storeAPI.security.access token expire minutes. And the return value is going to be -1. You can see this is fairly straightforward in how it works. You pass a function, you need to pass in the full import path to the function, and then the return value, and that's how you can do that. Then we'll say token equal security.create access token, and we pass in the registered user's email. We need to import security, so let's go up to the top. Let's say from storeAPI import security. Then when we make a request to create a post, we should get back a 401. So here we have it. We're just making a post request to /post, passing in any JSON body, it doesn't matter, and passing in the bearer token, which, as you know, is expired. And now we should assert that the status code will be 401. And we can also assert that token has expired is in the response JSON detail. Right, let's try to run these tests. And you can see we've got a few failures and a few errors. Let's check that out. Maybe I've made a typo somewhere. I forgot something. Here in the post router, I forgot to pass in the request. So here we need to pass in the current request. In order to pass the request, all we need to do is import it from FastAPI. We'll say request at the top, and then down here, create comment, we'll say request is the request, and then just pass it in there. And we'll need to do the same thing when creating a post. The reason I forgot to do this is because in a couple of videos time, we're going to change this very slightly, and that's no longer going to be required. But for now it is. Okay, so we've got rid of all our errors. We've just got one failure. And that is that this needs to be awaited. And we also have to await get current user. So let's put the await on both of these. Now you can see all our tests pass except test create comment, and that's because we haven't given it the headers. So let's go down here and in test create comment, put our logged in token and then our headers. Now you can see that all our tests pass. Again, we've done quite a lot in this video. We have defined our auth2 scheme, which tells FastAPI to populate the automated documentation and where to get a token from using the username and password. Then in our post router, we've also made sure that the token is needed to create comments and posts. And we've done so by calling getCurrentUser and auth2 scheme, using await there, which I forgot to do, and making sure to pass in the request to here. And if you go into auth2 scheme and into auth2 password bearer, you can see that the object has a call method that takes in a request and simply goes into the request headers and gets the authorization header. And then basically if it doesn't exist or it's not in the right format, it returns a 401. Otherwise, it returns the value. Then we pass that to getCurrentUser, which uses the token to validate it and get the user from the database. Adding this line therefore means that in order to call /comment or /post, we need a token. And in order to get a token, the user needs to have previously sent us their email and password, which means that in order to create posts and comments, the user needs to register. We've then also added a bunch of stuff to our tests by the way of this logged in token fixture that we've created, and now we're passing it every time we need to create a post or a comment. So I know this is a little bit confusing. Remember that all the code is available for you to check out if you're not following along or if there's a lot of jumping around. I know that sometimes this development can be a bit confusing with so much text and jumping around between files. So feel free to download the code and check it out if you want to spend a little bit of time making sure you haven't missed anything. Thank you very much for joining me in this video, and I'll see you in the next one. Hi and welcome back. In this video, we are going to use dependency injection in FastAPI to automatically get the token from the request without having to call our function ourselves, the getCurrentUser or the auth2 scheme functions. So let's go to security.py, and here we're going to do from FastAPI import depends. And we're also going to need to do from typing import annotated. With these two, we can go down to the bottom, and now we can say this token here, instead of receiving it as an argument when we call this function, we're going to ask FastAPI to populate its value automatically when this function is called without having to give it a value ourselves. This is known as dependency injection, and it simplifies our code quite a bit. Here, instead of saying that the token is a string, all that we have to say is a token is an annotated string, and the value that should be given to this parameter is depends of auth2 scheme. And I know this looks a bit bizarre, but what we're doing is exactly the same as we were doing before, but now we no longer need to call auth2 scheme ourselves. It gets called for us, and FastAPI will do everything that it needs to do in order to get the value from this auth2 scheme, including passing the current request to it. So now, if we save this and we go to post.py, we would no longer need to pass in the auth2 scheme, but we can go a step further. We can do the same thing with getCurrentUser. So what we're going to do is we're going to do it in create post first because it's at the top. We are going to get rid of this current user line and of this request. And then we're going to do current user is an annotated user object, and its value is get current user. Let's import annotated and depends from typing, import annotated, and from FastAPI, import depends. Now you can see that we no longer need to import the auth2 scheme. We're going to get rid of that in a second. And the value of current user will get populated automatically by the dependency injection system. So it's no longer needed inside the body of the request. By the way, annotated only works with FastAPI as of version 0.95. So if you have an older version, you'll need to update FastAPI to work with that. If not, if you don't want to use annotated, you can do this. It basically means the same thing, but the annotated version is the new recommendation in FastAPI. So prefer it if you can. We'll do exactly the same thing in create comment. So let's go down here, get rid of the request and put our current user. And now we can get rid of that line, save it and gets reformatted. And that does exactly the same thing, but we don't need to call these functions ourselves. We don't need to await them. So that's pretty handy. You can see that running our tests makes them all pass. So this works in exactly the same way as it did before. All right, we've started learning about dependency injection, and it's really simple to get started with. You basically use depends and pass in a callable. Make sure to not call the callable, just pass in the callable itself, and its value will get injected when you call this function. There's quite a lot in the FastAPI documentation about dependency injection, so feel free to read through that if you want a bit more information. I'm going to leave it linked down below or in the resources section of this lecture. Thank you very much for joining me in this video, and I'll see you in the next one. Hi and welcome back. In this video, let's link together our users, our comments, and our posts. So here in database.py, we're going to add a new column to our post table, and what we're going to add is the user ID. So we'll say SQLAlchemy.column user ID, and this is going to be a foreign key, just as we did before with the post ID in the comments table. We're going to do users.id, and then nullable is false. And we'll do exactly the same down here with the comments. Now that we've got that, we can go into our models up here and make sure to add the user ID to these as well. So in user post, we're going to add the user ID, which is an integer, and in the comment, we're going to add the user ID. Now, if we go to our post router, when we create a post or a comment, we also want to insert the current user ID. So here, when we are deciding what data we're going to put into the database, we're going to do something similar to what we do when we return data. We're going to say post dict, and the user ID is current_user.id. Similarly, when creating a comment, it's exactly the same thing. Comment dict and user ID is current_user.id. Now in our tests, here we can also add user ID is the current user's ID, for which we need the registered user, which is a dictionary. And we'd put registered user ID in there. And we can do the same when creating a comment. Now let's run our tests. You'll fail. And you can see we've got a bunch of errors because we do need to recreate our tables. So that's important. Let's delete test.db, and also let's delete data.db at this point because that's also old from when we last ran our application. And let's run our tests again. And now this should pass. And there you go. So this is how you can add those relationships in your data. Now, in the next section, we're going to be looking at how users can like posts, because that's going to involve a lot more complex database interactions, including a many-to-many relationship. So thank you very much for joining me in this video and in this section. I hope you've enjoyed it, and I'll see you in the next one. Hi and welcome back. In this video, let's get started adding our like table to our database. Let's go to database.py, and here we're going to add the like table. Following the same structure as our other table, we make this a SQL Alchemy table, give it a name, add the metadata object, and then we'll define our columns. This table will have 3 columns: a unique identifier, a post ID, and a user ID, and it's going to define who liked which posts. We can simply grab these columns here and delete the body, which was unique for comments. So likes are very similar to comments in a way, but the comments have a body and they will be displayed differently by the client, presumably, and the likes are just +1 essentially. So you just count the number of likes for a given post, or the number of rows in this table that have a post ID equal to the post that you want to get the number of likes for. And that count of rows gives you how many likes the post has. Now that we've added this table, we're ready to add our endpoint in the next lecture. Thanks for joining me, and I'll see you there. Hi and welcome back. In this video, let's add our endpoint for liking a post. To do this, we'll first need to add some models. So let's go to post.py. And here you could create different files for likes and so forth. But I think it's going to be quite easy to add this to post.py because we only need 2 new models for now. Then at the bottom, we'll add our 2 new models, one to like a post and another one to output data. So what data will we be receiving when a client likes a post? Well, we need to receive the post ID. So we'll say class post like in. This is a base model, and all it has is a post ID, which is an integer. And then when we want to display a like instance, we will need the post that has been liked, the ID of the like, and the user ID that did the liking. We'll define our class, which inherits from post like in and adds the ID and the user ID. First, we'll need the like table from database, and then we'll also need our post like and our post like in. Now going to the bottom of the file, let's define our endpoint. This endpoint will take in a post like in as well as the current user. So this means that the user needs to be authenticated. Obviously, we need the user ID in order to do a like, so we need the user to be authenticated so we can get their ID. Then it will add a row to the table, and then it will return the post like object. We'll start with a post endpoint. The response model is a post like, and the status code is going to be 201 because this effectively creates a like in our system. Then async def like post, and here we'll need the like itself, which is a post like in. Remember, this tells FastAPI that this data is coming in the JSON body of the request. Then we also need the current user, which is an annotated user and depends of get current user. Now we can start with logger info and say liking post. And then we can try to get the post that this refers to, because if the post doesn't exist, we'll need to raise an error. So we'll say find post like.post ID. Remember that this post like in just has a post ID. Now, if this post doesn't exist, we will raise an HTTP exception just as we did in other places, such as here. So let's just copy that and bring it down there. Otherwise, if we didn't raise this exception, that means the post does exist. And obviously we have the current user already, since this is already validated by the time that we get into this endpoint. So now we have everything we need to actually add the like row to the table. We'll define first the data we're going to add. That's like.dict. And the user ID is the current user.id. Then we'll define the query that we're going to use to insert. We'll say like table.insert values and pass in the data. We'll always add a debug statement for the query here, just to make sure that we're doing the right thing when we're inserting data. And then we'll simply execute the query, which, as you know, returns the insertion ID. So we'll say last record ID, await database.execute of query, and then we will return the data and the ID. This is very similar to when we were creating posts or comments because it effectively does the same thing. Although this is quote unquote liking, it is just creating another resource in our system, which is the like. Let's go over to our tests and add a test for liking a post. First, let's write a function to like a post. We're going to be using this a few times. So how do we like a post? Well, we need the post ID, which is an integer. We need the async client, which is an async client, and we need the logged in token since the user needs to be authenticated in order to do this. And this is going to return a dictionary. And now all that we have to do is make the post request. So we say response is await async client dot post. We'll send to the like endpoint. Let me just scroll down a wee bit so it's a bit easier to see. The JSON is going to be the post ID, and the headers is going to be the authorization header, which has the bearer and the logged in token. Then we will return response.json. So this is identical to creating a comment or creating a post because the interactions with APIs are fortunately quite straightforward. You simply send your request, you send your data, and then you get some data back. This is one of the things I really like about backend development, which is a little bit more complex in front-end development. In front-end development, you have to worry about the browser sizes, mobile versus desktop, different browsers like Firefox or Safari, and what the user is doing, how they're moving their mouse, what things they're hovering over, what things they're clicking, and the interactions between them, etc. So it's got a bit more complexity, the front-end development. Back-end, you get data, you perform actions, you return data, and you're hopefully designing a system that's very deterministic. So that's what we're trying to do here. All right, let's write a test that likes a post. Let's go down, for example, to here. Before get all posts, after creating a post. I think this is a good place to write our test. But again, the order of these tests doesn't matter. It's just where you think it makes sense from a logical standpoint. And I think after creating a post, it makes sense to test liking it. But again, totally up to you. As usual, we'll mark it as async. Then we'll write test like post, remembering that the test underscore has to go at the front for Pytest. And this needs the async client, the created post, and the logged in token. And again, this just calls our API, so it's identical to the function we wrote earlier. This just uses the created post, likes it, and then checks that the status code is correct. We can just call the like endpoint with our post ID and our header, and then we'll say assert response status code is 201. If you like, and depending on how you want to do things, you could call the like post function. Just make sure to not return the JSON in here. You'll have to change the return type to just be the full response. And then you can just use this function and check the output's status code is correct. But I quite like having this function here that just gives me the API output, the JSON of calling this endpoint, and then maybe have a little bit of duplication here, but that's okay for me. All right, let's run these tests. And as you can see, everything passes, which is fantastic. Now that we've got our post liking functionality implemented, we need to actually get the like data when we retrieve data about posts as well. So let's do that in the next video. I'll see you there. Hi and welcome back. In this video, let's return like data when our clients request post data. The first thing we'll do is go to our post model, and then underneath user post, we're going to add user post with likes, which is a user post subclass. And all it does is add a likes, which will be the count of likes in this post. We also need to add a ORM mode of true. Then when we go to user post with comments, we're going to change this post to be a user post with likes. That's because we only use this class when requesting a specific post. So this is why we want to change that. Let's go to our post router, and then here in get post with comments, we need to do some work. The find post function that we've already defined goes into the database and finds a specific post by ID. We don't want to change this function because it is still useful to, for example, check that a post exists when we need to use it. But we do want to create another function or something that will allow us to get a post and the likes and the count of likes. In order to do this, we are going to write our first slightly more complex SQL Alchemy query. So let's go to the very top of the file and we're going to import SQL Alchemy. Then down here, not in a function, although you could put this in a function if you wanted, I don't think it's really necessary. We're just going to define a query. So we're going to say select post and likes, and this is going to be a SQL Alchemy select. And what we want to select from goes in here. So just as we would in SQL, we can pass in the specific columns that we want to select, such as the post table. And in SQL Alchemy, if you pass post table to select, it just means all of the columns in the post table. Just as we can with SQL, you can also call SQL functions that will run on the data that you've got available. If you're not very familiar with SQL, I don't really want to get into the nitty-gritty of SQL in this course, but it is helpful to know SQL in order to work with SQL Alchemy effectively. So what we can do here is call a SQL Alchemy function. We'll say SQL Alchemy.func.count, and this is a count function. This is like count something in SQL, if you are familiar with that. And then we pass in here the column that we would like to count by. So we'll say like table.c.id, and this will give us the ID column of the like table. We should also give it a label. This is akin to as something in SQL. So we'll say .label likes. Why do we need to give this a label? Because the model expects the likes property to be available when it does the validation. So this is why that's necessary. We are selecting the post table, but where does the like table come into play? This data we haven't selected anywhere. And we can say select from post table.outer join like table. Finally, we'll say group by post table CID. Let me bring these brackets back. I think it makes it quite a bit easier to see what's going on, and also black will format it a bit more nicely. As you can see, up until now, we've been doing post table.select, and then we've applied where clauses. This is the extent of our SQL Alchemy querying up until this moment. And when you do this, SQL Alchemy knows that you want to select from the post table. This is a shorthand for doing SQL Alchemy, SQL Alchemy.select post table, select from post table, which obviously is pretty repetitive. So SQL Alchemy gives us this shorthand, which is nicer. But what we're doing here is we're saying, okay, grab me all of the columns from the post table and this extra column that I've labeled likes, which runs a SQL function. And where do we want to select it from? We want to select it from post table that is joined with like table. If you're not familiar with SQL joins, it's what allows us to merge two tables together temporarily so that we can get data from two or more tables at once. So that's what we're doing here. We are joining the post table together with a like table. And essentially what this does is for each post in our post table, you get 0 or more like table rows. By grouping by the post table's ID, you shrink that back to a single row per post. And when you do that, you can count on things that are essentially hidden by this grouping. And I know that is quite difficult to understand. I would recommend learning about SQL if you're not familiar with it, because it's really going to help make more sense of what's going on. I will leave a couple of links in the resources section of this lecture to some information on how this works. We've got a SQL ebook that I will leave linked. But again, learning about SQL is definitely worthwhile for working with SQL Alchemy effectively. At the end of the day, what we end up with this query is a row that has all of the post data and the count of likes for that post. So now that we've got this query, we can simply use it. So let's go down to get post with comments, and we're going to make a small change. Instead of post equal await find post, we're going to say query is equal to select post and likes. And notice that this is a SQL Alchemy query, so we can still modify it. And we can modify by saying where post table CID is equal to post ID. And then we'll say logger debug query, and post is await database.fetch1 of query, and spelling it correctly helps. Now we've modified what was going on by adding an extra column, which is the likes column. So now that we modify the output of this function, if we run our tests, we should see one of them fail. So let's run Pytest. And you can see we get one post failed because in one of our tests, we say that post is equal to created post. That's our fixture that returns the value of the post when it is created, the JSON body. But that post doesn't contain the count of likes. It only contains the post data. Let's go to test post, and that is get post with comments. This post here contains everything except the like count. We can modify that by putting this in a dictionary, destructuring the existing data, and adding likes is 0. So let me just save that so it's a bit easier to read. And now you can see that we're checking the post that is returned by this endpoint should be equal to all of the data of the post plus this extra piece of data. Now, if we run this test, we should see it pass. And there you have it. All our tests now pass. In this video, we've learned how to create a SQL Alchemy query that we are then going to reuse. And I've called this extracting a query because we're not putting it in a function that we're just calling. We've got essentially a partial query, although it is a complete query just on its own. But I like to think of it as a partial query that we're then going to extend by adding where clauses and things like that. We're going to be using this query in a couple more places in the coming video. So hopefully this makes sense. Remember to check out the links where we talk about SQL. It's helpful to understand that in order to know how this works. So thank you for joining me, and I'll see you in the next video. Hi and welcome back. In this video, let's take a look at the enum class in Python, how we can use it with FastAPI, and how to do post sorting based on some properties. To begin, let's go up to the top of the file and we're going to add a couple of imports. So we'll say from enum, import enum. This is a built-in Python library, so you don't have to install anything. And we're also going to import user post with likes. Then in the get all posts function, we are going to make quite a few changes. First, let's not just get all posts. Let's get all posts with their likes sorted by the number of likes. So let's change this list to user post with likes. And we are going to change this query. We're going to say select post and likes, but we are going to add an order by clause. Order by in SQL simply orders by one of the columns we've selected. We have selected all of the columns in the post table as well as our likes. We can sort by likes. We'll say select post and likes, order by SQL Alchemy DESC likes. And here we pass in the column name. DESC simply means descending. So we're going to get the post with the most number of likes first, and these are going to be in descending order from greatest to smallest. There we have it. This is how to add likes sorting. It's pretty straightforward once you've extracted your query. But what if we wanted to allow users to sort in different ways based on a piece of data that they send to this endpoint? That is quite a common approach. We're going to allow by recency, newest post first or oldest post first. And then we're also going to allow sorting by likes. When you have a set of predefined options, it's helpful to use the enum class, as that is what it's for, and FastAPI has good integration with the enum class. So we'll say class post sorting, and now we define what kind of enum this is. So that's a string and an enum. And then we simply say new is new, old is old, and most likes is most likes. And this has been unimported now from enum import enum because I saved and we've got the auto fixing on. And now this looks a bit pointless, but what this allows us to do is do post sorting.new, and now we'll get the value of this string, which means that if we in the future want to change this string, we don't have to change any of our code because this value that is internal to our code doesn't have to change even if we want to change this string. So for example, if instead of new, you wanted to change this to be -id for descending ID order, you could do that. And then the API would have to change how it sends us data, but we wouldn't have to change our code. So that's a good reason to use enum. Also, using enum defines that these are the only 3 options for post sorting. And FastAPI, like I said, has good integration with that, because now when we get all posts, here we can add a sorting value, which is a post sorting, and a default value of post sorting.new. Now, FastAPI will know that this, because it's not a Pydantic model, it is an enum, is going to be coming as a query string parameter to our API. So it's going to be like http api.com/post sorting equal most likes, for example. This is what FastAPI will now expect the requests will be like, and we can grab the value of most likes, put it into our sorting parameter, and use it in here. FastAPI will also validate that the value of sorting is one of these 3 strings. So that's quite helpful as well. Now that we've used this to order by a specific column, I'm sure you can do the rest. We'll need an if statement and then change the query value based on the value of the sorting variable. Let's start with if sorting is equal to post sorting new, and we'll say query is equal to select post and likes order by post table CID DESC for descending. When you have an actual column object, you can call the DESC method on it. If you don't have a column object, but you do know the column name, then you can do it like this. In VS Code, you can select multiple columns and then press Option Shift down to duplicate them. So we're going to do that and select old. And instead of DESC, we're going to say ASC. Then we're going to select them again and press Shift Option down. Option is the same as Alt, by the way. And most likes. And now we are simply going to use our query that we already defined earlier. Instead of multiple chained if statements, let's use elif. And if you're using a very modern Python version, you can also use the match case. But since it's quite a new feature of the language, I think it's maybe something people are not really used to. But if you did want to use it, it is match sorting and then you define individual cases like this and put your query in there. We've got a blog post on the match case operator, so you can have a look at that if you want to learn more about it. Totally up to you which one you want to use. For now, let's stick to the if statement for greater compatibility with other Python versions. And most importantly, because I think this is very easy to read, the match case adds another level of indentation, and I don't think it's necessary for this specific bit of code. But again, totally up to you. Both features of the language are fine to use here. Now that we've got our sorting, we need to write some tests for sorting. And here's where we're going to introduce the Pytest parameterize functionality. So let's go to test post. Then here where we're getting all posts, we are going to write our first tests. Let's write a single test that checks the posts are returned in the correct sorted order. The default order is by recency. So let's just write a test that does that, and then we'll adapt the test to use parameterize, since that's going to simplify our work quite a bit. We'll say at Pytest mark neio async def test get all posts sorting async client and logged in token. Now you could pass in the created post in here, but we need at least 2 posts for this to actually be relevant, since you can't sort a single post. So I'm not going to use the fixture, and instead I'm just going to call await create post. I'm just going to call 2 of these functions, test post 1, and pass in the async client and the logged in token. And then again with shift and option, we're going to create test post 2. We don't need the response values of these because we know that this is going to be post ID 1 and this is going to be post ID 2. But if you like, you can put this into a response and use those values instead. Now, when we get all the posts, we'll do await async client dot get post. And these posts should be sorted by recency, since that's the default value. So we'll say assert response status code is 200. And the data is the response JSON. And now we have to define what the expected order for these posts is. So we'll say expected order. Expected order is first post with ID 1 and then post with ID 2. Now, what actually came back from our data, where we can say post IDs is post ID for post in data. Remember that data contains a list of posts, so we are just grabbing the ID of each post in that data. Then we can compare the expected order and the post IDs. We can say assert post IDs equal expected order. Now let's run this test. So I'm just going to copy the name and then do Pytest k and pass in that name, and you can see that it failed. And why did it fail? Because I've got the wrong expected order. Of course, the most recent post first, which is a default value, should be 2 and 1. So there you go. Writing tests is pretty helpful. It makes you realize when you've made a mistake. So that's the expected order when the default value of new is selected for the sorting. Now, it's good practice to pass in the sorting value here. So we'll say params is sorting is new. That's the default value. Now, running this test again, it passes. So now you may think, well, we can just copy this, right? Put it down here, change this to old, change this to 1 and 2. I'm just gonna change this name to old. Now we can run both of these tests and both pass. But there's a lot of duplication between these two tests. All that's changed is a string, and that produces a slightly different response. So this is a prime candidate for parameterizing this. What we can do with parameterize in Pytest is we can pass in certain values to a test, and the test will run with those values. So if we pass to the test the sorting and the expected order, we can simply interpolate those values into the test and have one for new 2, 1, and have another test for old 1, 2. And Bob's your uncle, we don't need to duplicate everything. So let's get rid of this test and let's add the parameterize here. So we'll do a pytest.mark.parameterize, and we pass in the names of the parameters that we want in our function. So that's sorting and expected order. This is a single string, by the way, which is a little bit confusing, but there you have it. And now that we've got that, we can pass those parameters in here. Sorting, which is a string, and expected order, which is a list of integers, just as we have down here. And now we pass in a list of tuples, where each tuple has the sorting and the expected order. So we say new and 2, 1. And we say old and 1, 2. Now the test will run twice. One with new and 2, 1 being passed to sorting and expected order, and again with old and 1, 2 passed to sorting and expected order. So as long as we use sorting and expected order, well, we can just delete this really, because it's got the same name. Then that should be us. Let's run the test. And now you can see that we used Pytest-k to select this test, and there's only one test with this name, but we got 2 passed. So this test ran twice effectively. Something that is unfortunately a bit more tricky to do is to test the likes, because we not only need to create posts, but we also need to like the posts. So for that, we're going to need a separate test. Let's copy this test. And I'm going to hide the terminal to give us a bit more space. We'll do Pytest mark any IO, put this test in here, and we're going to say sort likes. We're not going to need the sorting and expected order arguments. And then we do need to create the 2 posts, and we're also going to say await like post, and we're going to pass in a post ID, which can be 2 async client and the logged in token. And now when we sort by most likes, we should get that the expected order is 2, 1. So we can say expected order is 2, 1. And actually, I'm going to change this to 1, 2, and we're going to like post 1, just because we don't want the test to be testing the same as the default value. Let's use something that isn't the default, and that way we make sure that the test actually is doing something. So let's run that, Pytest-k, pass in that test, and that passes. Now, what happens if we pass a sorting method that doesn't exist? Well, we should test that as well. So Pytest mark any IO, and we'll say async def, and we'll give it a name. This just needs the async client, and we don't even need to have any posts. We'll simply say response await async client dot get. Remember that we don't need the logged in token to retrieve posts, so that's why we're not passing that. We'll say sorting is wrong, for example. And we should not forget the equal sign. Response status code is 422. This is what the response will be by FastAPI. Let's grab that and run it, and you can see that passes. For good measure, we should also run all our tests. And upon running all our tests, we can see that there's actually a failure here because in get all posts, we are assuming that the response JSON will be the created post, but actually this includes likes. So we do have to remember to pass in likes 0 in here, just as we did for getting a single post with comments. We have to pass in that. Alternatively, this could be a good place to use dictionary inclusion, as we've done in a few other places, to ensure that the created post is inside the JSON. And again, if you prefer to do that, that would be created post dot items is inside response JSON 0 dot items. And if we run this test, you can see that it passes. It ran 5 tests because there's a few tests that start with that. Let's run all our tests again. And you should see that they all pass. So again, this is an option. Alternatively, you can use equal equal, and that's totally fine. Here, because we don't care about likes, this is perfectly acceptable. So in this video, we've learned quite a lot. We've looked at Pytest parameterize, which is a really helpful tool for simplifying tests that use various pieces of data together, but otherwise are identical, such as when testing sorting methods. And we've also looked at enums for receiving query string parameters using FastAPI that have specific values, such as these 3 specific strings here, and then how we can use it in our code. Remember that the benefit of this is it defines specific values, it has good integration with FastAPI, and if you wanted to change what the API uses to communicate with you, you don't have to change the code that actually uses the enum. So benefits all around, highly recommend using that when you have specific values that the API can interact with. So overall, in this section, we've added likes, and that is a many-to-many with posts and users. So one user can like many posts, and each post can have likes by many users. These many-to-many relationships are usually a bit intimidating, but you can see that with this method that we've been using in this course of defining the data that you want to store, the models that you want to interact with, and then the endpoint, it flows quite nicely, and the development is fairly straightforward in terms of what you have to do as a developer to implement this functionality. There is something important about backend development, and that is you have to know how to interact with your data, and for that, learning SQL is highly recommended. So again, there'll be links throughout this section to our SQL ebook. Highly recommend that you give that a read, and if you're not familiar with SQL at all, that you take a course or spend some time learning about it. Thank you very much for joining me in this section. I hope you've enjoyed it and you've learned a lot, and I'll see you in the next video. Hi and welcome back. In this video, let's start working on email confirmation. When a user registers, we're going to give them a link that they have to click, and when they click it, our API is going to receive some data. We're going to identify the user, and we're going to mark them as confirmed. So let's think, what data can we send the user so that when they click the link, we get that data back and we can use it to identify the user and then to mark them as confirmed in our database? Well, we've already got a piece of data that we're using to identify our users every time they send us it, and that is their JWT. As you know, whenever a user logs in, they get a JWT and then they send us that JWT in every request, and we can decode the JWT and use it to identify the user. This is safe because users can't tamper with the JWT, and also it's easy because the JWT is just a string, so it's pretty easy to give it to the users and to get it back from them. With email confirmation, things are a little bit different because we want to be able to give the user a link, and when they click it, then they are confirmed. So what we're going to do is we're going to, when the user registers, give them a link, and in that link is going to be, in the URL, a JWT. When they click the link, that is going to go to our API. In that endpoint, we're going to extract the JWT from the endpoint, and we're going to use it to identify the user and mark them as confirmed. However, we can't use the login JWT or the access token to confirm users, because if we did, then a user could register, get the confirmation JWT, and then use it to access protected endpoints without confirming their user first. So we want to keep the confirmation JWT and the access JWT separate. Let's begin by creating a new kind of JWT here in security.py. We're going to call this a confirmation token as opposed to the access token. So let's go to access token expire minutes, and we're going to copy that and then create another function called confirm token. expire minutes. We're going to make this return 1440, which is 24 hours. Whereas an access token only lasts for 30 minutes before the user has to re-authenticate, the confirmation token is going to last for 24 hours, so they can click the link in their email after a few hours in case it doesn't arrive very quickly. Then when we create the access token, we are going to include in the payload the subject and the expiry date as we have been doing, but we're also going to add a type of access. This is going to allow us to tell which kind of token the user has sent us. If the type is access, we'll know they're trying to log in or to authenticate. If the type is confirmation, we know this is a confirmation token that we can only use for email confirmation and not for access to protected endpoints. So with that said, let's copy this create access token function, paste it in here, and we're going to call it create confirmation token. Now we're just going to change this to confirmation token. The expiry time is going to be confirmation token expire minutes, and the type here is going to be confirmation. Now the next thing we want to do is go down to the bottom, and in the get current user function, where we use the access token to retrieve the user, we need to check that the type of token is access, because we don't want to use a confirmation token for login. So we're going to say here, type is payload.get type, and then we'll say if the type is none or the type is not access, then we're going to raise a credentials exception. And we're going to improve on this slightly in the next video. We're going to reduce this duplication slightly, but in a way that makes the code a bit simpler without adding any complexity. There we have it. Now, whenever the user tries to log in, they need an access token. A confirmation token will not be allowed for accessing protected endpoints. Now let's write a couple of tests for the new functions that we've added. So let's go to test security.py, and then at the top where we've got, for example, test access token expire minutes, we're going to copy that and make sure that we have a test for the confirmation token. So we're going to say test confirm token expire minutes, and confirm token expire minutes should be 1440. Then in test create access token, we're going to make sure that the type of access is returned here as well when we decode the token. And we're going to copy this test and do something similar for the confirmation token. So we'll say test create confirmation token, and we will say create confirmation token. And here the type should be confirmation. So we're just checking, making sure that the correct type is returned when we call the appropriate function. And you could parameterize this with Pytest. You could pass in the function as an argument and the type as another argument and then compare the two. This is so simple that I don't think it's necessary, but you know how to parameterize, so you could do that if you wanted. Then down at the very bottom of this file where we've got test get current user with invalid token, we're going to write another test, which is for getting the current user, but the wrong type of token. So if they get a confirmation token and they send it to us, we're not going to allow that. So again, Pytest mark any IO, then we'll define our function. We're going to say get current user wrong type token, and we're going to get the registered user, and all we're going to say is grab the token, but we're going to create a confirmation token. So we say create confirmation token with the email, and then we'll assert that this should raise an exception when we try to get current user, because the confirmation token should not be allowed for that function. So with Pytest raises security.http exception, and we'll say await security get current user and pass in the token. Let's run our tests, and you can see that they all pass. So in this video, we've started implementing our new confirmation flow. We've created a new type of JWT, which is the confirmation token. And the reason why we're using a JWT is because it's just a string, so we can put it in the URL when we send a URL to the users to click to confirm their email. We have created the confirm token expire minutes and create confirmation token functions. We've included a new type claim in the JWT payload of access for the access token or confirmation for the confirmation token. And we've made sure that the type has to be access when we're getting the current user, since we use this for authentication and we're not going to use it for email confirmation. We're going to write other functions for that. So thank you for joining me in this video. I hope you've enjoyed it, and I'll see you in the next one. Hi, and welcome back. In this video, let's start working on getting information from the confirmation token. We need to decode the confirmation token and extract the email from its payload. And this is something that we're already doing for access tokens in the getCurrentUser function. Most of this function, and all of this, is concerned with decoding the token and getting information out of it. The rest of the function is actually getting the current user with that information. So we can extract this into another function and then pass in an argument to the function that will allow us to detect whether it's an access or confirmation token. And then that's it. We can simplify our code a bit. Let's cut this out. We're going to leave this as is for now, as it will remind us to come back to it and fix it. And then here under create confirmation token, we're going to create a function that will allow us to get the subject field in the payload for a specific token type. So we'll say get subject for token type. We pass in a token, which is a string, and the type of token, which is also a string, and this returns the email or the subject in the token. So let's paste in the code that we cut earlier. And now this is almost ready really for this function. The only thing that we need is to make sure that we return a string. So here, after we get the email and we check the type, we simply do return email. The other thing that we have to do is, instead of checking that the type is always access, we are going to allow either access or confirmation by doing that. And this variable and this argument are called the same. So let's rename this one to token type. If token type is not none and the token type matches this. And we'll just raise the credential exception if the token type is incorrect. Otherwise, we'll return the email that we've gotten from the JWT. There are a couple of improvements that we should make in this function, and the first one is something that I should have done earlier on, so my apologies for this small error. You should only put in the try except block code that may raise the exceptions that you're checking for. So in our case, jwt.decode may raise expired signature error or JWT error. The rest of this code doesn't raise those exceptions. So we should take it out of the try and just put it after, like this. This is just a better practice. It reduces the indentation levels of the code, so makes it easier to read. And also it allows us to very quickly tell that these exceptions are only related to this line of code and not to these. This is a better way of writing this function. Again, apologies for making this mistake earlier on in the course, but this is slightly better. The next thing that we should do is make sure that we use the correct type hinting for this string. The type string may only be either access or confirmation. So we should tell Python that only one of those two values should be passed in here. The way we do that is by going to the top of the file and importing the literal class from the typing module. And then down here under type, we're going to say literal access and confirmation. Saving this now reformats it like this. And what this says is the type value should be either the access string or the confirmation string. Next up, we can do a small improvement on our exception handling. And that is because here, when we have an expired signature error, we're returning an HTTP exception, but the detail says token has expired, which is good. But when we get a JWT error, we raise this credentials exception that just says could not validate credentials. And this is fine, but we can do slightly better and ensure that the error message matches why the exception was raised. When there's a JWT error, we want to say that the token is invalid. When the email is missing from the sub in the payload, we want to say that the token is missing the sub field. And when the type is incorrect, we want to say that the token type is incorrect. So we're going to go up to this credentials exception, and we're going to turn it into a function that returns an exception instead of the exception itself here. So we'll say def and then call it create credentials exception. And this takes in a detail, which is a string, and returns an HTTP exception. Then in the body, we're simply going to return the HTTP exception, but the detail is going to be the argument that we passed. Now that we have this, we can call this and pass in the appropriate detail string instead. So here we'll say token has expired. And now this raises the exact same exception, but it's a bit easier to create the same exception with a different detailed message, such as invalid token here and there. We're going to say the token is missing the sub field. Finally, down here, we're going to say that the type was incorrect. So we'll say token has incorrect type, expected type, for example. Now we can call get subject for token type down at the bottom of our file in getCurrentUser. We can say the email is get subject for token type, and we pass in a token and we pass in access. And indeed, here you can see how the literal annotation works. As soon as I stop typing a string, Visual Studio Code says that these are the two options for the value that I can pass to this function, access or confirmation. Of course, I can still pass whatever you want, but Visual Studio Code hints that it should be either access or confirmation, so that's pretty helpful for us as developers. Again, remember that in Python type hinting, there's no validation that the values you're passing match the type hinting. It's just to help you out. If you use something like MyPy, you can use that to validate your type hinting, and it actually tells you where you've gone wrong. So that's an option if you want to do that. For these other credentials exceptions, we're going to do the same thing. So we'll say create credentials exception, and we're going to say invalid email or password. And we're going to do the same here. Remember that when you're checking emails and passwords, you don't want to tell a potential attacker which one is incorrect. You don't want to let them know that the email they've chosen is correct, or indeed the password they've chosen is correct. And that's why we say invalid email or password on both exceptions. Finally, here we're going to say create credentials exception, and we'll say could not find user for this token. Now let's write some tests for our get subject for token type function. Let's go over to test security, and here under creating the confirmation token, we're going to write a few tests. First, let's test it when the token type is valid. So we'll say test get subject for token type valid confirmation. And we will simply get an email, test@example.com. We'll get a token, which is security create confirmation token, pass in the email, and then we will assert that the email is equal to the security get subject for token type. We pass in the token and confirmation. And then we'll do exactly the same for an access token. So we'll copy that, create access token, and pass access in here. Because confirmation and access are the only two values that we may pass to this function, we should write a test for each of them to make sure that they both work. For parts of the function where we don't care what type the token is, we are simply going to use one of the two. And it's up to you which one you use. The common recommendation is to use the token type that is most commonly used in your application, and that would be access token. So now that we're going to check, for example, when the token has expired, we're going to use an access token for that. Also, let's rename this to access. Let's write our next function, which is get subject for token type expired. And this uses the mocker fixture. We'll patch access token expire minutes. So stored API security access token expire minutes, and return value is -1 to make sure that the new token is already expired. We'll get an email, test@example.com. We'll get a token. And again, here we're using access token instead of confirmation token, although it doesn't matter which token you use. The most commonly used kind of token is what you should normally test in these cases, and that's an access token in our application because it's going to be used whenever users want to authenticate. The confirmation email is only used once per user. There you go. This should raise an exception. So with Pytest raises security HTTP exception. And we're going to say as exe info, we're going to use that in a second to make sure that the detail of the exception is correct. We'll do security, get subject for token type. We pass in a token and we pass in access, making sure that the type of token that we've created, which is an access token, matches this string. We want to make sure that this test fails because the token has expired and not because of anything else. Then we'll say assert token has expired is equal to exeinfo .value.detail. And this is how you can access the detail property of the exception object and check that it is correct. All right, let's run our test. So we do Pytest, stored API, tests, test security, and all the tests pass. So that's great. Next up, let's write a test for when the token is invalid. So we're going to copy this one. And now we don't need really any of this. We can simply say token is invalid token. We don't need the mocker fixture. And we can then assert that this raises an exception. Down here, it should say invalid token. Let's change the name to invalid token. So let's run our tests. And you can see that now they all pass, and we've got 17 tests in here. A couple more tests that we should write match the different paths in our application. So when the sub field is missing, we should have a test for that. and when the wrong type of token is passed. So let's write those two tests. The first one is for when the sub field is missing. So we'll say test get subject for token type missing sub. And here what we're going to do is we're going to create a token and then delete the sub field from it. So we'll say email is test.example.com. The token is security create access token, and we pass in the email. Then we will say the payload is JWT.decode, and we pass in the token, the key, and the algorithms. Then we're going to delete the sub field from the payload, and we're going to re-encode it. So we'll say token is JWT encode, and we pass in the key and the algorithm. Now that we've got this token that is missing the sub field, we can run it through the function and make sure it raises an error. So we'll say with Pytest raises security, HTTP exception, exe info, and we'll say security get subject for token type, and we'll pass in a token and access. Then we will assert that token is missing sub field is in the detail. There are a couple of ways that you could do this instead of creating an access token, decoding it, deleting part of it, and then re-encoding it. You could create your own JWT that already doesn't have a sub field, and I'll show you how you can do that. Instead of all of that, you could do this. You could get the current time, add 3600 to it so it lasts for an hour, get the payload, which doesn't have a sub field, and then just create a token. This is basically the same thing as that. But if the payload in your JWTs has more fields, then you'll want to do this to make sure that you're not missing any of them. This is a simpler way to do it, but you could potentially run into some other issues if you're missing many things from your payload. So that's why I think this option is slightly better, but either option is fine. This, you just need to import the time module, which comes with Python if you want to use that. In any case, neither of the two options is what I would call beautiful code. It does feel slightly hacky, but it's the best we've got. Now that we've got this test, let's finalize our test suite with the wrong type of token. So we'll say test get subject for token type, wrong type. And now we will simply create a proper token, but make sure that we try to decode it as the wrong type. So we'll say token is security, create confirmation token, and we'll pass in the email. And then with Pytest raises security or HTTP exception as exe info, and we'll try to do security get subject for token type. We pass in a token and we say access. And now you can see that this should fail because this is a confirmation token and we're saying it is an access token. So it should fail at the end of the function. And we can assert token has incorrect type, expected access to be the exception info value detail. Okay, let's run our tests. And you can see one of them has failed. I've probably misspelled something. Yep, here in JWT encode, we have to pass in the payload, not the token. So that's my bad. Make sure to pass in the payload in there. Otherwise, you're re-encoding something that's already encoded, and that's not gonna work. So there you go, 19 tests passed. We're ready now to continue. So in this video, we have created our get subject for token type function, which takes in a token and the kind of token it should be, and then gets the subject field from the token, which is the user's email. This is going to allow us in get current user to make sure that the user has provided an access token and not a confirmation token. And later on, when we start confirming users, which we're going to do in a couple of videos time, we're going to be able to check that the token they've passed for confirmation is a confirmation token and not an access token. Thank you for joining me in this video. I hope you've enjoyed it, and I'll see you in the next one. Hi, and welcome back. In this video, let's start writing our user confirmation endpoint. The first thing to do is go into database.py, and in the users table, we're going to add another column for whether the user is confirmed or not. This will be a SQL Alchemy column. We'll call it confirmed, and the value is SQLAlchemy.boolean. The default value is going to be false, and we need this so that when we create a new user, false will be the value in this column. Later on, when we confirm the user, we will change this to true. So all users will be unconfirmed until we say otherwise. Now we can close this file and go to our routers and user. And in here, we're going to write our new confirmation endpoint. Let's go down to the bottom of the file and do @router.get. And this has to be a get because we're going to send this endpoint in the email to users, and users are going to click it. And when they click this endpoint or this URL, they're going to be opening their browser and coming to this URL, and that is going to make a GET request. Remember that when browsers access a URL, they always make a GET request, and they don't make POST requests. So that's why this has to be a GET request. Then we'll do async def confirm email, for example, and this is going to have the token that comes in from the URL. And this is going to be the JWT. So this is going to be a fairly long endpoint, /confirm/ and then probably 50 to 60 characters, which is the JWT, the confirmation JWT that we create. When they access this endpoint, the token is here in the URL. It's not in the authorization header, because again, we want this to be very easy to access with the browser using just the URL. Now that we've got the token, we can say email is get subject for token type, pass in the token and also the confirmation type. Now we need to import this. We can go up to the top and import it here and make sure to add the variable again. Now that we've got the email, we can say query, and we're going to write a query that goes into the database, gets the user that matches this email and confirms it. So we'll say user table.update. And this is going to allow us to modify a row of the user table in place. We'll say where user table.c.email is equal to email. And now we say .values, and we can pass in what values we want to update in this row. And that is confirmed equal true. Let's do logger.debug and debug the query. And then we'll say await database.execute, pass in the query, and finally return detail user confirmed. And this is all that we need to do for email confirmation in this endpoint. So again, what we have to do is now send this to the users in an email. Users are going to receive that email, they're going to click the URL, they're going to come to this endpoint with the token already in the URL. We're going to grab it, we're going to get the email from that token, then we're going to update the database, and then that's it. Now in subsequent requests, they can send us their JWT, and when we get the current user using their actual access token, we're going to see that the user is confirmed and they're going to be good to go. So how do we give the user something to click in their email? We're going to be dealing with sending emails in the next few videos of this course, but for now, when the user registers, we're going to give them the URL. So they will register, then we'll show them the URL that they can click. Obviously, this is not great because we're not sending an email, but like I said, we're going to send the email in the next few videos. For now, so that we can make sure this is all working, let's just show the URL here when they register. So instead of returning user created, we're going to return user created, please confirm your email. And we're also going to pass in here a URL. Let me just reformat this like that. The confirmation URL, which we can get with request.url4, and we have to have the request. We can get it with request and request in here, which comes from FastAPI. Request.url4 allows us to generate a URL for a particular endpoint. So what endpoint do we want to generate a URL for? It is the confirm email endpoint. So we just put that in there. And the token, well, we have to create it. Create confirmation token for user email. We need to import this as well. So let's grab that, put it in there. So now you can see that when the user registers, we give them a message of the user has been created and to confirm the email, and we give them a URL for them to click. As I mentioned earlier, we're going to be putting this in an email. We're doing this just temporarily so we can test that this is all working. So with that said, let's go over to our tests and test user, and we're going to be writing a couple of tests here. Under the registration tests, I'm going to put this here, but again, it doesn't matter where the tests go. You can put them at the bottom if you prefer. I've just got them here in my notes and I want it to match my notes so that the code at the bottom of this page, or if you download the code, you can see that it matches exactly what you've written. In here, we're going to write Pytest mark any IO, and we're going to write a test for user confirmation. So we'll do async def test confirm user. This takes in the async client and also the mocker fixture. Now what we're going to do is we're going to register a user and then look at the response, grab the URL from the response and call it to see if it works. We'll do spy is mocker.spy, and this allows us to look at a function but not replace its return value or how it works. So we'll do request URL4. We have to import request from FastAPI, so we'll do from FastAPI import request. Then we'll do await register user, passing in the async client and an email. 1, 2, 3, 4. I realize that sometimes I'm using .NET and other times .com. I'm sorry, that's just force of habit. I'm actually more used to using .NET for these tests, but it doesn't matter obviously what email you use. Now that we've registered the user, the spy is going to let us look at what arguments request.url4 was called with, but this is still going to work. This is not going to replace how request URL4 works or what it does. Let's grab the confirmation URL. Confirmation URL is str of spy.spy return. We can do this grabbing the return value of the last time the spy was called by doing spy.spy return. And we can do this because it is only called once in this entire flow. If we were calling this in multiple places in our application, this wouldn't be an optimal approach, but over the next few videos, we're going to do slight modifications to this and it's going to be a better solution. For now, this is how we're going to do it. Later on, we're going to make small changes to make this a bit better. Now that we've got the confirmation URL, we can say response is, and we can make a request to it, async client.get confirmation URL. And now we can simply assert that this responds with a 200 and with user confirmed. We'll say assert response status code is 200 and assert user confirmed in response JSON detail. All right, let's run our tests. So the Pytest StoryAPI tests routers test user. You can see that all our tests fail because we've got test.dp here that we have to delete in order to make sure that the new column gets created. So let's do that and then run the tests again. And now they all pass. So what happens if the user tries to call the confirmation endpoint, but they don't have the correct token, or maybe they make one up, or it's an invalid token? Well, let's write a test for that. So we'll do test confirm user invalid token. This takes in an async client, but we no longer need to call the mocker fixture because we're not going to be using the return value of that function. So we'll say response, await, async client, get, and then confirm invalid token. Then we can assert that the response status code should be 401. Let's run our tests. And now we've got 6 passed. Finally, what if they try to confirm their email but too late after 24 hours have passed? So we're going to check with an expired token. Now we're going to copy the confirm user, but we're going to change the name to expired token. And as well as spying on URL4, we're going to do mocker.patch StoryAPI security confirm token expire minutes. The return value is going to be -1. And this means that the confirmation token that gets generated and then used for the confirmation endpoint is going to be expired. So when we try to do a GET request to that endpoint with the expired token, this should fail. And we should get a 401. And token has expired should be in the detail of the exception that gets returned. Let's run our tests, and now we get 7 passed. So there you have it. We have implemented our confirmation endpoint that simply takes in a confirmation JWT, uses it to get the email, and then goes into the users table and updates the corresponding row with confirmed equal true. Thank you for joining me in this video. I hope you've enjoyed it, and I'll see you in the next one. Hi, and welcome back. In this video, we are going to require confirmation before users can access protected endpoints. So down here in authenticate user, we just have to add a few lines, which are if not user is confirmed, then we are going to raise an exception. So we'll raise create credentials exception, and this is going to be user has not confirmed email. Now, just these two lines have a surprising effect on our application, and now most of our tests will fail because throughout our test suite, if we go to conftest.py, we have been using this fixture, registered user, and this user is not actually confirmed. There will be some places in our application where we will want to use registered user, which is not confirmed, but there are other places in our application where we will want to use a confirmed user. So we have to create another fixture for confirmed user. So let's do that. Let's do Pytest fixture and async def confirmed user. This takes in a registered user, which is a dictionary, and returns the same user but confirmed. So what we have to do is go into the user table, update, and then do where user table c email is equal to registered user's email, and then do values confirmed equal true, and we have to run this query just as we did in the confirmation endpoint, and then return registered user. This is going to take the registered user and confirm it, and then give it back to us, so that in any endpoint where we need the user to be confirmed already, we can just swap out that fixture for this one. So let's copy that name because we need to do it in a few places. When we log in, we need a confirmed user and not just a registered user, because we now require confirmation, is what these two lines do. Then if we go to testpost.py, there are a few places here where we need the confirmed user. So when we do test create post, here we need the confirmed user instead of the registered user. When we do test create post with expired token, we also need the confirmed user. And when we test create comment down here, we also need the confirmed user. And that's it. I don't think we're using registered user anywhere else here. We can go into test user, and we need to make a few changes here as well. Down at the very bottom, we have test login user, and this one needs the confirmed user as well. But we also should have a test for when we try to log in, but the user is not confirmed, and that should return a 401. So let's write that test. Pytest mark neio async def test login user not confirmed. And this takes in an async client, also the registered user, remember, not the confirmed user, because we want to make sure the user is not confirmed when they try to log in, and that should return an error. So response is await async client.post. We go to /token and we pass in the email and password. I'm just going to copy it from there by using the registered user. Let's save this so it gets reformatted nicely. And then we assert the response status code is 400, making sure to bring back the response there since it got deleted. Okay, let's run our tests, and we should have 8 passing tests. One failed because actually this response code is 401, so let's run that again, and now they all pass. Brilliant. We have now required confirmation, and we have our 2 fixtures, one for confirmed user, one for registered user, and we are ready to continue in the next video. So thank you for joining me in this one. I hope you've enjoyed it and learned something, and I'll see you in the next one. Hi, and welcome back. In this video, let's talk about Mailgun, which is the platform we're going to use to send emails to our users. To get started with Mailgun, go to mailgun.com and then get started for free at the top right. During registration, you don't have to provide payment info if you don't want, and then you'll be limited to sending from a sandbox domain only to 5 authorized recipients. If you want to send emails to any user that registers to your application once you've deployed, you'll have to add payment info and you'll have to pay for the email delivery. Signing up without payment information lets you learn about how to send emails and test the service. Once you've logged in, you can access your sandbox domain, and then here on the left under Overview, you'll be able to see this screen for your sandbox domain. If you're not sure if you're on your sandbox domain, at the top right, you can see what domain you're on. The first thing you'll want to do is add your own email address to the authorized recipients list here on the right. You'll need to receive an email and click an email confirmation link when you do that. Then your email will be added to the authorized recipients. You'll then be able to send emails in your API to just that email. So here I can send emails to my email address. Once you've done that, you can select the API option for sending emails. You will need your API key and the sandbox domain name. We'll save those two to our .env file in our application. So copy them, then open your .env file and add here dev mailgun API key and dev mailgun domain, and then populate the values for them too. Once you've done this, go over to config.py and add these two in here. Mailgun domain, which is an optional string, defaults to none, and mailgun API key, which is also an optional string and defaults to none as well. In dev config and later on in prod, when we deploy our application, we'll be able to access the values. We won't need to send emails when we are in test mode. And in fact, we want to avoid sending emails when we're in test mode. So what we'll do throughout our tests is make sure that when we try to send an email using Mailgun, that we actually intercept that call and don't actually send the email. All right, now that you've signed up to Mailgun and you've got your configuration ready, in the next video, we can start actually sending Mailgun emails. I'll see you there. Hi and welcome back. In this video, let's start sending emails with Python and Mailgun. In Store API, let's create a new file called tasks.py. This is going to hold the background tasks that we're going to ask our FastAPI to run in the background to send emails. There are a few things that we're going to need. We're going to need the logging module, we'll need HTTPX, and also we'll need our config. Then let's create a logger that we will use throughout the file. Now let's write a function to send an email. We'll do async def send simple email, and this needs a few values. We need who we're sending the email to, the subject of the email, and the body of the email. This is going to send a simple text-only email. It's not going to include any HTML. First, let's add a logger statement that includes a little bit of information so that we know who we're sending an email to and we can kind of detect what's going on when our logs are visible. And then we'll do async with HTTPX async client as client. And we're going to simply send a request to the Mailgun API. Just as we are making an API here to deal with social media, Mailgun has a web API that deals with receiving data about the email we want to send, and then they actually process the email sending, and then they send us a response back saying, yeah, we've managed to send that email or we haven't. Let's say response is await client.post, and this needs to be a post request that we send to Mailgun. And then we need HTTPS api.mailgun.net/v3, and then we need the config mailgun domain, and then /messages. This is the URL that we have to send our post requests to for Mailgun. So that's api.mailgun.net/v3, then our Mailgun domain, which is the sandbox domain that we're currently using, then /messages at the end. For authentication, we use API key authentication or basic auth, where the user is API, and we include Mailgun API key there. Then we also need to include some data, which is from. And here you're going to include your name, for example, my name, and then inside the crocodile clips, we're going to put the email address that we're sending from. And for the sandbox domain, that's mailgun at, and then the Mailgun domain. This is the way to commonly spell out the name and email address of a sender. You've got the email, and then inside crocodile clips, you put the email address. This is widely understood by most email clients. Now that we've got the from key, we also need to, and this can be a list of email addresses. So we're going to create a list, and inside it, we're going to put the argument that we've received. And that's just a single person that we're sending emails to. For subject, we've got the subject, and as text, we've got the body. For Mailgun, we can send HTML as well as a separate key if you want to send an HTML email, but HTML emails are pretty complex and they actually don't perform that well in most cases. You're fine using simply text emails for most cases. If you want to send complex HTML emails with a lot of images and styles and stuff like that, it's normally better to use a different kind of service for sending that email. It's an email marketing service that you use in those cases, like MailChimp or Drip or ActiveCampaign or ConvertKit. Those are some examples. But for most transactional emails, you're okay sending simply plain text. Once we've got our response, there is a method of the response object called raise4status. And what this does is it raises an exception if the status code does not start with 2 or 3. For status codes that start with 2, that means okay and everything is successful. And for status codes that start with 3, that means a redirection took place. But for status codes that start with 4 or 5, that normally means an error has taken place. So when you call response.raise4status, then you'll get a Python exception raised if the status code of this response starts with 4 or 5. For example, a 401 or a 400 or a 500. Then we're going to do logger debug response content. And finally, we're going to return the response. Now, when you do raise4status, you can get an HTTPX exception. So let's catch it. Except HTTPS status error. There you go, as error. And then what we can do is we can re-raise our own custom exception so that it's a bit easier to catch later. And we know that what happened was an HTTP status error. So we'll create our own API response error exception. And we can simply say pass in the body to inherit from exception. And then we can raise this and say that the API request failed. So we can say raise API response error, API request failed with status code, and say error response status code. Remember to say from error there to include the appropriate context. There you have it. This is a function that sends an email using Mailgun. But whenever we call this function, we have to include the subject and body, and we can make it a bit easier to send a registration email by adding another function that simply calls this function. So here I've pasted in another function that does send user registration email, takes in an email and a confirmation URL, and then calls send simple email with the email that we want to send it to, the subject, which is successfully signed up, and then some text in here. Because this text is quite long, I think it's a good idea to write this function rather than pass these arguments when we want to call this function in our routers. I'll show you more in a second. Remember that in Python, if you have multiple strings one after another without a comma at the end, Python just concatenates them and joins them together. So this is a way to create a long string without needing the plus signs at the end, which is also something you can do, but it's not necessary. But you do have to put these inside brackets if you want to use that feature of the language. So now we've got this function that we can call at any point to send the email that tells users that they've signed up and they need to click the link to confirm their email address. So now let's go to conftest.py, and here we're going to write a fixture that will make sure that we can't call the Mailgun API accidentally. We'll do Pytest fixture, auto use is true, and then we'll say mock HTTPX client. We pass in the mocker, and what we'll simply do is say mocked client is mocker.patch, storeapi.tasks.htpx.async client, and we're going to patch the async client that we use in our tasks module. And all we'll say is whenever we make a request using this specific async client, is going to return a 200 and it's not actually going to call the API. So we'll say mocked async client is mock. The response that we want to return in any case is a response that we need to import. So let's go up to the top and say from unit test mock import async mock and mock. And from HTTPX, we're going to import request and response. The response that we want to return whenever we make a request with this async client is a response that has a status code of 200, a content of empty string, And we also need to include the request that is why we're sending a response back. The request is a post request, and the URL to which the request was sent, we're just going to include this, which is the home URL. And it's responding to a request made to this URL here. We need to pass this in because we have to give it what URL the request went to, but we don't care what the value is. Now that we've got these things, let's glue them together, because I know that up to here, this is quite a confusing situation. We'll say mocked async client.post is async mock, and the return value is going to be the response variable that we've created there. And what about this mocked client? This mocked client also has a return value. And something tricky about this mocked client is, how do we use httpx.async client? Let's go over to tasks.py. You can see we say async with httpx.async client as client. So we're not saying client equal httpx.async client. We're actually using it in an async context manager. What we want to say in this mock client is mock client.return value.dunder aenter. And this is the method that runs when you do async with httpx.async client. And what we want to say is that when that method gets called, the return value of that is going to be the mocked async client. Let's walk through how this works. What I'm going to do is I'm going to save this and bring tasks.py on another tab, and then we're going to hide the sidebar just so you can see how it works. Let me increase the size of this slightly. You can see this is where the async client gets used. Because this fixture is automatically used, that means that no matter what, the httpx.async client is our mock. When we do httpx.async client and we have the two brackets at the end, this creates an object of type async client, or that calls the async client constructor. So when we do mocked client.return value, what we're saying is we're replacing the value of this thing here. When we do async with and then that thing there, that's calling the dunder aenter method of the thing. The aenter method's return value is mocked async client, which means that this client variable is the mocked async client. I know this is quite confusing, but stay with me. If you need to pause the video, rewatch this, or try to type it out and have a think about it, please do so by all means. So once we've got our mocked async client here, we're using it to send a post request. So that's why the mocked async client's post method is equal to async mock. And the return value of making this post request will be the response. So instead of this post request, we're going to simply skip it and get this response back. The response variable in our tests will always have a status code of 200, empty content, and it will say that the request wasn't to mailgun.net, but was to just // What we have achieved with this fixture is we've made sure that this request never actually happens in our tests. We always get a 200 status code back. What we'll do with this is we can make sure that we have made the call to Mailgun correctly, but we can't verify that Mailgun is actually sending the email or is responding with the right thing, because that's up to them. They should write their own tests that make sure that they are responding with the correct stuff. We can only ensure that we're sending the right stuff. So even if we mock the Mailgun API and we're not actually using the Mailgun API, we can test that we're sending them the right stuff. And we can only hope that they work correctly when we run in production. What we're also going to do at the end of this fixture, although it will seldom be used, is we're going to return the mocked async client just in case we need to use it somewhere else. Now let's close this tasks.py and bring back the sidebar, and we're going to create a new file inside tests called test.tasks.py. Here we're going to import httpx, import Pytest, and from storeapi.tasks, we're going to import API response error and send simple email. Then we're going to write a couple of tests. First, let's make sure that when we call send simple email, we're actually making a call to a third-party API. So we say async def test send simple email, and we'll get the mock HTTPX client. And then all we have to do is send simple email, making sure to await the function and pass in some values. It doesn't matter what you pass, because remember, the email should not actually be sent. But what we can do is mock HTTPX client .post.assert called. This is going to check that the post method of the mock HTTPX client was actually called. And that means that we sent a request to somewhere. The next thing we can do is check that if the API responds with something that isn't a 200, we get an API response error. So we'll say Pytest mark NAIO, and then async def test send simple message API error mock HTTPX client, and sorry, this should be test set simple email. Then we'll say mock HTTPX client .post.return value, and we can override the return value of the HTTPX client's post method. We can say HTTPX.response, and we can pass in a different response. So we'll say status code is 500, content is empty, and the request is HTTPX.request post and 2 forward slashes there. What this means is that normally when we use the mock HTTPX client, or in any case, in any of our tests, because the fixture is auto use, the response is going to be a 200. But in this specific case, we're overriding the response and it's going to be a 500, which is an error. So now we can say with Pytest raises API response error is await send simple email, and we can just pass in another value. So let's run our tests, make sure they all pass. And you can see we've got one failed test. I think this was actually from earlier where I forgot to change something from registered user to confirmed user. So that's my bad. Let's go over to test security, and here in line 99, this should be confirmed user. That's my bad. Let's run those tests again, and now they should all pass. And there you go. Everything passes. We are actually making requests to the Mailgun API, which should produce an email in our inbox. In the next video, we're going to wire up our tasks with our user registration endpoint so that when a user registers, we can send them an email to tell them that they need to click the link. So thank you very much for joining me. I hope you've enjoyed this video, and I'll see you in the next one. Hi, and welcome back. In this video, let's use the code that we've got in tasks.py to actually send an email. So let's go to our user registration endpoint, and here at the top, we're going to import our tasks. So we'll say from store API import tasks. Then down here, instead of including the confirmation URL in the response of our registration endpoint, what we're going to do is we're going to say await tasks.send user registration email, and we have to provide the user's email as well as the confirmation URL, which is this request URL for there. So we're going to copy that and say confirmation URL is that. Remember that our send user registration email function only takes those two values, and then it constructs the email and sends it using Mailgun. So we no longer need to include that there in the response. Now let's go over to our tests, and we are going to make a couple of changes because we no longer need to spy on the request. We now can spy on our task function. So let's get rid of that, and instead we'll say from store API import tasks, and then in our confirmation test, we're going to make a small change. We're going to say spy is mocker spy, but we're going to spy on our tasks, send user registration email. And then we need to get the confirmation URL argument that we give this function when we call it. So we need to get the second argument to this function when we call the function. So here the confirmation URL is no longer spy return, but it's spy.callargs, and this is a tuple with two values. The first value is a tuple of arguments, and the second value is a dictionary of keyword arguments. Here we are passing confirmation URL as a keyword argument, so we need to use the second value of call args, and then we can access it as a dictionary confirmation URL. That's why we passed it in as a keyword argument. If you passed it in as a normal argument, then you'd have to go into 0 and then 1. I just think this is a little bit less readable, so we're doing this instead. We're passing in the confirmation URL as a keyword argument, and then we're accessing it like this. We'll do the exact same thing down here. So let's just copy that, paste that in there, and copy that, paste that in there. And now let's run our tests. And you can see that all our tests pass, which means that we have successfully called our task, and the confirmation URL that we've passed to the task function is correct, because when we make a request to it, we confirm the user. Because we have separate tests for our task function, we don't have to do any more testing in this function here. We can assume that because this works, we've called the task with the correct function, and the task has its own tests, that everything is tested in our system. If we run our app, and I know that we haven't been doing this with Insomnia because we've got our automated tests, we don't have to use this, but we can try this out and actually send an email and see if we receive it. So let's send the request, making sure to send a post request to /register and include the email, which has to be the email that you've added to your authorized recipients in Mailgun. Then you should receive an email that looks like this one, and it probably will be in your spam folder because we're using the sandbox domain and Mailgun. Once you register a domain and you use an actual domain, you've got some configuration done, it's less likely it will end up in spam. But for now, it will probably end up in spam. It should look like this. You should be able to click it, confirm your email. Let's grab this link here. I'm just going to copy it, go over to Insomnia, and I'm going to create a new request in here, and we're just going to put that in there and hit send, and now you get user confirmed. You can post to token, and you should be able to get an access token. Of course, you can do this just by clicking the link and doing this in your browser. That's totally fine. I just wanted to show you what this kind of looks like. Either option is fine. Thank you for joining me in this video. I hope you've enjoyed it. In the next video, we're going to start looking at background tasks so that we can not send the email while we're responding to the request, but we can delay sending the email for a few seconds so that our API can respond to requests faster. I'll see you in the next video. Hi and welcome back. In this video, let's look at background tasks. From FastAPI, we're going to import background tasks like that. And then we are going to add this to our function parameters. So here in the register function, as well as the user and the request, we're also going to add background tasks, and this is a background tasks. When you do this, FastAPI will inject what you need into this variable so that you can use the background tasks. And background tasks in FastAPI are very simple, quite powerful, and it's unlikely you'll need anything else, but there are more powerful options, which I'll discuss in a second. So now that we've got the background tasks here, what we can do is we can ask FastAPI to run any function that we've got in a background task. If the functions that we try to run are async, FastAPI will automatically await them for us. So here, this send user registration email, all that we're going to do is we're going to say background tasks dot add task, and we are going to pass in send user registration email, and that is the first argument to add task, is the function that we want to run. Then we pass in all the different arguments for this function. So this is argument 1 to add task, this is argument 2 to add task, and then this is a keyword argument passed in to add task as well. As you can see, we're not calling send user registration email, we're just passing the function to add task, and it will automatically await this function when it runs it and pass in the rest of the arguments or keyword arguments to that function. The benefit of this is that now the actual email sending doesn't happen while we are responding to the user registration request. When a user sends us their username and password, we're just going to run through our code, add the background task and respond, but we don't send the email because that is the slow bit of this request. We have to talk to Mailgun and send them some data, make an HTTP connection, etc. And that can take a couple of seconds. by putting that in a background task, it will run later and our registration endpoint will be much faster. If you have a lot of users trying to register at the same time, this is when adding a background task becomes really powerful and greatly increases the performance of your API without you having to do any extra work. So let's save this and go over to our tests. And now one final change. Instead of importing the tasks from Store API, we're going to say from FastAPI import background tasks. And now we're going to spy on add task. So we'll say spy is mocker spy of background tasks add task. And because the confirmation URL is still a keyword argument, and it's the only keyword argument that we're passing to add task, this here doesn't have to change. Still, we're doing call args1 for the keyword arguments, and then we're accessing the confirmation URL as a dictionary. So we're good to go there. We're going to copy this, go down here and do the same thing in this other test. And that's it. That's how you can use a background task with FastAPI. As you can see, very simple. You just add this parameter to your endpoint function, and then you can call it with add task. Something to note is you want to use these FastAPI background tasks for input-output bound jobs. That is, jobs that are slow because you have to talk to another service or you have to send data or wait for data to come back. You're not actually using your computer's CPU to perform computationally heavy tasks. So for I/O bound tasks, the FastAPI background tasks module is brilliant. It works very well. It doesn't impact performance very much because it's not really doing anything. It's mostly just waiting for data or sending data away and then waiting for a response. So for this kind of thing, fantastic. If you want to do something like, for example, run a machine learning model, which is computationally expensive, you don't want to do that in a background task because that will affect the performance of your API. Even though it's running in a background task, it's still the same Python process. Maybe with Python 3.13, this will change or improve, but we're not there yet. That's a long way away. That's just me speculating. So if you have a computationally expensive task, you don't want to use FastAPI background tasks. You want to use something like an RQ worker and a task worker. When you use something like RQ or Celery, these are two options, you have a separate Python process, usually in a separate server, consuming the tasks and executing them one at a time. But because it's in a separate server, or at least a separate Python process, it doesn't affect the performance of your API. If you'd like a little bit more information on RQ workers and this kind of background task queues, we've got some information from our REST APIs course with Flask that uses RQ workers. I'm going to leave that linked in this lecture. But it is rare for a REST API to perform computationally expensive tasks. So that's why FastAPI ships with this background tasks module, because for 90% or more of the background tasks you'll actually want to run, this is perfectly acceptable and it doesn't impact your performance at all. But if you have a computationally expensive task, you'll need to look at something else. And again, that's linked in this lecture. So thank you very much for joining me in this video and in this section. I hope you've enjoyed it and you've learned a lot of new stuff. Thanks for joining me, and I'll see you in the next one. Hi and welcome back. In this video, let's get started working on file uploads. We're going to need to add a couple of dependencies to our requirements.txt. We need AIO files for working with the file system asynchronously. That's what the A stands for. And we're also going to need B2 SDK, which is the Backblaze B2 software development kit. We are going to ask the client to send files that they want to upload to our FastAPI server. And then instead of storing the files in the server, we're actually going to send them to Backblaze B2, which is a third-party file storage service. That way, we're not going to run out of disk space in our server, and our application will be able to continue running. And Backblaze B2 is really cheap to store a lot of files in. It's a good place to put everything that our users give us so that we can access it later on. We're also going to need to get some configuration variables from Backblaze B2. We're going to need the B2 key ID, also the B2 application key, and we're also going to need the bucket name. With these three things, we can authenticate with Backblaze B2 and upload files to the bucket that we've selected. All right, now we're ready to actually get started uploading files. I'll see you in the next video. Hi and welcome back. In this video, let's code a Python file that will help us interact with Backblaze B2. We're going to go into our Store API folder and create a new folder called libs. Then inside it, we're going to create B2. And inside that, we're going to create a file called dunder-init.py. When we put something in here, let's say x = 5, we can then import from B2 from anywhere else. For example, let's say we go into main.py and in here we want to do from storeapi.libs.b2 import x. This is something we can do because x is defined inside dunder-init.py. If we call this file anything else, let's say client.py, then we would have to do from storeapi.libs.b2.client import x. So that is a special case with the dunder-init file. When you import from a folder that contains dunder-init, it automatically goes into dunder-init. So this just helps keep the imports a little bit cleaner. The other benefit of using dunder-init.py is that if the B2 library that we're going to create had multiple files to do different things, we can keep some of those files within the B2 folder, but not necessarily expose them to be imported, because we can just put what users might be able to import inside dunder-init.py and keep other stuff that's internal to our library in other files. So those are two benefits for using dunder-init.py. But the main one really is that it's a little bit cleaner to do our imports. Our library is only going to have a couple of functions, and we're going to put them all in dunder-init.py. I will add a few imports. We're going to need the logging library for actually doing logging whenever we're running one of our functions. And then we'll use LRU cache because there are a couple of functions in this code that will only need to be calculated once, and then they won't change no matter how many times we call them. And then we'll also use the Backblaze B2 SDK in version 2 and also our config file. Then let's start by first authenticating with the Backblaze B2 API. So let's create a function called B2 API. And in here, all that we have to do is grab our authentication details from our config file and then call the API and send them. So we'll do info is b2.in-memory account info, and then we'll use this in-memory account info to authenticate with the API. So we'll say B2 API is B2 API and pass in the info. And now this may look a bit weird, like maybe you should pass the API keys and stuff to in-memory account info, but the B2 API doesn't actually work like that. I feel like that would be more obvious. How it works is we have to do B2 API.authorize account and then pass in production, because we are storing files in the production environment, and there's very little documentation as to what this string actually means, but it just has to be production. And then we pass config B2 key ID and config B2 application key. Now what happens is this authenticating information gets stored in the in-memory account info, and when we do authorize account, then that goes in there, and this gets used by the B2 API to authenticate. Then we say return B2 API, and this is one of these functions that only has to be calculated once because it's always going to be the same. We're always going to get the authenticated B2 API. The authentication details are not going to change. This doesn't take any arguments, so there's nothing for this function to calculate past the first time it calculates something. And this is a good place to use LRU cache. That way we can effectively use this function as if it was a constant. And just by calling it once, it actually runs. Every subsequent time that we call it, it doesn't run. It just uses the stored cached value. Now, when we want to use the API to get the bucket that we're going to upload files to, we can do something very similar. So we'll say B2 get bucket, and we're going to get an API. So we'll say decorate this with b2.b2 API, and this just returns API.getBucket by name and pass in the B2 bucket name that we defined in our config. And again, this is something that's never going to change because our application only uses one bucket. if you are making a large application with lots of different clients, and you want each client to be able to use their own bucket, or you want to be able to define a bucket per client, then obviously you would do this a little bit differently. But for now, this is not necessary. Also, don't feel like if you have many clients, you have to use a bucket per client. It's just not necessary. And that falls under the same category as using a database for each different client. It's most of the time not necessary. You can put everything in the one bucket, and that's totally fine. Finally, we get to actually using this to upload a file. We'll say b2 upload file, and this is going to take a local file, which is a string, and a file name, which is also a string. So the local file is the path, and the file name is the name of the file that we want to upload and how we want to store it in Backblaze B2. First, we'll say API is B2 API, and notice that the first time that we call this, it will actually calculate and authorize the API, but the second time or any other times that we call this, it will use the cached value. And then we'll say uploaded file is b2 get bucket, and we pass in the API that we just calculated there, and then upload local file. And very conveniently, the arguments to upload local file are the same as to this file. So we'll say local file is local file, file name is file name. And now we've got our uploaded file. So what this does is actually processes the upload, sends the file in this path with this name to Backblaze B2. So this can take a few seconds or maybe a little bit longer depending on the connection speed. But normally when you use a production server such as one provided by render.com or Heroku or DigitalOcean, they have incredibly fast internet speeds. So the uploads take very little time. Once you've uploaded the file, we're going to say download URL and api.get download URL for file ID, and we pass in the uploaded file .id underscore. The uploaded file is an object that gets returned, and we can access the ID underscore value of it to then ask the API to fetch some information about that uploaded file. And what we want is the download URL. When you upload a file to Backblaze B2 into a public bucket, you can get a download URL for that file, so that just putting that URL in your browser will let you download the file or see the file if it's a photo. By doing api.get download URL for file ID, we can actually get that URL. If we then wanted to, for example, display the uploaded image, assuming this was an image, in a website, we can simply use the download URL and put the download URL on the website, and the image will be displayed, as long as we use the correct HTML. So that's why the download URL is very useful. Finally, we can return the download URL, because this is actually going to return the string, which is the download URL. Let's add a little bit of logging, because we created our logger, but we haven't done any logging. And I think it's useful, especially when interacting with third-party APIs, to at least do a little bit of logging so you know what's the last thing that happened before a problem occurred. So we're going to do logger.debug, creating and authorizing B2 API. Now we're going to print this out into our logs. And if then there's a problem immediately after, we're going to be able to see the stack trace, which will tell us we're about here, but we'll know that this executed and the problem was maybe around here. Or if the problem was somewhere else, this will help us determine exactly where, or at least more or less where. Now, after we get the B2 API, we can also do logger.debug down here and say something like uploading local file to B2 as file name. And this is going to give us that information in the logs as well. Now, after we upload the file and we get the download URL, we are going to also have another debug statement, which is going to be like that. Uploaded local file to B2 successfully and got this download URL. I think this is enough logging, but remember that you may always add logging later. If you encounter an issue and you're not sure how to solve it, you can add more logging in your application so that the next time the issue occurs, you have more information. But you don't want to overdo it to begin with, because then you can log too much. All right, so we've written our B2 library, and this is just a collection of functions that we are going to use in our application to interact with the API. And that saves us from having to write code that interacts with the dependency directly in our routers, etc. So it just makes our code a little bit simpler when we go to actually code the endpoints, which we're going to do very shortly. So thank you for joining me in this video, and I'll see you in the next one. Hello and welcome back. In this video, let's start working on our upload endpoint. We're going to go to routers and create upload.py. And in here, we're going to write another API router that will handle the file upload. I'll just bring in a few imports. We are going to use the login module, of course. We're going to import temp file. This is a built-in module in Python that allows us to create temporary files, which is where we're going to store the file that the user uploads or the client uploads. And then we're going to delete the file once we've taken that and put it into Backblaze v2. So the flow is going to be the client sends us the image to our server into a temp file, and then we send it to b2, and then we delete the temp file. That's basically going to be the flow for the file lifecycle. We're going to import AIO files because this allows us to deal with saving what the user sends us in an asynchronous fashion. I'll show you exactly what that means when we code the endpoint. We'll also, of course, import a few things from FastAPI, and we're also going to import our b2 upload file function. Important thing here is the upload file, which we're going to use from FastAPI to receive the file asynchronously. In order to receive a file asynchronously, the client will split up the file into chunks. Each chunk is going to be 1 megabyte. Then the client sends us chunks one at a time, and FastAPI has the asynchronous functionality to receive a chunk, and while the chunk is uploading, it can deal with a different request. And then when the client finishes sending us the other chunk, it will handle the next chunk and then wait for the client to send us the following chunk. And in that time, while it waits, it can deal with something else. And that is the asynchronous file upload functionality that upload file is going to give us. Finally, when the client sends the last chunk, then FastAPI will finish putting all the chunks together into the temporary file and upload it to Backblaze v2, and then we'll delete the temporary file that contains all of the chunks. That's the lifecycle of our upload endpoint. The first thing we have to define is the chunk size that we want to allow the client to send us. And we're going to define 1 megabyte, which is 1024 times 1024. That's how we define 1 megabyte. And then we're going to say add router.post upload, and the status code is going to be 201, async def, upload file, and we need the file that's being uploaded. And remember that this file here may not be the complete file in one go, it may be chunks of a file. In order to get the next chunk, we do file.read chunk size. And this is an asynchronous method of the upload file class. And essentially, it reads the chunk that has already been uploaded if a chunk has finished uploading. So for as long as the chunk is still uploading from the client, the data is still reaching our server, this doesn't do anything. When the data finally all reaches our server, the whole 1 megabyte, then this will handle that chunk, or it will read it and give us a variable that we can then store in a file. So first, we're going to put this in a try catch. We're going to say with temp file.named temporary file as temp file. This is going to create a temporary file in our file system. And at the end of this context manager, it's going to delete the temporary file. So within this context manager, we're going to get the different chunks that the client is uploading, and we're going to save them. And then we're going to put it in Backblaze v2 when we're done. And then the file's going to get deleted. So we'll say file name is tempfile.name. Then we're going to add some logging because this is going to be pretty handy. Saving uploaded file temporarily to file name. This can be handy in case something goes wrong and you have to check the temporary files, see if they are being created successfully in your file system and what's happening with them. Then we'll say async with AIO files.open file name, and we are going to write. So we'll say W, but we're not going to write text. We're going to write whatever it is that the client is sending us. We're going to write chunks of binary data. So we say WB for write binary as F. And now we'll say something very modern in Python. We're going to grab the chunk. So we can say chunk is await file read chunk size. But we need to be able to do this over and over for as long as the chunk is not none. So you could do while chunk, then await f.write chunk, and chunk is equal await file read chunk size. But this duplication here in these two lines, and Python has a brilliant new syntax for doing exactly this. So we'll say while chunk, which is equal to await file.read of chunk size, exists, then we do await f.write chunk, and we can get rid of those two lines. This is the walrus operator, and I don't use it a lot, to be honest, but it comes in handy in this specific instance. So we're going to keep it for that. And then once all of the chunks have been read in an asynchronous fashion, doing other things while the data uploads, the chunk will be equal to none. This while loop with exit, because we've written everything to the file. Then the file is ready to be uploaded to backplace B2. So we'll say file URL is B2 upload file. Local file is file name, and the file name is file.filename. The file name here is the temporary file's file name, which is the actual stuff that we want to upload that's stored in our computer until it is deleted. But we want to tell backplace B2 that when the user uploaded the file, it had a name. If you uploaded, for example, wallpaper.png, you want wallpaper.png to end up in backplace B2, not some random string of numbers and characters that is used for the temporary file name. So that's why we're passing these two things, and that's why they're different. All right, so if there's an exception, then we're just going to raise a 500. If something goes wrong here, we're just going to say, crash. We can't deal with this because we're not sure what went wrong. So we'll say raise a GCP exception. The status code is going to be status 500. And the detail is going to be there was an error uploading the file. Finally, if that doesn't happen, we are going to return that the upload was successful. And of course, we want to send back the file URL so that the user can then use it for subsequent requests, or maybe just save it somewhere so that they can keep their photos or files stored in our server. Imagine that you were using something very similar to this for users of your application to send you a profile picture. That's a very common piece of functionality to implement. You would do exactly this, but instead of responding with the file URL and that's it, you would probably save the file URL into your user's model profile picture URL, and then you would use that throughout your application to display their profile picture. So you could do something like user.profilepicture URL is file URL, and then you would save that to the database, and then your users would have a new profile picture uploaded. So that's a very common thing. Similarly, if you were creating items in a store and you wanted pictures to be able to be uploaded, then you would associate those download URLs with the item that you're selling, and those pictures would then be accessible by any client once they have the download URL. Now that we've got our upload endpoint, we need to go into main.py and register it. So we'll just copy that and we'll say upload, import router as upload router, and then we will register it down here, include router, upload router. And that's it. Now we can upload photos. Make sure to add your variables to the .env file. This is the first time that we're going to need to go into config, and the B2 key ID, B2 application key, and B2 bucket name with the dev in front. You need to add those to the .env file, and then you're ready to try out the upload and make sure that those end up in backplace B2. Thank you very much for joining me in this video. I hope you've enjoyed it, and I'll see you in the next one. Hi and welcome back. In this video, let's finish up our upload endpoint by writing tests for it. So let's go over to tests, routers, and create a new file called test upload.py, and in here we're going to write some tests. Now, testing this is relatively tricky because we have a number of dependencies that you're normally not going to have in most applications. You've got a third-party API dependency that is taking files from our file system, and you've also got the file system itself, which is traditionally a pretty tricky thing to test. So we're going to have to deal with those two dependencies, because what we don't want in our tests is to check that a third party works successfully. They should test their own service. We should assume it works, and we want to test our code. So what does that mean for our tests? Well, when we upload a file to Backblaze B2 with upload local file, we're actually not going to send them the file. We're just going to assume that when we send them a file that exists, that is going to work, and we're going to get back a download URL. We're going to prevent any data from reaching Backblaze B2. The main reason is we want to be able to run our tests when we're offline, and we don't want to fill up our Backblaze B2 bucket with test garbage. So that's the first thing that we have to do. The second thing we have to do is we have to be able to have a file that we want to upload, but we don't actually want to create a picture file in our tests that we're going to quote unquote fake upload. We need to fake out the file system, tell it that a file is there that we want to upload, but the file doesn't actually exist. So those are two things that are going to be pretty interesting that we're going to deal with in this video. The first thing we need to do is go to requirements-dev.txt and add pyfakefs for faking out the file system in Pytest, and then pip install -r requirements-dev.txt. Make sure to install your requirements.txt, by the way, because we added the B2 SDK and so on earlier on in this section, so you're going to need to have that installed as well. Now that we've got that installed, we can essentially mock the file system, because we rarely want to interact with the file system in our tests because it's very slow. Let me bring in a couple imports here to test upload.py. We've got context.lib because we're going to be creating an async context manager. We'll need the OS library, and we're going to need pathlib for dealing with paths in our local file system. We'll need temp file as well, and we'll of course need Pytest and the async client from HTTPX. Let's start off by creating this fake file system and putting in a fake image inside it that we're going to fake upload. So we'll say add Pytest fixture and then sample image. And now to use the Pytest fake file system, we need to include the fs fixture. This is what pyfakefs gives us in our Pytest tests, this fs fixture. And this is going to return a pathlib path. If you've not used pathlib before and you're still using OS path for your path operations, I strongly recommend taking a look at pathlib. It's really a fantastic Python library. Now let's come up with a path to our fake image. I think a good path is somewhere in the current directory. So we can say pathlib.path and pass in dunder file, which is the path to this file, testupload.py. And then we can do dot parent, and that gives us routers. And then we can say something like assets and myfile.png. So this is a fake file that is allegedly stored inside assets folder in routers, and then it's called myfile.png. And then we can do dot resolve to get the absolute path to that file. In pathlib, you can use this / to separate path segments. So for example, assets here is a folder, myfile.png is a file because it has an extension. And then we say simply fs.createFile path. And that's it. Now in the fake file system, this exists. And we can give it to our B2 upload file function. So we'll return path so we can use that path in somewhere else. The next thing we want to do is mock the B2 upload file function. So we'll say at Pytest fixture, and we'll say auto use is true for this one because we never want to upload a file to Backblaze B2. So this will make sure that any of our tests use this fixture, even if we forget to explicitly add it to the parameters list. We'll say mock B2 upload file, and this takes in the mocker that we've used in the past, and all it does is return mocker patch, and then we pass in the store API routers upload B2 upload file. and the return value is going to be fakeurl.com. Or you could put example.com if you prefer. It's totally up to you. So what this is doing is it's going into our upload router and patching the B2 upload file in there. So if we go to our routers, you can see we've imported B2 upload file. And this is what we are patching. We're not going into storeapi.libs.b2 and patching that, because we only want to patch that in the upload router, since it's the only place where it is used. And this allows us to target that very specifically. Then the return value, instead of trying to get the download URL for the file, etc., is just going to be fakeurl.com. Now comes the tricky bit. So if you thought this was the tricky bit, just you wait. We now need to mock the AIO files open. So let me show you why. When we get a file uploaded, we are opening the temporary file with AIO files, and we are writing to it. But AIO files is actually going to try to read from our physical file system, whereas we wanted to read from the fake file system. Now, if we were not using AIO files, if we were simply using open, which is a built-in Python function, but this isn't async, so we'd have to do that. If we were using this, then that would read from the fake file system, because pyfakefs has already patched the open function when we use Pytest. But because we're using AIO files, we need to patch it ourselves. We need to tell it, hey, AIO files.open, when you run, don't actually read from the file system. You're going to read from the built-in open function instead. That does mean that our tests are running quote-unquote synchronously, but they are running synchronously anyway, so we don't care whether other things could potentially happen at the same time or not. We know that FastAPI works like that, so we don't have to test that. Let's write a fixture, Pytest fixture, auto use equal true, again, because we want AIO files.open to always read from the fake file system. We never want to interact with the real file system. We'll say AIO files mock open, and this needs the mocker and the fake file system. Then we're going to say mock open is mocker.patch AIO files.open. Now we need to say that when mock open is used, it needs to return something. So let's do that first. We'll say at context lib async context manager, and we'll define what's going to happen when mock open is called. So we'll say async file open. This takes in the file name and the mode, which is going to default to R, but we're only ever going to use it with WB in our case. Then what does open return? So we'll say out fs mock for the output file system mock of open. So this is what AIO files.open is going to return, is mocker.async mock. And we can give it a name. It doesn't matter what name we give it. Let's say async file open, and we'll say fname and mode. This just includes the representation of the file name and the mode that we used, and basically puts it all there. So if we want to inspect something, all the information's in the name of the mock. Now, this object here is what the open function is going to return. So we'll say with open fname and mode as fin. We'll say out fs mock dot write dot side effect is fin dot write. And for good measure, although we are not using it, we can also use read here. So what this is going to do is the thing that gets returned by AIO files.open is going to be an async mock, but its read and write functions are actually the default open's return value read and write functions. So basically what we've done is overwritten this file read and write methods with the default built-in open functions read and write methods. And those have already been patched by pyfakefs. So effectively what we've done is we've told AIO files that it is now using the fake file system. Now we say yield outfs mock, and then mock open.sideEffect is async file open, and then return mock open. This finishes the wire up. So when we call async with aio_files.open, then we get this executed and we return outfs mock, which is using the fake file system. So this is a pretty complicated setup here, but we need it because AIO files isn't patched by pyfakefs, whereas the built-in open is. And we actually don't need this in this specific situation at all, because you'll find that the file that we are uploading doesn't have any data in it. So this never actually runs. So this doesn't run. So therefore we don't call any method of f. We don't call write and we don't call read. So we don't need these things at all. We could just do this. If we wanted to, we could just do that and it would be fine. But in the future, if we ever do want to test it with a file that does exist or with a file that does have data, then we will need that. And so I think it's good practice to keep it in there. But if you want to simplify slightly, you can delete it until it is necessary. Okay, so now that we have this, we can go ahead and write a function that will upload a file. So we'll say async def call upload endpoint. This takes in the async client, the token that we need for authorization, and the sample image. And then it simply opens the sample image using RB. And that's what we pass to the file when we do a post request. And that is going to send all the binary data in the file, which we know at the moment is empty, but it could be there. And it's going to send it over. So then we write our test that's going to use this to check that things work correctly. So we'll do at Pytest mark any IO, and then async def test upload image. And this needs the async client again, the logged in token, which is the string, and the sample image. And then simply does response is await call upload endpoint with the async client, the logged in token, and the sample image, and then assert response. Status code is 201, and the file URL should be in the JSON of the response. So we'll say file URL is https fakeurl.com. So it should match what we defined up here. Let's see if it works. So we can do pytest-k test upload image, and you can see it passes. So that's fantastic. That means that we've wired things up correctly. When we upload a file, everything that we expected to call is being called. There's some stuff going on with the file, and that is received, and then we are calling b2 upload file, and that isn't actually sending anything to backplace b2, but we know that it is being called. This is one of the tricky bits of testing things when you have so many third-party dependencies, that you don't want to test the dependencies themselves, but then you also don't test everything as thoroughly. So it reduces confidence slightly. So something that we could have in addition to these tests is an actual system test that does upload a file, and those system tests should run less often. So your unit tests, which is what we're writing here effectively, or integration tests, don't use the third-party dependencies, but you could have some tests that do use third-party dependencies. But for that, you need a bit more setup in the way of, a separate backplace bucket specifically for testing, and you need some plumbing to do to delete the bucket contents before you run your tests, etc. So it's not something that we're going to get into in here, but you could do that if you want a little bit more confidence that things are working across the entire system. Something else that we can test, though, is to make sure that when we create a file, the file no longer exists once the endpoint finishes running. So we can check that this is called, the temporary file is created, but when the endpoint finishes, it is deleted and it's no longer there. This is something that I've struggled a bit with whether we should include this test or not, because it does feel in some way as though we're testing temp file.name temporary file. But you can execute this without the file being deleted automatically if you just say delete is false. And then the temporary file will stay. It will not be deleted, and the next time you upload something, a new temporary file will be created, and so on until your computer runs out of disk space. So I feel like it is a good idea to make sure that the temporary file is deleted after we upload a file. Plus, that's also going to let us check that this is called, a temporary file is created, giving us a little bit more confidence that things are happening in our upload endpoint. So let's write that test. We say Pytest mark NEIO and then async def test temp file removed after upload. And again, this takes in the async client, the logged in token, sample image, and the mocker fixture. Then the first thing we do is we spy on the temp file. So we'll say named temp file spy is mocker.spy temp file, which we need to import because it's been deleted. So let's go up to the top and say import temp file. Then we will try to upload our file. We'll say response is await call upload endpoint, and we pass in our async client, logged in token, sample image. We will, for good measure, assert the response status code is 201, and then that the created temp file is named temp file spy.spy return. This is what this will have returned when we called it in our upload code. And we can say assert not os path exists created temp file dot name, and we need to import os as well. And this is just going to check that this was called because we've got a return value, and that the file doesn't exist anymore because this has already finished running. So let's run those tests, and you can see one passed, so that is all good. And we can run all our tests for good measure as well. You should always do that periodically to make sure that you've not broken anything unwittingly. And everything passes, so we are good to go. We've implemented file upload using FastAPI in an async fashion with chunking, which means that we get much better performance out of our server. We're not waiting for data to reach our server. We can process other things at the same time. And to do that, we've used AIO files and the upload file with this walrus operator and the await keyword to make sure that we can do other things while waiting for data to reach us. Then we've also put our uploaded files into a third-party storage service so that we don't clog up our server and run out of disk space. So hopefully you've learned something in this section. Thank you very much for joining me. I hope you've enjoyed it, and I'll see you in the next one. Hello and welcome back. In this video, let's start working on adding images to our posts. But what we're going to do is we're going to interact with a third-party API to generate images for our posts using a background task rather than get users to upload them. We've already talked about user upload, so we're going to talk about long-running jobs and stuff like that. The first thing that we want to do in order to add images to our posts is add an image URL to our database. So we're going to go to database.py here under posts. We're going to add another column, which is going to be for image URL. And what's going to happen is each of our posts is going to get an optional image generated, and that URL to that image is going to get stored in this column. So just like that, we've got a new value in our column. And now what we have to do is remember to delete our data files. And when we start the application again, they will be recreated with this new column in them. Now let's go over to our model, post.py, and here we're going to add an image URL value as well. So inside user post, we're going to do image URL is an optional string with a default value of none. We need to import optional. So we'll say from typing import optional. What this will do is that when we turn a user post into JSON, it will include an image URL key with the value of none, unless the object that we are turning into JSON does have a image URL because it's coming from the database, in which case that value will get used. Now to test that the posts do have an empty image URL when they get created, let's go over to test post And then here in create post, test create post, we're going to add an extra value here. Image URL is none. Now what this does is it creates a post and then asserts that these fields are inside the response. Notice that this is not all the fields that the post could have, but just the ones that we're particularly interested in testing. So we're going to put image URL in there. Now let's open up a terminal, activate our virtual environment, and then run our tests. You can see all the tests pass, which means that our posts are now being returned with an image URL, which is none. In future lectures, we're going to be actually generating an image for our posts and adding the image URL here, and then we'll be able to test that is included. Thanks for joining me in this video, and I'll see you in the next one. Hi and welcome back. In this video, let's talk about generating images for our posts. Now with the advent of AI and AI-generated images, it's fairly straightforward to find a third-party service to which you can give text and it will give you an image back. Most of these services have an API, just like the one we're creating, only that it behaves slightly differently because we give it some text and it returns an image or an image URL, whereas our API takes text and responds with text. These APIs can sometimes take a little while to respond because the work that they're doing is intensive. So we have to take that into account with the way that we code. And by using async ways of interacting with this API, which we will do because FastAPI uses that methodology as well, we're going to be able to do other things while we're waiting for this API to respond to our requests. If you wanted to deploy your own machine learning model and use it with your FastAPI API, then you could do that. You just have to make sure that the way that you interact with your machine learning model is also async, so that your API can respond with an empty state, such as image URL being none, or with a valid state, such as image URL being a valid URL that your model might generate. If that's not possible, maybe you'll want to run your machine learning model in the background and then have the API update after the fact. But that's a little bit outside the scope of this course. Basically, what we're doing with interacting with this third-party API is similar to what you would do if you were running your own machine learning model. After all, that is what this API is. We're going to deepai.com and then we're finding their text to image model, and we're going over to the Cute Creature Generator API. In here, you can enter a prompt and you'll get an image back. But if you scroll down, you'll be able to see that you can also make requests to the API. All you have to do is include your prompt and your API key and make a request to this address, and you'll get back your image. You'll notice that this API key is a quick start API key. This is only going to be valid for a few requests. So after that, DeepAI will want you to pay. You can try to open up an incognito window to get another quick start API key, but again, that will only be valid for a few requests. And that is simply because making these images requires computational power and requires money. So although we can use this for learning and trying things out, we're not going to be able to use this for production. You have to pay for the requests that you do use. And that'll be the same no matter what service you're using, simply because it takes money to generate these images, so they want your money. What we're going to do is we're going to use this quick start API key to try out our code. And after that, if we want to use this in production or something similar, you know how to do it. And you can very easily switch your code over to use another service if you want, or use this one, but pay for it. What we'll need to do is to grab this API key and put it into our config file. Let's go over to config.py, and in here under the B2 settings, we're going to add deepAI API key, which again is an optional string and is going to be equal to none. Then we're going to go to our .env file and we're going to add dev deepAI API key, and we're going to put our value in there. Now we're ready to make use of this in the next lecture. So thanks for joining me, and I'll see you there. Hi and welcome back. In this video, let's interact with the deepAI API key and get an image in response. Here we're going to tasks.py and we're going to write a couple of functions. The first one is going to be async def _ generate cute creature API, and this simply takes a prompt and will respond with the JSON response. We'll do logger.debug, generating cute creature, and then just as we did for sending data to Mailgun, async with HTTPX client and so forth, we're going to do exactly the same thing. So we're going to copy that and bring in the async client. Then we will try to get the response, which will be await client.post, and then /api.dpi.org/API/cute creature generator. Then we'll include some data, which is text, and this will be our prompt. Then the headers, where we'll need to put the API key, which is config.dpi API key. And finally, we're also going to include a timeout of 60 seconds, such that if the API doesn't respond within 60 seconds, we'll just say that an error occurred. Now that we have that, we can say logger.debug and simply debug the response so we can see what's going on. Then response raise for status, so that if the API doesn't respond with a status code starting with 2 or 3, it will raise an error. Finally, we will return response.json. And here we're going to catch HTTPX, HTTP status error, and we'll simply say raise API response error, and we will give a message. We'll say API request failed with status code, and we'll put the status code there, and we'll say from ERR. And this kind of error will be raised if raise for status raises an exception because the status code started with 4 or 5. But we could also get an error in this JSON conversion, for example. So we'll say except JSON decode error or type error. And we'll need to import these. So we say from JSON import JSON decode error. And then we'll raise our own API response error, API response parsing failed. Make sure to include the quotation marks from ERR, just like that. So now we've got our error handling and we're making our request to the third-party API. So how will this get used by our code? You can see that I've already made it a quote-unquote private function because of the underscore in front. And that's because I don't think we're going to call this in our code ourselves. We want to write a function which will run as a background task. And in that background task, we're going to write to our database. And what we're going to write to our database is the image URL string. So let's go back to tasks.py, and here we're going to add our background task. So we'll say async def generate and add to post. And this is going to take in a few different values. So it'll take an email because we need to send an email notification to the user when the image is generated. We'll say post ID, which is the integer post ID to which we want to add an image that we generate. The post URL, which is a string, and we're going to send the post URL to the users in their email so that they can click on it and have a look at what the image URL is that was generated. Then we will also need to include the database itself that we want to write to. And finally, the prompt, which is a string. And we're going to have a default prompt, but you can not have a default prompt if you want to make this forced. We're simply going to put something like that. Now let's import database so that we can type into that. So we'll say from databases import database. And we're also going to need from storeapi.database import post table. Now that we have this, what we have to do is generate the image and then try to write it to the post with this post ID. Then send the user an email with the post URL. So we will say try to get a response, await generate cute creature API with the prompt. And if there is an API response error, then we will return await of send simple email, and we'll send the user an email and say, hey, there was an error generating your image. This is the email that we're sending an email to. This is the subject of the email, and now we need the body. So we'll say, hi, email. Unfortunately, there was an error generating an image for your post. Now you can see that this string is a little bit long and we've got a linter complaint. So we can put this inside brackets and then simply split this string into two like that. Black is going to reformat that into multiple lines. In Python, when you have a string immediately followed by another string, Python is just going to concatenate them and join them together. So if we reach this line 93 here, we should have a response. So we say response in there. And now we can say logger.debug, connecting to database to update post. Now, what's the query that we want to make in order to update the post? Well, we'll say post table.update, where the column is equal to post ID, and the values that we want to update is the image URL column. And this response should have an output URL field that contains the URL to the image that was generated. And because I saved earlier, we lost from storeapi.database import post table. So let's bring that back. So now let's do logger debug of query. And finally, we will run the query and send an update email. So we'll say await database execute query. We will add a debug statement to say that we finished working with a database in the background task, and then we'll send an email. Again, I'm using send simple email to this email address with this subject title and this body. So we'll say your image has been generated and added to your post. Click on this link to view it. And also earlier on, I think I forgot to add a space in front of this. There you go. You want to add a space there to make sure that these two strings are separated properly. Finally, we return response. So although this was a long function, I think it's a fairly straightforward function in that one thing happens at a time. There's no real complexity. We make a request, we get a response or deal with the errors. We define our query, we run it, and we send an update email. So this is a good idea for background tasks, is to try to keep them simple and try to log maybe a little bit more than you think is necessary, because if there is a problem in a background task, it's pretty difficult to debug sometimes. So add logging to make your life a little bit easier. The other thing that we need to add in order to make our life a bit easier and make sure this is actually working is tests. So let's go over to test tasks.py, and we're going to add a couple of tests for this. Now for these tests, we are going to mock the API that we're using. And what we're going to do is get it to return a valid output URL or get it to raise some sort of error. Let's start by adding our imports of the private function and the actual background task. We'll also need our database and the post table, and finally the database class itself. Now let's write the first test. We're going to just see that if the API responds successfully, when we try to interact with it, we get back the output URL. We'll say async def test generate cute creature API success. This takes in the mock HTTPX client. And then the first thing we'll do is set up our test with the JSON data that we want to get back. Output URL is going to be https example.com/image.jpg. And then we'll say mock HTTPX client.post.return value, just as we did up here, is going to be an httpx.response with a status code of 200, a JSON of JSON data, and the request is just going to be, as we did here, a fake request, because we don't care what the request was in this specific instance. So we're just going to put an empty request in there. So now when we do result is generate QCreature API and we pass in a prompt such as a cat, it doesn't matter what the prompt is, it should always return that the result is equal to JSON data. So let's try it out. Let's grab that test name. We'll open a terminal and say Pytest-k and put in the test name, and it should pass. But as you can see, it fails. And that's because we didn't await. Here, result equal await. You can see that the test failed because we didn't await, because you can see that we tried to compare a coroutine object, which is result, with the JSON data, which is JSON data. A coroutine object is what you get when you create a async function, but you don't wait for it to run. So that's why we forgot the await. That's what makes it run, and it swaps it from a coroutine object to the actual result. Now if we run the test again, you can see it passes. Okay, so what happens if we do exactly the same thing, but the API responds with a status code of 500 instead of 200 and some valid JSON data? Here's my new test generate QCreature API server error. And all I've done is mock the HTTPX client, but now the response has a status code of 500 and empty content. Now when we call generate queueCreature API, we should get an error, an API response error. So we'll say with pytest.raises API response error, we can say await generate queueCreature API and pass in a prompt. There is a second argument that we can pass to pytest.raises, and that is the kind of error message that should be included in API response error. So we can say match equal API request failed with status code 500. And then it will check that this API response error has this message in it, and it's not because it failed with a different kind of status code. And we want to make sure that the status code is the same and it failed for this reason and not, for example, not having a body. Let's grab that test name, open up a terminal, and pytest-k that test. You can see that it was skipped because instead of any IO, I used async IO there. That's my bad. It should be any IO. And now it passes. All right, let's do another test where the status code is 200, but the content is not JSON. So here's my test. Test generate queueCreature API JSON error. We again mock the client. The post's return value is going to be 200, but the content is just anything that isn't JSON. Now we say with Pytest raises API response error, and the match of the error message should be API response parsing failed. And then we simply call our function. So let's grab that and try to run it. And you can see that passes. Finally, let's write our test for the generating and adding to the database. This test is going to be a little bit more complicated. We'll say a pytest mark any IO and async dev test generate and add to post success. Again, this takes the mock HTTPX client, but now we need the created post. We need the confirmed user, and we'll also need the database itself, which has now been deleted. So we'll go back to the top and say from database, import database, and we'll also need generate and add to post here. So now that we've got these things, we can again define our JSON data. We're going to grab it from this test. And again, get the HTTPX client to respond with that JSON data. So again, we'll grab it from there. Now, when we make a request, we're going to get a valid output URL back. We know this because our other test passed and it is what it was testing. So now what happens when we do await, generate and add to post, and we pass in the confirmed user's email. We pass in the created post's ID. We pass in the post URL, which is /post/1, the database, and a prompt. And by the way, don't worry about /post/1 here. When we write this code in our router, we are going to generate the post URL dynamically so users can click on it. The output of this function should be that the post that has been created now has an image URL with this value in the database. So let's go into the database and check it out. So we'll say query post table dot select dot where post table dot c dot id is equal to created post ID, and we need to bring back from store API dot database import database and post table. Now let's run this query and see if it actually is correct. So we'll say updated post is database execute query. And finally, we'll assert that the updated post image URL is equal to the JSON data output URL that we got up here. Let's run this test and see if that is indeed what happens. And you can see we've got an error because this should be from databases import database. So let's run the test again. Still another error. And this error is because of something else. We've got the created post fixture that we're using here, but this fixture is actually not created in test tasks.py, and it's also not created in conftest.py. You can see we've got confirmed user in there and so forth, but we don't have created post. Created post is actually only created in here inside test post.py, which is not a conftest.py or in the same level as test tasks.py. So if we want the test tasks.py to be able to access created post, we need to move this fixture to this conftest.py there at the same level as test tasks. Fortunately, it's pretty easy to do. All we have to do is grab this fixture and move it to conftest.py. But this fixture calls createPost, which is a function that lives in here. And I'm pretty sure that this function is also called in a few other places in our code. Yep, down there. So we can't just move this function to conftest.py and leave it there. We are going to have to go into our tests and create a helpers file where we store these functions. And then we will move these functions over there, import them in here, and then move the fixture to conftest.py and use the helper function there. So let's do that step by step. First, let's go into tests, create a new file called helpers.py, go to test post, grab the create post, create comment, and like post. I'm just going to grab the 3 because I feel like these should be all together since they basically do the same kind of thing. And now we're going to add our HTTPX async client import in here so we don't get any errors. And now we can import the helper functions. So we'll say from store API tests helpers import create post, create comment, and like post. So now this file works. And we can do exactly the same thing when we move created post over to conftest.py down here. I'll bring in created post down there and I'll cut these imports and just move them to the top, making sure that this is decorated with this no QA and we only need create post, so we'll get rid of the other 2. Then we can go back to test post and get rid of this created post fixture. We only want it to exist in one place and we want these tests to use the one that's defined in conftest.py. You might also be tempted to move created comment over to conftest.py, but I am torn as to whether that's a good idea or not. I feel like the fixtures should be at the highest level possible in our hierarchy. And because created comment is only used within this file, I don't really want to move it and make conftest.py massive. I want to only put in conftest.py the things that we really need to be there and everything else kind of hide away where it is needed and not in a very global file. So that's why I'm not going to move it there, but if you prefer moving it there and having your fixtures in conftest.py, then feel free to do that. I think it just makes things a little bit more messy, although it does make things a little bit easier to find as well. So it's up to you. So now that we've got that, we can once again run our test. And now we've got another error. So let's go over to test tasks.py and we see that database.execute query is giving us an error. And that is because I've made a silly mistake. Instead of database.execute, we should use db.execute. And we don't actually need to import database up here at the top. And we've got our error. You can see it here. It's inside tasks.py. Here we're using database.execute. We're getting database from our arguments. And we pass a value to database here, which is db. db, if you don't remember, it was a while ago that we wrote this fixture, is this fixture here, asyncdefdb. And you can see that we have yield, which is correct, but we are not yielding anything. So if you use the fixture in one of your tests, as we do up here, its value is actually none. We want to return the database that we've connected to. So we'll say yield database, and now we connect to the database, give it back to the code that's going to run if it gets used, and then disconnect. So now db will be the database that we've connected to, and we can use it in here and use it in there as well. So now let's run our test. And we can see it fails because we forgot to, or I forgot to await db.execute in there. Okay, so let's run it again. We have to make sure that instead of db.execute, we use fetch1, of course. Yay, finally the test passes. So this is a pretty common thing that you're going to find, and it's why writing tests is good. Now you start writing tests and then you start noticing small issues and errors that you maybe didn't realize or forgot about. So we've done quite a few fixes in order to get this test to pass, which is great. We fixed an error there. It's actually correct in my notes. I just didn't copy it correctly. This should be fetch1. We forgot the await and we added it back in. We didn't have yield database in our fixture. We've added it in now. We've also moved a fixture to conf-test.py, and we've created a helpers set of functions so that we can import them anywhere in our tests. So quite a few changes to the tests. Everything is going to be detailed in the code for this lecture, so you can take a look at that. I know this was a little bit confusing, but now everything is passing and we've got our tasks all working, so we are good to go. In the next video, we're going to work on our router, and we're actually going to generate an image when we get a prompt sent to our create post endpoint. So thanks for joining me, and I'll see you there. Hi and welcome back. In this video, let's go over to our post router, and we're going to allow users to send us a prompt when they create a post. And if there is a prompt, we're going to use it to generate an image and store it alongside this post. So we need a couple of things. We need to get the background tasks from FastAPI, so we'll import background tasks, and we also need the request because we need this in order to access the prompt, which is an optional argument. Then when we go to create post, we're going to add a couple of new parameters to this function. We're going to add background tasks, which is going to be the background tasks. We need the request, which is request, and we also need a prompt, which is a string and whose default value is going to be none. Now, because this prompt is a string and not a Pydantic model, it's going to be assumed to come in the query string arguments to the request. But if it isn't included in the request, then it's just going to be none. Now, after we create the post, we're going to launch our background task that will generate the image using that prompt if it exists. So we'll say if prompt, then background tasks dot add task generates and add to post. We need to import this, so let's grab that and say from storeapi.tasks import generate and add to post. Then we'll go back down here and we have to pass in a few arguments to generate and add to post. So let me just break that down like that. Remember that when you add a task using background tasks, the first argument is the function that you want to run. Every subsequent argument to add the task will be passed to the function that you want to run. So we'll say current user.email, last record ID, which is the post ID. And then we need to generate a URL for users to click on to see their post in their email. And how do we generate a URL to a FastAPI view function? Well, we can say request.url4 get post with comments and pass in the post ID, which is last record ID. Get post with comments is the name of a function that we've got down here. That is the name of the function that you want to generate a URL for. That is how you do that. Request.url4 and pass in the name of the function and any arguments it needs. Then we need to pass in the database and the prompt. And that's it. We've got our task started. So when we create a post, if we pass in a prompt, the image should be generated. And then we'll get an email to tell us that the image has been generated successfully. Now let's go into tests, routers, test post. And here we're going to create a fixture that will prevent the generate queue creature API from running. We'll say mock queue creature API, that's a fixture, and it simply returns mocker.patch of storeapi.tasks._generate queue creature API. We've got tests for this function, so we don't need to actually run it in our code. We can simply rely on it to be correct because we've already got our tests that verify its correctness. So we can simply say that whenever we call this function, we will get back a valid output URL. And I'm actually going to put image.jpg in there just to make sure that it is an image and not just a URL. And with that, we're going to write a test that will check that when we create a post and it has a prompt, an image is generated for it. So maybe here under test create post, we can add our new test. So again, Pytest mark any IO, and then we'll say async def test create post with prompt. This takes in the async client, the logged in token, and the mock generate queue creature API fixture. Then we will try to get a response by creating a post. So we can just copy it from here. But we want to make sure that as well as sending this data, we pass in the query string of prompt equal a cat, or whatever it is that you want to test this out with. Remember that this is not going to get sent to the API, so it doesn't actually matter what you use. Then we will assert that the response status code is correct. We will also assert that the contents are correct, but we no longer need to test the user ID. We don't really care about that. We do want to make sure that the image URL is none, and then we want to say mock generate queue creature API dot assert called. And this is the key thing here. We want to make sure that we did call the mock, and therefore that means that the background task ran and it tried to interact with the third-party API. Let's grab that post and run it. And you can see it passes, so that is very good. We know that we try to interact with a third-party API, and we know that when that happens, things are working correctly. Finally, we do want to actually run this and test it out, see if we do get an image. So we'll say unicorn --reload storeAPI.main:\app, and we'll start this. And now we can interact with it using Insomnia. So I've gone ahead and registered and confirmed my email. Then we are gonna grab a token. There we go. And now we're going to try to create a post, but we're gonna pass in a prompt. So we'll say send, and you can see that we instantly, within 44 milliseconds, got back the body, the ID, and the user ID, and the image URL is null or none in Python world. This is very fast, so there's no time for this to have interacted with a third-party API. So now I'm just waiting for an email to tell me that this actually ran. And in the meantime, we can look at our logs, and we can see that the task did run, and we even sent an email. Here's my email. You can see that we have ourselves an image URL being generated. We can copy it and go on it, and you can see that we've got our image in there. This API seems to generate 4 different images, but obviously you could use a different service that generates only 1. And it also says they are cute creatures, but they are more creepy than anything. Anyway, this is how you interact with a third-party API that is long-running, and how you can use emails to keep the user in the loop while still having your API respond instantly as needed. So thank you very much for joining me in this section. I hope you have enjoyed it, and I hope you've learned a lot, and I'll see you in the next one. Hi and welcome back. Now that we're ready to start deploying our project, it's going to be important that we update the project to Pydantic v2. Now, throughout the course, I've already updated all of the code and the videos to use Pydantic v2, but actually in the background I've been recording the course using Pydantic v1, just because that's how I started recording, so I wanted to just keep the same style throughout. But in this video, I'm going to quickly show you what changes you'd have to do to go from Pydantic v1 to Pydantic v2, just so that we make sure that we are using the right one. Now, it's going to be very straightforward, and if you've been following the course from the moment that I updated it, you'll already be using Pydantic v2. There's nothing for you to change, but if not, you're going to learn how to do the update. The first thing we need is to go into requirements.txt and install Pydantic-settings. This new library encapsulates the base settings and that kind of thing that we've been using in Pydantic. So we'll install that. We'll say source VM bin activate and install the requirements.txt. And something that we will want to do as well while we're doing this is make sure to upgrade our packages, because at the moment I'm using an older version of FastAPI and Pydantic. What I'm going to do is I'm going to upgrade every package. So we can do pip install --upgrade -r requirements.txt. This is going to try to upgrade all the packages. And there we have it. We've upgraded all of our packages and we've installed Pydantic-settings. So now we can go to config.py, and I'm just going to close this terminal because we don't need it anymore. And we're going to change a couple of things here. Instead of importing base settings from Pydantic, we're going to import from Pydantic_settings, and we're also going to import settings config dict. Then we're going to get rid of the class config because this is no longer a thing in Pydantic v2. So we're going to get rid of that. I'm going to say model_config is settings config dict, and the env file is .env. This does exactly the same thing, but we no longer need the inner class. Instead, we use this model_config attribute. In these models down here, we're going to do the same thing. So instead of env prefix here, we're going to say model config is settings config dict, and env prefix is dev. And we'll do the same thing with prod and test, making sure to change the env prefix at the end. Now there's one more change that we have to do to our configs, and that is inherited properties such as this database URL. You can see was typed in the parent class. It's an optional string, but down here in test config, it's not typed. Now we have to type inherited properties using Pydantic v2, so we'll simply say string and bool. There you go. That's the changes that we need to do to our config file for Pydantic v2. Now, there are a couple other changes we have to do. So let's go over to our models and go into post. Now, we have to get rid of the class config in here. So we will import config dict from Pydantic. Because none of these are settings related models, we do import from Pydantic. And instead of settings config dict, we import config dict. We can now get rid of class config and we'll say model config is config dict. And we will say from attributes is true. Instead of ORM mode equal true, now we use from attributes equal true. We'll do exactly the same thing on here and in here. But I like putting these model configs at the top. I think that's a little bit more readable, easier to see what's going on. So I'm just going to move them up to the top, and that's it. That's the change that we have to make to our models for Pydantic v2. Now we're going to do a global search and replace. So pressing Command Shift F or Control Shift F if you're on Windows, we're going to look for .dict, open and close bracket. And we're going to make sure to not include the .venv. So we'll delete that. And in our post.py router, you can see that in 3 different lines, we've used post.dict, comment.dict, and like.dict. Now to do a global search and replace, you can just open this up here and then change this for .model_dump, open and close bracket. And VS Code shows you here what the change is going to be. For these 3 files, you're going to swap .dict, open and close bracket, for .model_dump, open and close bracket. And we want to make that change because Pydantic has changed the naming of the function used to turn a model into a dictionary, and it's no longer called .dict. So to change those 3 lines, you do them one by pressing this replace icon, or you can do them all at the same time by pressing replace all, and then you get a wee dialog that asks you if you're sure, and we are. Oh, and I almost forgot, back in config.py, we have to add an extra ignore. This was the default behavior in Pydantic v1, where if you had any extra environment variables in the .env file, that would be fine, they would just get ignored. But in Pydantic v2, the default behavior is that if you have any extra environment variables, then that will raise an error. And the reason why that's a problem is because our .env file may have development, test, and production environment variables, and that will raise an error. And also, when you create the base config object, because we want to get access to env state, it's going to load the .env file, but it's only going to expect env state to be in the .env file. All of the other environment variables, like your dev database URL and so forth, will cause an error at this point. So you have to add extra equal ignore. And we're going to do the same thing in all of these other ones. Just to make sure that we are compatible with Pydantic v1, we have the same functionality as we had there. And that's it. Now we've upgraded our application to Pydantic v2, we can go ahead and deploy this to render.com, which we're going to do in the next video. Thanks for watching, and I'll see you there. Hi and welcome back. Now that we've learned about Git and how to use it, we're going to put our FastAPI project in GitHub so that we can then deploy it using render.com. The first thing to do is go to GitHub and create a repository for the project. You can leave it public or private if you like, and you don't have to add a git ignore or license or anything else. Now that's created, you can see in here there are a few instructions for setting up your repository locally. So let's go over to Visual Studio Code and run these commands. Here we've got the project open, and the first thing to do is to git init, and that's going to initialize the empty repository. Then we're going to make sure that the .gitignore file contains everything that we want to ignore and not include in the repository. And really the main thing is a .env file. We don't want our secrets to become public and be shared on the internet, so we want to make sure that's not going to be added to the repository. Then I can see that Pytest cache is not grayed out, so that's not in here. We're going to add it in there so that it is grayed out, and we're not going to include the cache in our repository. Then let's have a look at the contents of the project, and you should see that every file is green because we want to include it in the repository, and the grayed out files are not. Here's a log file, and we want to avoid that, so we'll do star.log so that it's not included in the repository either. Everything else is good to go. So we can do git add dot to add everything in the current folder, and then run git status to make sure that everything that we want to include is indeed going to be included. Now we can run a commit. We can say first commit, and then we will run git push -u origin main. And there you go. Now the code will appear here on GitHub, and you can see that it is there. Now we can go over to render.com and create an account and link your GitHub account with Render. Then you can go over to new, create a new web service, and we're going to find here our FastAPI project. So you can see it's there. We're going to connect. And what this does is it allows render.com to download the contents of the FastAPI project and then run it. You can see that render.com has detected this is a Python service. We've got our requirements that we want to install, and then to run our application, we're going to do uvicorn storeapi.main app. Now, render.com does have a free plan, so we can use that to test out our application. But later on, if you want to deploy this and share this with users, and you actually have users that are using your API continuously, then you'll want to start paying for it because you get a lot more performance out of that. Finally, the last thing we want to do is open up the advanced tab in here, and we want to add our environment variables. That's everything that we've got in our .env file. Because we didn't put our .env file into GitHub, render.com doesn't have access to it, and all of these values will not be given to render.com, so we have to give them it. Something I like doing is defining a section in the .env file for production. So we can copy that, paste it in here, and just swap it out for prod. And now we can write in here what the environment variable values would be if we were in production. But whenever we are working locally in development, we're going to keep env state as dev, and therefore we're going to use these values here. But when we go over to render.com, we're going to change the env state to prod, and then we would use these values here. For now, let's leave it as is. So what I'm going to do is grab everything in here, copy it, then go back to render.com and add a secret file, which I'm going to call .env. Then we're going to paste all the contents in here, and we're going to go to the top and change this to prod. Now, these are the values that will get used, which are identical to these, but we're going to change it later. We're going to grab a different database in just a moment. So let's save that. And now this .env file will be accessible at the root of the project. Now, upon saving, we start deploying. These are the logs for what render.com is doing, and in a free service this can take a little while, so just bear with it for a moment. You can also see that it's using Python version 3.7.10. That's the default version, but we can change that. To change the Python version, we can go to environment, and here we're going to add an environment variable. That's going to be Python version, and we're going to do 3.11.5. We should also add another environment variable called port and set it to 8000. This is what render.com is going to use to connect to our FastAPI app, and we have to give it the port number that the FastAPI app is going to be running on. We also need to modify the run command to expose the app and make sure it runs in the selected port. So once the project is deployed and you can see it is live, then we can go over to Insomnia and try to register a user. Then we should get an email that we can confirm. Once we confirm the user, we can grab an access token. And then we should be able to create a new post. So we should be able to hit send and get a response. But I think there's a small bug in Insomnia just now, and the variables in the environment are not working. So I'm just going to copy the access token for now, and hopefully this will work when you're doing it. I'm going to paste it in here. So now we're going to be sending the bearer token like that. And let's hit send again. And we get our response. And now we should get an email in the moment when the image is generated. But what we can also do is simply get the ID of 1, then go to post 1 and see if it got an image URL, which it doesn't so far, but now it does. So you can see that our application is now working and it is deployed, so it is publicly accessible. That's it for this video. Thank you very much for watching, and I'll see you in the next one. Hi guys, and welcome back. Now that we've got our application deployed, it's time that we add a proper database. And SQLite is a great database if your application is doing mostly reads, but it's maybe not so good for an async application if you're doing a lot of writes. So for a REST API, SQLite is probably not the right choice in most scenarios, but PostgreSQL could be the right choice. To get a free PostgreSQL instance so that you can try out the PostgreSQL connection and so forth with your application, I recommend using Elephant SQL. Later on, if you want to upgrade and improve the performance of your database, you can also do that with Elephant SQL. They have pretty fair pricing. Or once you've tried out PostgreSQL and you're happy with it, you can also use render.com to get a PostgreSQL database. Render offers free PostgreSQL, but it's much more limited than the free offering from Elephant SQL. So that's why I recommend using this if you are after a free instance. Anyway, let's create a new instance. You'll have to sign up and make your account and all that, but you don't have to give them any payment details. And you can call it FastAPI course project or whatever you want. And the plan is going to be the free plan. You can tag your projects if you want to be able to search through them a bit more easily later on. Then you'll select a region. You want to find a region that is in the same region as your render.com service so that the communication between your server and the database is fast. You can see that my render.com service is here in Oregon, so we're going to do the same thing in Elephant SQL. Here in this dropdown, let's find Oregon or similar. So this is US West. Let's find, for example, Northern California. I'm guessing that's nearby. My geography is pretty rusty, so I couldn't tell you for sure. But in a production application, you want to make sure that they are in the same data center or very close by. And also, when you make a production application, you'll likely be replicating your database. So you'll have the database in multiple data centers so that if one of them fails or there's a fire or whatever, your application is not going to be impacted. But we're not going to do that in this course. So there we have it. We've created our database and we can click into it, and then we've got the URL. So we're going to copy that and then put it in render.com. Open up your project, then go to environment, and then here in the .env file, go to prod database URL and put your database URL. But something that you do want to change is this Postgres. Here, you want to make sure it says PostgreSQL. This is the new way of defining PostgreSQL connection URLs. Postgres is like the old way, so I don't recommend using it, and you may encounter some errors if you do. So just change it to PostgreSQL and then hit done and save the changes. This is going to trigger a new deploy for an updated environment, and we can see how that goes once it's deployed. After deploying, you may encounter this error, no module named psychopg2. And that's because all this time we've been working with SQLite and we've not installed the dependencies that we need to work with PostgreSQL. So let's fix that, and we also need to make a couple of small changes to our database code as well. Here in our requirements file, we need to add psychopg2, but you may struggle to install psychopg2 locally in your computer doing pip install. So if you do find an error, just install psychopg2-binary instead. But I would keep psychopg2 in your requirements file because it's better for render.com to have that when it installs requirements. Then for the databases module to work with Postgres, we need to add databases async pg. And what that's going to do is it's going to install any dependencies that the databases module needs to work with Postgres. And it's going to do that by using the async pg library. It's okay to have this seemingly duplicated there. All the requirements for the databases module will be installed here, and this one will only install any extra requirements that you need for PostgreSQL. So let's save that and now go over to database.py. We have to do a small change here as well. This checkSameThread connection argument is only usable for SQLite. So we're going to cut it out and we're going to say connect args is equal to checkSameThread false if SQLite in config.database URL. Otherwise, we're going to use an empty dictionary. And then we're going to pass connect args in there. You could do other if statements here. For example, checking whether the config is a prod config, as we've done in logging conf, like that. But this gives you a little bit more flexibility to use SQLite in production if you want, or use PostgreSQL if you prefer. There is one more set of changes that we need to do to work specifically with Elephant SQL. And that is, we have to limit the size of the connection pool. When we use the databases module, it creates in the background a connection pool of connections to the PostgreSQL database. When one connection is needed to read some data or write some data, it will grab one from the connection pool. But because the databases module works in an asynchronous fashion, it's possible that multiple different connections are in use more or less at the same time. That is why it uses a connection pool, so it can work asynchronously. But Elephant SQL has a limitation on the number of connections that we can have open simultaneously. You can see here the free plan is limited to 5 concurrent connections. More expensive plans have more connections, and if you go to a dedicated instance, you can have hundreds of connections potentially. This may look very expensive if you've not hired a database server before, but it's actually not all that bad. So if you want to squeeze a lot of performance out of your database server and you need a lot of storage space, you'd probably go for one of these dedicated instances, and then you wouldn't have to worry about the connection pool size. But because we're using the free instance, we do have to worry about it. Connections in the connection pool are kept open so that they can be reused very quickly without having to reopen the connection. So we have to have a minimum number of connections in our pool and also a maximum number. You can simply pass min size equal 1 and max size, let's say 3. You don't want to get to 5 because if you do, you won't be able to connect to your database using third-party software. If you wanted to simply connect to look at the data that's there, you wouldn't be able to do that if you set to 5 because then all your connections would be in use. So that's why we're going with 3. You can just do this, but the problem is that this doesn't work for SQLite. So we have to only pass these arguments if we're using Postgres and not pass the arguments if we're using SQLite. So we're going to do something very similar to what we have up here. So I'm going to copy this dictionary. I'm going to say dbargs and paste the dictionary in there, but we're going to pass in min size 1, max size 3 if Postgres in the database URL, otherwise nothing. And then we can simply pass ** dbargs in here to pass these as keyword arguments. This looks a little bit ugly and you can do it differently. You could argue slightly better. You can pass min size and max size as query string arguments in your connection string. So if we go to our .env file and we've got our connection string here, you can at the end of your connection string put min size equal 1 and max size equal 3. But the problem with this is these are non-standard arguments. They are only used by the databases module. They are not used by SQL Alchemy. So you encounter an error if you try to do that while using SQL Alchemy. So what you can do instead is not call metadata.createAll and instead create databases using encode databases. That is more complex. It's actually more complex than simply doing this if statement. So that's why I've opted to go for this. If you wanted to take it a step further and you didn't want this dictionary here, and you also didn't want to create your tables using encode databases, you could use a database migration package such as Alembic to create your tables. So now that you've got that, you can do git commit -am and update code to work with PostgreSQL. Then remember to push your code and that will trigger another deploy in render.com. So let's go and have a look at that. Once your deploy succeeds and you see live in there, you should be able to go to Insomnia, register a user, and confirm the email address, get your access token, and everything should work as normal. That's everything for this video. Thank you very much for watching, and I'll see you in the next one. Hi and welcome back. In this video, let me tell you about Sentry, which is a tool I use in my own websites to detect errors and get a little bit of help fixing them. First of all, go to sentry.io and get started creating your account. And then once you've created your account, or you can sign up with GitHub, which is what I've done, you can sign in. Once you've signed in, you'll probably go through some sort of quick start where you'll create a project. And if you are happy to do that, then go ahead and create your project, making sure to select a Python project. But if you haven't done that, you can simply go to your projects and click on Create Project. And then here we're going to select FastAPI. For now, for the alert frequency, we're going to alert us on every new issue, which means that whenever Sentry detects an error, it's going to send you an email. Then you can name your project. If you don't have multiple teams like I do, that's fine. Just leave it on your default team. I have two teams because one is what I use for my actual projects, and this team is for my courses. So here we can call it FastAPI 101 course project, or whatever you want to call it, and hit create. Then it gives you some very nice instructions. So let's go through them. First, we're going to add this to our requirements file. So go ahead and in your requirements.txt, just add Sentry SDK FastAPI, and then make sure to activate your virtual environment and install the requirements. Then we need to initialize the SDK before we start our application, and really hopefully before we do anything. So all we have to do is import Sentry SDK and then do the init, and make sure to include your DSN, which should be a secret. So we're going to grab this and put it into our .env file. So let's go to .env. I'm going to say dev sentry DSN, and we're going to put that in there. And similarly, prod sentry DSN, and we're going to put that in there. For now, it's the same one. You could create two different Sentry projects, one for local and one for prod, but Sentry actually can detect whether you're running locally or not, so it's not really necessary. Then let's go over to our config file, and we're going to add the Sentry DSN. So we'll say here, Sentry DSN is an optional string, which is none. Now let's go to main.py, and just before we do anything, we're going to import Sentry SDK, and then we're going to run this code here. I actually recommend copying the comments for now, just because it gives you a little bit of information, and later on, you may want to change these numbers. It's good to know what they mean. Basically, traces sample rate is going to capture this percentage of transactions for monitoring performance. Sentry is going to charge you based on how many transactions you record. So by setting this to 1.0, you're going to record all the transactions in your application. And if it turns out that you have too many transactions and you're getting charged too much money, you can turn this down. The trade-off is if you turn this down and there is a performance issue in a transaction that it just so happens you didn't record because the transactions are recorded randomly, then you're going to miss out on some data. But by turning this down, you're still going to catch some transactions, and if you have enough of them, that's still going to give you enough information to know what's going on. So the traces sample rate lets you modify how many transactions are captured for error detection. Profile sample rate lets you modify how many transactions are captured for performance profiling. You can adjust those independently. Let's copy that. And then down here, we're going to do that. I'm actually going to move it just above the logger. I like that a bit better. Then hit save. And instead of using this DSN here, we're going to do config.sentry DSN, and we're going to say from storypi.config import config. For now, let's leave it at 1.0 so we don't miss any transactions. At this stage, when we're still implementing it and trying it out, if you start missing transactions, you may not realize if it's because there's a problem with the setup or Sentry just decided to skip that transaction. So let's leave it at 1.0 for now. We can adjust it later on if it turns out that you need to adjust it. And here it tells you how you can verify your Sentry installation. Simply add a FastAPI endpoint that will always trigger an error, and we can do that just by doing this. I'm including this return here because if not, this would get deleted by the linter. Yeah, this is that. And now we can simply run our application and see if this raises some sort of an error. So we've started our application. Let's go over to Insomnia and trigger this and see if something appears in Sentry. So I've created this endpoint here in Insomnia and we can hit send and you'll see the internal server error. So now we can go back to Sentry and take me to issues. And you should see here that there is an issue that appears. It can take a few seconds or up to a couple minutes for the errors to appear, but when they do, you should see this one. This second error is actually caused by Insomnia in a way, because Insomnia will automatically try to generate an authentication token to send with the requests, because we've set it up that way in the environment, but the details that I've got in Insomnia are not valid, so you end up getting an error in /token. But let's ignore this error for the time being and focus on zero division error. You can click into it and then you get a lot of information and it can be a little bit scary, but there are a few important things to pay attention to. The first one is the URL. You can see here that we were running locally. Then you've got your stack trace, which is really the main thing. It tells you where the error happened and it lets you see some code around it. And then it also gives you some breadcrumbs here for what happened in the application before the error occurred. You can see some more information in the headers sometimes, such as the request ID. You're going to use this to look in your logs for more information. Finally, here on the right, you can see how often this issue occurred in the last 24 hours and in the last 30 days. And this can tell you if it's a one-off or something that, is actually recurring and you have to pay more attention to. There's a lot of information in Sentry, and as your application grows, you're going to be paying more attention to what's going on here, and you might also look at performance analytics and stuff like that. But for now, what we should do is go and fix the issue and then hit resolve. So we could come into our application and delete this endpoint, save that, and now this error is not going to happen again, so we can hit resolve. And that's it. This issue doesn't really go away, but it is marked as resolved and it will only reappear in your issues if the issue happens again. So that's the very basics of Sentry, and I like enabling it for all my projects because then when an error happens in the code while the project is deployed, I'm going to know about it. So the next step would be to commit this code and push it over, deploy it to render, in making sure that we include our Sentry DSN in the environment variables of render.com. So that's everything for this video. Thank you very much for joining me, and I'll see you in the next one. Hi and welcome back. In this video, let's take a look at how we can automatically run our tests when we push to our main branch in GitHub. Let's go over to Actions in our GitHub repository, and then we're going to find Python application, and then click Configure. Now, this will look a little bit scary, but what this is a YAML file that configures how a GitHub runner is going to do something when we do something in GitHub. That's very abstract and very vague, but you have a lot of flexibility as to what it does and when it does it. So here's when it's going to do something. Whenever we push directly to the main branch, or when we start a pull request against the main branch. If you're not sure what pull requests are and you don't use them, don't worry too much about it. But if you do, or if you work with other people, then you're probably going to be using pull requests. So this lets us run the tests whenever a pull request is made against the main branch. The permissions here tell it that it can read the code in our repository, but it's not going to modify the code. And finally, you've got the jobs. So you've got the build job. It's going to run on Ubuntu, and I would leave it as is because Ubuntu is pretty much the most popular operating system that you can use. And then you've got a list of steps. In YAML, each step uses this listic notation, and then you can either tell it to use an existing workflow, such as this actions/checkout v3. This is going to clone the repository inside the Ubuntu runner so that it can access your code. Or you can say name and then give it a name and then uses with a third-party workflow. This one just installs Python 3.10. You can modify the Python version. And also there are ways to run this in multiple Python versions, so you can run your tests in multiple versions if you want to do that. We're not going to look at how to do that in this course, but it is possible. And finally, you can also give it a name and then give it some bash code to run. Here with the pipe, we can then define a multi-line string. And what it does is it runs this command, then it runs this one, and finally it runs that one. First it's going to install pip, then it's going to install Flake8 and Pytest, and then it's going to install the requirements. We haven't been using Flake8 in our code, so I'm going to get rid of Flake8 just now. We have a few more requirements that we want to install, so instead of pip install Flake8 and Pytest, we're going to do pip install -r requirements-dev.txt. Remember that by this point in the workflow, the runner has access to our code because it's already checked out and downloaded it. So we can access the requirements-dev.txt file. Then if there is a requirements.txt file, which there is, we're going to install it. But we can leave this using the if statement, or you can simply get rid of it and just keep pip install -r requirements.txt. It's up to you. Then there's a step here, lint with Flake8, but we use rough. So we're going to change this to lint with rough. And then all we have to do to lint with rough is actually say rough and then the period. That's going to lint every file and every directory in our application. Finally, we're going to run our tests here with Pytest. All right, once we're happy, we can commit the changes and we can give it a message. And now for the sake of trial, let's create a new branch for this commit and start a pull request. And you can give the branch a name. I tend to give it my name and then / and then what the branch is for. Then we can propose those changes and I'll show you what the pull request flow looks like. We're just going to click on create pull request. And now you can see that our changes are asking to be merged into the main branch, but first we have to run our build step, which is the thing that we've just added. And so that is now doing that. It's going to clone the repository, install the dependencies. You can see that's happening here very quickly. Then it's going to lint with rough, test with Pytest, and then clean up. And if everything passes, it's going to say, okay, you can merge this pull request into your main branch. As part of a pull request, when you're working with other people, you'd normally also review the code, make sure that it is correct. First of all, it does what you want it to, and there's no issues that you can see. And also if there are any improvements or extra learning that you can share with the original author of the pull request, you would also suggest those things when you review the pull request. So you can see that we've got an error. I knew this was going to happen in the linting step. There's only one linting error and it's in logging conf.py. Line 54. The line is too long. So let's have a look at that. We can go here to logging conf line 54, and you can see it's a little bit long in there. Something that we can do is we can disable rough for this line because we don't want to break this line up. So just by hovering over it, clicking quick fix, you can see disable for this line. And again, that's going to do a no QA E501. We would also have some more rough errors. I think it's in our tests. Yeah. Here, the E402, these would fail if we didn't have the no QA added in there. Now that we have done this, we can open up our console and do a commit. Linting error by disabling on long line. Now, I was about to commit this, but I've remembered that we are on a new branch in our pull request, so we want to commit this change on the pull request branch. So let's first do git fetch to bring the branch information, and then we'll do git checkout Jose and figure out what branch this was. Add lint test workflow, and we can do git add story pi logging conf.py, and we'll commit this. We'll say fix linting error by disabling on long line. And then we'll push. Now automatically our pull request will receive this new commit and the build step will rerun. You can see it's rerunning because of the orange dot over there. If I refresh the page, you'll see it's rerunning down here as well. Let's go back into it, click on details to see what's going on, and you'll be able to see that it's installing the dependencies. And again, a lot of output in here, but it lets you debug if something were to happen with the setup stage. There you have it, the linting step now passed, and now we're running our tests. You can see the wee dots there to tell us that the tests are passing, and everything should pass. And there you have it, all ticks, so we're good to go. We got the green tick in our pull request. We can go back and you can see the green tick in there, the green tick in there, everything's green. So we're good to merge this pull request into the main branch. And when you do that, you're going to trigger a deploy in render because you're adding a commit into the main branch. Something that you can also do once you merge your pull request is delete the branch that you've merged, because you're no longer going to need it and you're not going to use it for anything else. I'm not sure if this shows up in GitHub by default, or maybe I have an extension that adds this, but in any case, you can delete the branch. And that's it. This is how you set up your GitHub workflow to run your linter and run your tests so that you can see it before every pull request. And also it will run whenever you merge a pull request or whenever you make a commit to the main branch. So now you're getting another build step here, which will again do the same thing. You can also do different things when you merge into main versus when you do a pull request. For example, you could trigger a deploy when you merge, but only run the tests when you make a pull request. But because render already has automatic deployments, we don't need to do anything different. Thank you very much for joining me in this video. I hope you've enjoyed it and you've learned something new, and I'll see you in the next one.